Welcome to the Ultimate JavaScript Game Dev course. In this course, you will first learn the basics of JavaScript so that you can make games with it. Then we will move on and I'll teach you how to make a Sonic themed infinite runner. Once this is done, we will step up the difficulty a bit and work on a much bigger project, a JavaScript Metroidvania game. So a Metroidvania is like a platformer, but instead of having levels, you explore one single world. Once this is done, I will teach you how to make desktop games in JavaScript using a technology called Tauri. So you will be able to package your JavaScript games as desktop PC games that you can install on your computer. And that will be the end of the course. Thanks for watching and subscribe for more content like this. Hi everyone. Welcome to this crash course where the goal is to teach you how to program in JavaScript so that you can start making games with it. So as opposed to all the crash courses you find on YouTube on learning JavaScript, they usually teach you JavaScript with the intent of making websites and working in web dev. Now here it's different because I'm teaching you the bare bones of JavaScript so that you can start making games, and then you can start even watching my previous tutorials, which all assume that you have a basic understanding of JavaScript. Now, why learn JavaScript for making games? So that's a good question you might have asked yourself, and yeah, I'm here to answer it. So JavaScript is a very accessible language. It's a very sought after skill. That means that with JavaScript you can work as a web dev, so why not use the same knowledge, same tools to make games, and especially web games. So games that can run on the web without having to download or install anything. And that's the first advantages of web games and using JavaScript for making those games is that you don't have to install anything as a player, which reduces the friction. It's especially an advantage in game jams and especially an advantage when you're a new game developer trying to build your reputation. So by making a bunch of smaller web games, you can not only build your skill as a game developer, but also more easily amass an audience or potential players. Now, the advantage of doing this in JavaScript is because JavaScript is the lingua franca, I think that's how you say it, of the web. That means that when you make your game in JavaScript, things load fast and are snappy. So if I press, this is a game I made, a Pokemon style game, I made in JavaScript. So I have even like 60 FPS, etc. So yeah, if you were to make the same game in Unity, which has a web export, it's usually bloated, very slow to start. I had only bad experiences playing Unity games on the web. Now, the other advantage of using JavaScript to make games is that you're not stuck on the web. So if you want to make a game on Steam, you can relatively easily transfer your game, convert your game into a desktop application using Tauri or Electron or some other technologies. I have a tutorial on my channel teaching you how to make this, how to do that, to have a game that is written in JavaScript but works on desktop. A prime example of this was Vampire Survivors, which was a very popular game on PC, which was a web game that was transferred into an Electron application. So you can have PC game, you can publish your games on Steam. So that's another advantage without having to change your tools. You can also do the same thing for mobile. So with one language, JavaScript, you can make games for the web, desktop, and mobile. Now the only missing part here is the consoles, and for consoles I don't worry much about it because if you can make a very successful game on PC, usually it makes business sense to just pay a porting house to port your game to consoles. So as an indie developer, you really should be focusing on making a great game, and if you want to make money, usually you have to go to Steam to do that, and you can do that with JavaScript. And I would say the last advantage is the transferable knowledge you have with web dev. So imagine you're a new developer, you just started out, you wanted to learn programming, and you learn JavaScript and you realize like making games is fun, but I would not be able to make this a sustainable career or something like that. Well, the tool, JavaScript, the language you learned, is actually useful for making web applications and websites. So the knowledge you have here is transferable into in-demand skill. which you can use as a software engineer, etc. So, and vice versa, if you're a web dev already, you might want to try to make games, and you cannot justify the investment of time into learning maybe Unity or Godot, etc. So it might be actually better for you to just stick to JavaScript and make games with it. And there are many libraries you can use in JavaScript to make things easy. And one of them that I teach on my channel, Kaplay, is really fun to use and really quick to use, that it makes it very fast to make games with it. So that's that. So what's the promise of this video? So by the end of this video, you should have a basic understanding of JavaScript, even if you have never programmed before. And you should be able to have made your first game. So we're going to try to build, by the end of this video, a first simple game, either a platformer or something very simple. And then after that, you are ready to watch my previous tutorials. I can show them to you here. So I have tutorials on how to make a Metroidvania game, how to make a Zelda-like fighting games, etc. And of course, you can use other resources, and basically you can dive into it. So after that, if you want to make go to web dev, you can follow tutorials, etc., and read documentations, etc. So this is meant as a gateway to JavaScript, but also like game development in JavaScript. So it's a gateway to your programming career, maybe. So let's get started. So you will need Visual Studio Code here, which is the the code editor that I'm gonna use. You don't need it. If you're not a beginner, let's say you're coming from another programming language, let's say Python, you can use whatever you like that is a code editor like Vim or whatever. But I suggest that if you're a beginner, an absolute beginner, you have never programmed before, you pick this editor, so you're gonna have the same thing as me. VS Code, by the way, if you don't know, is really like the major code editor for web developers. So here I have a window that contains VS Code. So to open a new project, you go to File and then open a new folder. So first of all, I recommend that you create a folder and then you open that folder, and it's going to open it up for you here, an empty window with your empty folder. By the way, I forgot to mention, but this tutorial assumes that you have basic computer skills. So that means you know what a folder is, etc. And yeah, it might sound surprising, but for some people, it's not something that they know, etc. So usually, if you grew on the iPad, you might not know what a file system is, how it works, etc. If you're used to any like real operating system, in the sense that it's either Windows, Linux, or Mac OS, you should be good when it comes to following this tutorial, this crash course. All right, so what is the shortest path to have your JavaScript code running? So I'm going to create a file by clicking on that button, and I'm going to call it main.js. It's going to be the entry point of our project, of where we're going to write our JavaScript code. So I'm going to first create that file, write some JavaScript code. So here, if I do, you might assume that you write your code in that file, and then you click on a big green button somewhere to run the code. And this is not how we do it in the JavaScript world. So how you do it is you need to create an HTML file. I usually like to call it index.html, but it doesn't matter. It has to be called .html. So usually JavaScript is paired with HTML and CSS, which are other programming languages. They're domain-specific programming language. That means that they're not a general-purpose programming language like JavaScript is. So let me explain just a brief overview of what HTML and CSS are, but I'm not going to teach you them. I'm really not going to dive into it. I'm just going to teach you the bare minimum of HTML you need to get JavaScript onto your web browser and running. So index.html. So HTML is a language used to make a web page. So describe a web page. You have many tags. For example, the basic tag is the HTML tag, which signifies like that you're gonna create a document, a web page. And then you have the body tag, which is going to, not bot tag, the body tag, which is going to contain the content of your web page, and etc. So the body tag, the way tags are written in HTML is you need those thingy, and then you need to have a closing tag, an open tag and a closing tag. And then here the body is essential. And then within the body, I'm going to put a script tag, which is the tag used to load JavaScript, JavaScript files. So the way script tags work is that you have the tag here, and you have a source attribute where you define where to find your JavaScript file. Here, since we are on the same level within the folder, the path is going to be main.js. So you could even remove that and then do main.js. If you were to create a folder within that learn.js folder, which is the folder I created for this project, when you created the project, you would have gone here, maybe open a folder, and then you would have a different name. But feel free to name it as you want. It does not matter at all. So if I were to create a folder here, I'm going to call it source, or I'm just going to call it code. And then I put my main.js within it. Here, the path is going to be code/main.js. So that's how it would work. Now, the first statement we're going to write, first line of code we're going to write, is going to be console.log. And as the name implies, it's going to log something, the thing you pass in within the parenthesis here, to the console. The console is in your web browser. When you press F12, this is the console. So if I were to, depending on your browser, you should have a symbol. So here you have this symbol, console. This is because I really have a big font, so usually you would see them displayed here, but since I've increased the font so much, I need to click on the plus to actually see the console here. So if this is the console, and this is where the output of your JavaScript code will appear. So now here, let's say I want to write a message to the console. I need to pass in what is called in programming a string of characters. So a bunch of characters that makes up a string. So hello world is a string of characters. So we have the character H, character E, L, L, O, space character. And then W, so this is a character, even if it's not visible to the eye, it is a character, and W, etc., etc. And it needs to be put within quotation marks. So now everything should be all right, but we still don't have a way to run the code. So the basic way, I would say, is you would just open this in a web browser and you would get the result. But usually the preferred approach is to have a local web server that runs from your computer that is going to run the code and run the web page. This local server is usually called local host, and there are many ways to run one, but the simplest way, if you're using VS Code, is to go to the extension marketplace, type in live server, and you're gonna get this extension, which, as the name here, launch a development local server. So you cannot really see here. So install it. Here it should be written install, but since I have already installed it, it's gonna write uninstall. So install it. Once this is installed, go back to your project, and then here below you should see a go live button. So click to run a live server. If you click that, it's going to open up a window. Now I'm just going to copy the address because I'm going to open it in this page. So here we go. So by the way, look at the description to have all the links you need, for example, where to install VS Code, etc. So here's the local host server, the address that was given to me, and then click on that. So by default, live server should open into your default browser. But here I'm using a different browser for recording this tutorial. That's why I copied and pasted manually the address here. Now here you have a blank page because as I said, HTML is actually the language used to write the content of a web page, but JavaScript is a language used to have animations and logic, etc. So initially, when JavaScript was created, it would run only on web pages like that as a supporting character, I would say, just to add animations to HTML pages, so the actual web pages. But as the language evolved and you could do more stuff with it, it is now possible to make games with it. So here we go. So now I'm going to open up the F12, the console tab. You can also open this console tab using, I think, Command Shift I if you're on Mac OS, but it's F12 on Windows. And you can see we can have our hello world output message appear here. This is the console. So we write our code in our main.js file here, and then it's going to appear. So if I, instead of hello world, I say hello JS legend, and you can see that it updates here. So now we're ready. We have our basic programming environment ready. Later on, we're going to see more advanced tools and a different setup that is more closer to what is actually what's used professionally. All right, so now let's start actually learning the core concepts of programming in JavaScript. So the first core concept I want to mention, it's the core concept 0, I would say, is how code is executed. So I'm assuming that you have zero knowledge of programming, and then that means like code is usually run as like a recipe. Imagine it as a recipe of steps you need to follow, and those steps are extremely detailed, because if you do not detail those steps, the computer will not know what to do. It's not like a human recipe for cooking something where the instructions are mostly general and the human can fill in the gaps. But with programming, it's different. So code usually runs sequentially. So first line, and then second line, third line, etc. So now that's the basic concept 0. But then the actual first concept we're going to talk about is variables and constants. So what is a variable and what is a constant? So a variable, you can imagine it as, first of all, your computer has memory. Imagine slots of where you can place data. A variable is you putting a sticker on it with a name, let's say my variable, and then storing into that cell. So imagine you have cells that could contain data in your computer. So it's basically a representation of your memory. And then you pick one of those boxes or those slots. You put a name on it to know, basically to be able to tell it apart from the other memory slots. And then you put data in it. So the type of data you can put inside of a variable are many. You can put numbers in JavaScript. So that's the number type, the data type. So you have data types. Those are called data types. For example, I would put 4 inside of the slots, of the slot my variable. And if I do this, and I again use the console.log message and pass in the name of the variable, my variable, it's going to print out the content of that. So if I look at the results, it's going to print 4 at the console, in the console. All right. Now, the way you declare a variable, so you create a variable, is you need to use the let keyword. So usually important keywords in JavaScript are in blue like that if you're using VS Code without any themes. But anyway, let is how you declare a variable. Once you have declared a variable, you can call it elsewhere. And you can even modify its content. So if I have my variable and put 5 instead, then console.log my variable, you can see the content is going to be different. If I go here, first it was 4 at line 2, and then when the computer arrives here, it modifies the content of the my variable, and then we console log again at line 4, and the content is now different. Okay, now there's a bunch of questions that you might have. Is why the name my variable? So here, when you declare a variable, you can basically choose whatever you want as the name. There are certain symbols that are not allowed. For example, you cannot use numbers to name a variable. So you'll have squiggly lines to tell you that it's not allowed. You cannot use dashes to name your variable. However, 8 letters from A to Z, you can actually use A0L. So you can use numbers, I think, within, mixed in with letters. But usually, I prefer to keep my variables. Actually, can you actually do that? I almost never do this. So let's say Z0 as the name of the variable, and then here, and then So I'm just going to remove it and see if it works. It should work, but I'm just making sure. Yeah. So basically, there are certain names you cannot pick as well. You cannot call a variable let because this is a reserved keyword. So those reserved keyword in the JavaScript language cannot be used to declare variables. And as you saw, I wrote my variable. This is a convention that is used in JavaScript code, where when you name a variable, if you have multiple words that comprise this name, the name of that variable, then the first letter of the second word used in that variable name always start with a capital. So for example, just to show you, if I call my variable name, then I can just leave it like that. If I call it my name, I need to put the capital here. It's not the actual rules. That means if you don't respect this, the code will still run, but it's against the convention, which is called camel case, because it looks like a camel, you know. So for example, my full name. So capital here, like it does a camel thing, camel hump. I guess that's the name in English for that animal, the thing behind. Anyway, so that's that's how you declare variables. So now we saw that you could put numbers in it, but you can actually put text, a string of characters, as I said, strings we call them. Here I can put a name, for example, and then if you print that out, so be careful when you write your code to only put like defined variables, not random names. And then here, if I look at the result, you can have, like you can see. All right, so now you know how to declare a variable, but you can do much more than that than just declaring variables. You can also declare constants. So a constant is like a variable, but the content of it will not change. And there is some nuance to it later on, but for now, just keep that in mind. So for example, I want to have as a constant, let's say, the width of the screen, for example. I would call it screen width. Screen width. And then let's say 1080. This is a constant. It's if you don't want something to change, it means if I try to change the value, screen width, and then put something else, let's say 720, then if you look, let me remove that variable. If you look at the console, it's not going to let me. And you're going to get an uncut type error, assignment to constant variable, which means that you're not allowed to change the content of a constant. Makes sense, right? So the general rule of thumb is that if you're sure that you're not going to change, so by default, what I do is that I always declare everything as a constant, only when I know that I'm going to need to modify the content itself of the variable. So the default for me is const. I always use const unless I need to change the content of the variable, the slot, the cell. Then I used let to be able to do so. All right, hope this was clear. Now let's try to write something more useful. So let's say you have a constant called, okay, yeah, I have a constant called number1, and it's going to hold 5. By the way, when you see me adding a semicolon, this is something in JavaScript and even in Java, where each time you finish a line of code, you write this after its statement, because there are some other types of constructs in programming that don't require the semicolon, but I usually prefer not to use it because it's not mandatory most of the time. So I usually do this, but just so that you don't get confused, if you try to use other resources, I'm gonna from now on always write the semicolon when it's needed. So const number1, let's have a second constant, number2, let's say 4, and then you can do math. So let's have another constant, and then we can have number3, or we can call it result. And it's going to be number1 plus number 2. So this is basic arithmetic, so it's an addition, and that means the result should contain the 9, basically. So if I do console.log and I want to print out the result, and then look at the result here, it's going to be 9. Now the other way you can do multiplication. So to multiply in JavaScript, you use the star symbol, not an X symbol, but this one. So now this should be 20, and it is. And then you can divide here by using the slash. So those operations are the same as math, but the symbols used are different. So you might not be used to them. That's why I'm telling you that, like, which is which. Here, 1.25. And then I think here, yeah, for now, those are the basic operations. You can have exponents as well. So for exponents, you use this symbol. I don't know how it's called. So if I look at the result, 1. So wait a minute, that's not right. I think it's two dot like that. Yeah. That's how you do exponents. So if you have, let's say, 2 exponent 2 to the power of 2, it's 4. The operation that I just did, this is something different, and I think it's something different. Actually, I don't remember, but there's bitwise operations, but for now, I don't think it's really relevant for game dev in JavaScript for now. All right. Okay, so now you have seen as the first core concept how to declare variables and how to change the content of a variable, but you cannot do that for constants, and that you can put numbers and strings in them. Now, what happens if you have, let's say, a constant called text, and it has a string called hello world, and then you have a number, let's say 4, or number 1, I was gonna say. Maybe just number, but I think number is a reserved keyword, maybe it's not. And what happens if I want the result? So by the way, you don't have to store the result of the operation inside of a constant or variable. You can just do it within the parentheses here. So text plus number. This, in any other language with a sensible type system, this should fail. But in JavaScript, it doesn't. It actually tries to compute it, and here it will do something called concatenation. So it's going to concatenate 4 with hello world. What does concatenate means is that if you want to join text together, join 2 strings of character together, you usually use the plus sign for it. So that might be confusing because this is usually understood as adding something with something, but adding text with text, how does that work? So if I were to have hello world and then I would say hello world 2, you should have as the result in the console 1 single string with both of them. So this is how the concatenation operator, which uses the same symbol, is plus. Now, the reason I said that it should fail when a number and a string of character are added together is that it makes no sense. You need to first, for example, Python, you would first convert this into a character, and then you would concatenate it. But JavaScript doesn't have this thing, and it's something that it has been criticized a lot. So just keep that in mind, to be careful with those operations. So don't do that, or if you don't know what you're doing. So yeah, this is cool and all, but it's time to actually learn the second, I would say, or third core concept, which are conditional statements. And this is how like a program will truly like become alive in the sense that it's actually going to do very interesting things. So we have a few constructs we can use. The main one is the if statement. So an if statement allows you to have conditional code that will execute only in certain situations. For example, let's say I'm going to have a variable this time, and this variable is going to be called is true. It's just a name, or maybe I'm going to call it execute. One other type I forgot to mention is that you have something called a Boolean type. So Boolean can be either true or false. So here you could have a true statement. So true means that it is true. And the reason why the true and false thing is useful here is because it allows us to have conditional logic. Conditional logic is code that will execute only under certain circumstances or do something else otherwise. So here in the if statement, I can have the execute, pass in the execute variable. And now if execute is true, it's going to run what's within the brackets. So here I can have a console.log statement, console.log, and I could say hello. And now if I look at the execution, the result of the code, you can see hello here. All right. Now the issue here is that let's have something more complex. So what if execute is false? First of all, you put false in. Nothing will happen. So nothing will happen. Nothing is happening. Now you can use this to have more complex code. So let's say let's create two constants. Let's say if the age, let's say 25, and the height is 182. So you could have an expression execute, and then instead of passing in a Boolean directly, you could do if age is superior to or equal. Let's say I'm gonna teach you those symbols later on, but this is what we call Boolean comparison expressions. I don't know if it's the actual term, I forgot, but anyway. So if the age is above 18, then it's gonna execute here. So you're an adult, for example. And then here, if you put some code outside, you're considered a minor. All right. So here you go. And now if I run the code, you can see that both of them has executed because the age here is actually above 18. So if you want to only run this and not this, you would use an extension called the else statement. The else statement, what it does is that if this condition is not true, it's going to run what's within. I mostly prefer not to use it. So I'm going to show you the alternative right after. So here we can see because the age constant was set to 25 manually at declaration. That's why you can modify, by the way, a constant, you can modify it manually here. What it prevents you to do is to modify it later on, like age, set to new age. Just make sure this is understood. So I said I would show you an alternative to using an else statement. What I prefer to do is to have, actually I cannot do it here, so I'll wait before showing you because there's another concept that you don't have yet, so you will not understand the trick. So basically for now, else if you don't want. So if you want to have more than one condition though, for example, if you are here an if, and then you can have an else if, and then else if, you can pass in another condition and then have it here. So yep. So that's the proper syntax, and then you pass in the condition here. For example, here instead of putting this inside of a variable, which there is no need to it, it was just to show you, you can put the expression within the if statement, and it's usually what happens in actual code. So if age is superior to 18, or if age is equal to 18, equal, but to 18, and then you remove here so in certain situations, for example, the if statement, you don't add the semicolon thingy. So that's why I usually prefer not to use it, but anyway, I'm going to use it. So here you have first, if the age is above 18, so I'm going to remove this. This is no longer valid expression, JavaScript expression. So if the age is superior to 18, then it's going to print that. If age is equal to 18, you could have another message. Let's say console.log. You just turned into an adult legally. Let's go. And now, if I go here and modify the content, let's say 18, you're gonna see that you're gonna have a different message. And you can actually start making games like that, where you would change depending on what the player does, you have different constants or variables, and then you show different things. But this is the basic of an if statement. Now here, equal, that might sound strange. So equal means that since in JavaScript we use the equal sign to declare a variable or store in it some value, we need a different symbol in order to compare if two things are equal. And the double equal is what's used, but actually that's not true. What's used is the triple equal, because in JavaScript, so in any other sane programming language, you would, for example, Python, you would have two equals to determine if something is equal to another. And this is an error I would do a lot. So by the way, just when you start writing code, you need to be very careful that this symbol is to store something inside of a variable or a constant when you declare it. But the double equal is used to compare things. But in JavaScript specifically, you don't ever use this. Use the triple equal. Because the triple equal, the reason why we have a triple equal is that if you have the equal, and let's say instead I'm going to remove all of this and have an if statement and have age equal 18. So here, if this condition actually occurs, we're going to say, I don't know, something like ABC. It doesn't matter. So here, if we have this, that means you could have declared a string 18, and then this is actually going to be true and it's going to print out, even though this is a string and not a number. So if I go here, it's going to print out ABC. And this is problematic, because usually when you write this condition, you're expecting that age is a number. So that's why if you use the triple equal, which was added later on in JavaScript lifetime as it was developed, like years later, it's not going to print it out. So the default, I always use triple equal. So now if I put back a number, it's going to actually work. So what triple equal does, it makes sure that not only the values are the same, but the type is the same. So the type being either string, number, Boolean, etc. are the same. So I go here, ABC is going to print out. All right. Now there's many different expressions. So when you use, for example, you cannot do this. Actually, yeah, you cannot do this. So when you're using above or equal, etc., you use single quotation marks, a single equal sign, sorry, with before it the either greater than symbol, lower than symbol, and also a new one that you might not be familiar with is the bang equal symbol. So bang equal means it's not equal, and it's if I go to here, so bang equal, the symbol is basically like this. You see in math classes where you have this symbol. Yeah, it's basically that, not equal. You can also have just greater than itself, and it means exactly what it means. Oops. Lower than, etc. Yep, and that's it. So that's all there is to it at the basic level. So just to summarize, here are all the symbols we've seen: lower or equal, greater or equal, greater, lower, not equal, equal, but equal stricter, or which is you prefer this over this. So forget even that this exists. All right, so that's that. Now there is so that's for conditional statements. There's another type of conditional statement called the switch statement. So the switch statement is this, and it takes in, for example, your age, and then it will match it against cases. I prefer to, so the cases must be specific. So for example, for case 18, you write some logic here, and then you need to break out by using the break keyword, etc. I think as a beginner, don't really think about it too much. You can write, you just use only if statements, and you should be fine for now. Later on at the end of the video, I'm gonna point you toward a great JavaScript resource for if you want to dive deeper. All right, now there's more complex types of data you can put inside of a constant or a variable. And those are arrays and objects. So let's start with arrays. So arrays, the way you declare them. So for example, I usually prefer to do const, and then let's say I have a bunch of numbers and I want to store them within a single constant. I'm going to use an array. The way you declare an array, the simplest way is to use brackets like that. And then for each slot, you're going to have an element. So 1, 2, 3, and then you separate them by commas. So this is how you declare a constant. You declare an array, sorry. So 1, 2, 3. This is my array. It contains the numbers 1, 2, and 3. You can have arrays where you can have one element, one number, and then a string, and a number again, etc. But let's keep it simple for now. So here we have an array. And one thing that is tricky is that you remember when I said that a constant means that you cannot modify this later on. That means you cannot later on in your code come here and then change with another array. For example, an array which is 1, 4, 6. It's not going to allow you to do that. However, you can actually change each each element itself, the content of each of the slots here. This might be tricky because constant, you might think that things must remain constant, but here the array itself is constant. It's just the content of the array that is changing. So the way you access specific elements of an array is that you take the name of the array that you determined, and then in the brackets you put in the index. So the way array works is that the first slot has an index of 0. The second slot has an index of 1. The third slot has an index of 2. And so that means that the first element is not, the first index does not start with 1, but with 0. So here, if I do numbers 0 and I print that out, you're going to have something here. So console.log and then numbers equals 0. If I look at it, the results, you can see 1. It's going to print out this one. If I do 1 as the index, not the element, the index of it's going to point toward 2. It's going to print out 2. And then if I do 2, it's going to be 3. So you need to really keep in mind that these are the values, the elements of the array, and these are the indexes. So basically the address of each of those slots that contains 1, 2, and 3. So if you were to use names instead, just to drive the point home. So here we have an array of names. So I'm going to call it names. And then here you can have I don't know, John. Let's say, I don't have any ideas for names here. Max, maybe. And then Chris. Okay, you have 3 names. And then here, those are strings basically. And then if you console.log names at index 0, it's going to print you John. John. Same thing if you do 1 instead, it's going to print out Max, and so on and so forth. So Max here, etc. All right, so now that we have arrays, you know that you can have this. So if you were to, instead of putting a const, do let, you could be able to replace the whole array itself. So you could redeclare a variable like that. But here I'm putting an empty array. That means that when you're gonna console.log it to the console, it's going to be empty. It's going to print you an empty brackets. Yep, empty array. All right, So hope you understood that's how arrays work at the basic level. Now there are operations that are available on arrays. So for example, let's say you want to remove the last element of an array. What you can do is you do names.pop. This is a function or method. So I need to explain what a function is first. So you know what? Let's wait before teaching you that those operations. So now you know what? Now I'm gonna call them operations because anyway, console.log is a function that you call a method. But you might. So I'm just for now call them operations. So there are certain operations you can have on arrays, and one of them in JavaScript is pop, which removes the last element. If I go here, you can see that we have John Max, but Chris is no longer there. We have push. If you want to add an element to an existing array, what you can do is use the push operation, and from within the parenthesis, you can pass in the next the element you want to add to that array. So here I could decide to add, let's say, Takuya. And now here, if I console.log that, names, you can see the array is going to have now 1, 2, 3, 4 elements. You can get the length of an array by doing dot length. So this gives you the length of an array. This is all concepts to revise, by the way, because I don't think you're gonna remember them like that if you don't use them. All right. So another type of data type you can pass, in a constant or variable, is the object type. So here, let's say I have an object const my data. I'm going to call it this way. You can define an object by using brackets like that. I always forgot to put the semicolon here at the end. By the way, my editor will put it automatically for me. That's why it was always there anyway. Here, an object can be, think of like, it's where you can store properties of data. So I think the best way is just to show you an example. So you have key value pairs. You define a key that you want to use, and then the value that is going to be paired with it. So for example, let's say we have a name. You can decide on the key name. You can write it out like that without a string. However, if you want as a key to use something that is more than one word, let's say name2, you need to put this within bracket how we say, quotation marks. So here, because we're not using them we're only using a default name, a single, no space name, we don't need that. And then you use the 2 dot, and then what comes to the right is the value. And here, what you can put here is the exact same you could put inside of a variable or a constant. It's the same type of data. So for example, the name, I could decide on John, for example. And then here you need to always put the comma. I think if you only have one element, you might not need it. But usually you'd use comma, and then you can add another thing. Age, let's say 25, 24, let's say. And then so on and so forth. And it's a handy way to store a lot of data. So age, nationality, for example, you could say America or USA, etc. So what's cool with those objects is that you can do my data. So to access it, you can do console.log. Either you can print out the whole thing using my data. So if I have the name of the object, so you're gonna have the age, the name, the nationality, or you can print out specific pieces here by using the dot notation. So dot, and then you can see the various properties. So the age, I just want to print out the age. You can have it here. One thing that is interesting with object is that you can declare new records or properties by using the dot notation itself. So I could decide on a new property after having the declared my object. So here I would call it maybe height, let's say, and then put an equal sign, and then 182 maybe centimeters. Probably should put it in inch, so let's say 6 foot. So my data height 6 foot, and then maybe it should be a string here, so 6ft. So now if I print out the console by using console.log, the my data, you can see that a new record has been added. Let's see, a height. You can see that even though it's a constant, like with the arrays, it will let you add new properties from within the same array. What it will not allow you to do is replace the whole thing with a new object. So by doing my data, if you were to do this, then it will not allow you to do that. So this is how object works, and I would say arrays and objects are one of the most useful data structures that you're going to use. There are others, of course. The reason I decide not to talk about them here is just not to overburden you with complex, and I'm really teaching you only the concepts you need to make like your game, simple game. And then as you gonna get deeper, you're gonna probably search and then find new features, new data structures you can use, etc. All right, so now that you have this key value pairs, etc., there's another way, actually, I forgot to mention, that you can access properties from an object. You can do my data and then pass in a bracket notation that is similar to what you saw with array, but instead of passing in a number, which is the index, you can pass the name of the property as a string. It needs to be a string here. So this is especially useful when you have a property that is 2 words, for example. So for example, nice, I don't know. I don't have any idea what to do here. Let's say years of experience, years of XP. And then let's say 2 years. And then here you cannot access this by using the dot notation. Maybe you could actually. Yeah, you cannot. It's going to transfer. You're going to transform the operation to the array notation. I don't know what is the name of it, but this is the other way of accessing a specific property, and is mandatory when you have a property that is a string in string form with more than 1 word. So you can actually use that way of accessing properties with the other ones by just passing it as a string instead, age, and then name, etc. So I hope that was clear. So the next concept I would say that is pretty crucial to understand is loops. So loops allows you to repeat a same line of code or multiple lines of code multiple times. This is very useful because it will allow you to repeat stuff and generalize. So you don't have to repeat yourself. For example, if I want to print 100 numbers, I'm not gonna write console.log 1, console.log 2, 3, 4, 5, 100 times. That would take me forever. And this is where for loops come into handy. So for loops are defined like this. So for something, so for an expression, condition, do what's inside here. So for, let's say, this is where for let I equal 0, I inferior to 100, I plus plus. Okay, this might be strange, and I'm going to explain it. So we declare a variable that is going to act as a counter. The convention is usually to use a single letter, like I or J or something like that. And then it's going to contain, so the for loop contains 3 expressions. The first one is the declaration of that counter. The second one is the condition to look for. So for I inferior to 100, so as long as I is inferior to 100, then it's going to run what's in there. And the third expression here is after running what's in there, it's going to increment, so add to the value of I by using the plus plus sign. So something I forgot to teach is that, let's say I have a variable called number1, and it contains 5. You can add to it by using number1 plus plus. That means the content of number1 is going to be 5. Another way you can do that is doing plus equal and then 1. That's another way of doing it. You can also do minus equal 1 or multiply equal 1 if you want to multiply, etc. The long form of that is to do the content of number1 plus 1. That's the most verbose way of doing it. So just something to cheat. I forgot to teach you. All right, so here, so if I have let I equal 0, okay, so let's write something here. So console.log, and I'm just gonna log the actual counter itself. So here, if I go here, you can see that it's going to run from 0 to 99. So 0 because the counter was started at 0, and 99 because, you know, if I were to do 1 instead here, it's going to still run till 99, but starting from 1. If you want to print out numbers from 1 to 100, you need to change this. Instead of it being inferior, you need to be inferior or equal. So if I go here, you have up to 100. So yep, this is it. So this is the basic traditional way form of the for loop. And now considering one thing, let's say you remember we had an array. So let's say we have an array of names and you want to print out each name individually. So I have John, Max, Chris, and we want to print each of them using a for loop. So how would you do that? The basic way to do is to have index I, the counter, to 0. And down here, we just make sure that the index, counter, is going to be inferior to names.length. If you remember, by using the dot length, you're going to get the length of an array. And here the length of an array is 3 because there's 3 elements. So here in the console.log, I can do names, and then if you remember, you can pass in the index here. So since it starts at 0 and it's going to be inferior to the length, that means it's going to be 0, 1, and 2 maximum. So if I do here, and you can have John, Max, and Chris, that is going to appear on the screen. So in the console, sorry. So just to illustrate what is happening, is that if I take this, for example, yep. So when, okay, I'm just gonna copy that code. I'm gonna go to the board here. I'm gonna paste it here, and let's zoom in. So what happens here is I'm gonna use the pen here. So we had 3 elements. Maybe I should increase the font size. XL. Here you go. So here, okay. So if you remember, we had those 3 names inside of the array, and the for loop, what it does, it's just going to, if I do the execution, I is first going to be equal to 0. So during that first pass, names, that I is going to be basically equal to names with 0. And if you remember, the index 0 is the first index of the array because we have 1 and 2. So if we have I afterwards, I equal 1, names is going to be, sorry for my poor handwriting, 1 here. So that means name is going to be 1, and it's going to print out Max. So the first time it prints John, sorry. The second time it prints Max. The third time, I is going to be equal to 2. And here, so what happens is that I is equal to 0. We print out John, and then I plus plus will make I equal now to 1. And then here, I is going to be equal to 1. I'm going to print out Max. Here, John. And then I plus plus is going to come into play, which is here, remember. and that means I is now equal to 2. And then here I is equal to 2. That means names square bracket 2 is going to point towards the Chris name. So Chris is going to be what's printed out. And I++ is going to make I equal to 3. And now we have I equal to 3 here. And if you remember, we run this as long as I is inferior to names.length. And names.length means that the array names has a length of 3 elements. That means that this condition is no longer true. That means we will not run the for loop another time because I inferior to names dot length, which is the array, is now false, equal to false. So hope that little schematic drawing was clear. All right, so that's how a for loop works. And now there is a easier version of the for loop that doesn't, where you don't need to think like that. This for loop is still useful in certain situations, but the easier version of the for loop is just to do here. So const name of names, and then you can just print out each of the names from that array. And then if I look here at the result, you can see that everything was printed out. Now this might be confusing because where does name comes from? So here the easiest version of the for loop is that you create a constant called name, but it doesn't have to be name. It can be any name here. This is just a convention because it makes more sense, because in the names array, what you have for each element is a name. So you do const the name of your variable that you just created of, and then the array. And each element is going to be assigned to that constant, and then you can refer to it from within the for loop. All right, so now that we have the for loop, there's another loop that is very useful. It's called the while loop. The while loop, what it does, it continuously prints, run the code within if the condition is true, as long as the condition is true. Now it's equivalent, I think, to a for loop where you just do empty expression here, empty expression. I'm actually not sure if you can actually do that in JavaScript. So this will run infinitely because it does it actually run infinitely? So let me test it out. I barely ever use this, so I'm gonna do this. By the way, something I'm just gonna teach you right now is if you want to, just for testing, want to blank out prevent certain codes from executed, you can do Control Shift, and it's going to turn it into a comment. Later on, I'm going to teach you like what's the utility of comments, but comments are things that are ignored by the compiler, so so they're not treated as code. So basically, it's a way to add notes explaining why things are the way they are in the code, but you should not overdo it. But this is the utility, and you can use it to blank out certain parts of the code you don't want to execute, just for testing purposes, for example. So if I do console.log test, just to test what happens, nothing happens. So nothing prints out. Or maybe, yeah, it's going to actually crash the browser. So if I do this, I need to be careful. I don't want to crash it. And I think it crashed the browser. I'm just gonna close it and crash the web page, not the browser. But so if I do this, oops. All right. Okay, so it runs infinitely. So if I, just to show you how the while loop is just a for loop, is if I have a condition, let's say we have let I equal 0, so like a for loop basically, and then as long as I is inferior to names.length, so I'm going to put back, so I'm going to remove it here, I'm going to put back the constant. So as long as name is inferior to length, what I'm going to do is I'm going to console.log the names dot with the index, so the actual specific element, and I'm going to increment the counter. So if I do this, you can see that it gives you the exact same result as if you were to use the for loop. Now, one thing I just want to show you is that if I were to do the same with a for loop instead, so here I'm going to comment out this one. I'm going to, by the way, hit Control Save frequently in VS Code to update what's on the code editor. Forgot to update what the code that is going to actually be executed, because live server, what it does is that every time you save, it's going to refresh the page and your local host, local server. So here, if I, instead of a while, I use a for loop, and here I use the empty thing, so the expression, I don't define it here. I also don't define the other expression. I think it should actually work the exact same way as a while loop, and it does. All right. So just to show it, but usually we don't use a for loop like that. Looks kind of weird, but we usually prefer to use a while loop. But I think Golang is another programming language that doesn't have a dedicated while loop. They just use the for loop in the way I've shown you. I'm not sure about it though. I think it's that. Anyway, so that's how a while loop works. Usually for specific conditions, you want to check, you want to run the condition as long as the condition is false, is true or false. You want to run what's in the while loop. It's not usually used to iterate through an array. For example, that's the terminology. It's called iterate through, when you want to go through an array and get every element. So for example, you can make a calculation here. If the calculation is successful, then you change the a variable from true to false, and then it stops running. So that's the use case for a while loop. But for now, you're gonna see when we're gonna make our games, there is a lot of JavaScript features we're not gonna use, and certain others that we're gonna use a lot. But I think it's a pretty important construct, so that's why I wanted to teach you that. All right, I think one of the most important concepts is the concept of the function. So a function is very important because it's actually what allows you to have reusable logic, reusable code that you can, instead of copy pasting your code everywhere, you usually create a function by using the function keyword. And then what the function keyword does is, first it's to declare a function, and then you need to decide on a name. So here the name I'm going to decide on is going to be, I don't know, add. Let's call the function add or addition, or maybe, you know what, let's call it add. And it's going to be used to add two numbers. So this is a basic function. So the function here, what you can use it, the reason it's so powerful is that you can see it as a template. So you can use a template, you pass in data here, and then you put it inside of your logic, and then you can adapt your logic to what you need. So here we need a function that allows you to add any two numbers, any of them. So here, the parenthesis here is useful because it's where we define the params. Params are parameters that the function will accept, and basically you can think of it as like tweaking values. So you can pass values to the function to adapt it to your situation. So here, let's say we have number 1 as our first param. So the way you define a param when you declare a function is by just deciding on a name. And then here I decided to call it number 1, and then comma separated by the second param you want to use. A function can have no params, or you can have 1 param, 2 param, etc. So it's up to you. Here in our situation, we want to be able to add 2 numbers. That's why I first take the first number and then the second number. And then here, a function usually can either return nothing, or you can return a value. So here I'm just going to not return anything, but I'm going to console log. So I'm going to print out to the console the result, which is number 1 plus number 2. Now here you need to be careful because you could pass a string here. It's up to you to be careful. If you were to use a typed programming language, that would be different because you would have to specify the type. So for example, if you were to use TypeScript, you would specify that this should be a type number and the other one as well. So just keep in mind that when you're using a dynamic language, a language that doesn't enforce typing like JavaScript is, you need to be careful what you pass to your functions or what operations you do. So there's a difference between defining a function, which uses the function keyword, and calling that function. So calling the function is what actually executes that function. Defining it, it's like a variable. Like you have the variable, you can define it where you define the value, and then you can call it, not call it, but look at the content of it or modify it by using equal signs, just the name without the keyword that comes before. So here for the function, I declare the function and then I can call it using add and then passing 1 and 2 or 3, 1 and 2. And what should print out to the console is the result 3. Now, one thing you need to keep in mind is that while execution of code is sequential, so you have 1, 2, 3, 4, 5, 6, etc. Step by step, functions can be declared in any order. That means that it doesn't matter if I call the function before it is declared. I think this should still work. So if I look at it, it's going to still give you the answer. The reason for this is because the way JavaScript code is executed is that it first parses your code and is going to first look at the various functions you have and parse them. So it's going to basically register them that they exist. So that's why it does not matter the order of when you call that function. So I can call it before it is declared because the way functions are parsed is not sequential. It's the code that is executed sequentially. Hope that distinction is clear. But usually I prefer, to first declare the function and then use it rather than, do this. So now that we have that, I need to talk about return statements. So as I said, a function can return something or nothing. Here, if instead of console.logging the result, I want to return it, I can do return, and it's going to return the value. So what does returning mean? That means it's going to just give you the value. So for example, if I just call the function here now, nothing's going to happen in the console because nothing is visible. However, you can do console.log and then call the function from within that console.log, and then you're going to have the result. Not a number. That's not because I didn't pass the params we need. So 1 and 2. So doing this is going to give us the result. Now, why would you return here? Is that it's not often the case that you want to actually, console log immediately. You might, for example, want to have a constant result here. Call the add function, let's say 1 plus 2, and then with the result, you want to have another call to the add function with the previous result plus, let's say, 2 or 3 again, and then you want to print out the final result. So this is a use case, a very contrived use case, but it's a use case nonetheless. So that's it. That's how you declare a function, how you declare params, etc. That's the basics of it. Now, another very important part, another concept I would say is extremely important, is that we need to know how things are passed to the function. So there's something in programming called passing by reference or passing by value. So passing by reference is when, let's say I declare a constant number 1 outside called 5. I declare another called let's say 4, number 4. When I call add here, let's for the sake of argument, let's say you have a let here and then let here as well. If I pass in number 1 and number 2, and let's say instead here of just adding, what I do is I actually try to modify the content of number 1. If I do instead of number 1 here, it's going to be 6, and then number 2 is going to be it's going to be 5. When I'm going to print out console.log number 1 and console.log number 2, if you look at the results, you're going to have 5 and 4. Nothing has changed. So let's say even let's ignore even this. Let's say it's no longer called the add function. Let's call it modify. I'm going to attempt to modify these two variables. You cannot do that. And the reason for that is that what is passed to a function is by value. That means it takes the value of your variable or constant, and then it's going to create within that function a local variable called number1 and number2 in this case. That means even if I modify it from within the function, it's not going to impact what's from outside. Now this is tricky because in JavaScript, there are certain things that are passed by reference in a function. So by values, when you just pass the value, that means no matter what you do within the function, it's never going to modify the outside content, which is good. But in certain case, with arrays and objects, it's actually going to modify the content. So that's something very tricky. Let's say we have a single param, which is going to be an array. I'm going to call it my array. And I'm going to remove this, and I'm going to remove all of this as well. So this function modify, let's say we're going to try to overwrite the array by putting it as an empty array. And then, yeah, it just does that. Now what I'm going to do here is I'm going to define an array called, I think if I use const here, like let's say my array, and let's say we have an array of 1, 2, 3. I think this actually might prevent us from doing this because we're using a constant. Anyway, if I call modify and pass in my array, because arrays and objects are passed by reference, if I console.log the array, it should be modify, unless because I use the constant, it's going to protect it against modification. So if I do this, let's see, 1, 2, 3, and you can see that nothing has changed. Okay, that's oh, never mind. That's not it's normal. When you pass the array itself, it's not going to modify it. So you cannot modify the array. So the array is as if it were passed by value. You cannot override the array. The only tricky part, sorry if I confused you. So it's passed as if it were passed by value, but however, if you push, that means you add content to that array, let's say 121, it's going to modify the original array. That means that's why I say it's passed by reference. So if I go here, you can see that it added to the external array here. It added the number that was added from within the modify functions. That means that the my array here is not a copy. It's not a independent copy from the my array that is outside of the function. And this is tricky because if you're not careful, you might think that you're not modifying the array, but you're actually modifying the original array. So you might think that you're not modifying the original array, that it is safe, but it is not. And operations like push, pop, etc. modify the array, the content of the array, even outside, so that it's passed by reference. However, you cannot actually overwrite the array. So if I do this, it's not gonna propagate. So my array outside of the modify function is still going to be the same value. So it gives you a reference to it, but if you remove the content, it's not gonna propagate. So this is a tricky thing. So if you need to take an array from the outside and do a bunch of operations inside of a function, what I recommend that you do is you make a copy of that array. So either you can use the spread operator, etc. So the spread operator is something like that. So my array can do this. I think this should do the trick. Does it? Oh, from within an array. Like that. So it takes the content of the array and spreads its element inside of a new array. The 3 dot dot does that. So that's just something I wanted to mention. All right, so now you've learned about this nuance. You need to be careful here. I think that we've gone over the main, I would say the bare bones concepts you need to learn JavaScript. There's two last concepts, I would say. The first one is a local versus global variable. So in functions, using the functions, you probably like intuitively understood the concept. So if we have a function, let's say call it main, and you have a constant outside, John, for example. So if you have a name called John, you can have access to it from the inside of a function by printing name here. So here deprecated. Okay, so that's something with JavaScript. So let's say my name, just to be different, make sure that the name is unique. So okay, so we have here. So if I call the main function, for example, and look at the result, you can see John is printed out. That means that this, what's declared outside, is accessible globally. That means it is accessible even from within functions that are declared near it or outside. So what that means is that if you declare a function here, const my name max, for example, then this variable, this constant, is not accessible from the outside. I cannot do console.log my name here. It's not going to work if I remove this. So actually, just to test it out, it's going to print John, but not Max. But from within the main function, it's going to print Max. So it takes the nearest value, the nearest declaration. So if I do this, you can see John Max. So this, you need to be careful with this. If you want something to be globally accessible, you need to put it outside. If you want something local, you declare the variable, the constant, from within the function. And this works the same with if statement, etc. So if you have an if statement, let's say I'm just gonna put it to true, that means it's going to run either way. If I declare a variable called age, and let's say 12, then console.log the age. This works, but if I want to console.log the age from outside, the if statement's not going to work. So if I do this, age is not defined. So hope you understood this, the difference between a local global variable and how scope works. So the concept itself is called scope, the scope of variables and constant. So yeah. So if you want something to be only accessible locally, you declare it as closely as possible as where you need it. So that's that. And then finally, there's the comments. So in your code, you can add comments by using the dash symbol and then writing your text. And usually comments you leave them for others and yourself to explain why things are the way they are and not what the code does, because what the code does, you can read it yourself. When you first start programming, it's very difficult for you to know what the code does. You really have to sit down, read line by line, etc. But as you become a more experienced programmer, you can actually it's pretty straightforward to read a piece of the code and understand what is happening. So useful comments are comments that explain why things are the way they are, not how it works. So why, for example, you had to use this resolution, so you had to declare const with 1000 something because this constraint, and we need to have this aspect ratio, etc., which is not clear to someone who would read the code. This is where adding a comment would be very useful. All right, that's it. I think we have the basics concept down, and then we can actually there's one last thing. It's not actually a JavaScript concept itself, but it's very important, is how to modularize your code. There are other concepts in JavaScript that I've purposely left unexplained and not in this course, just so to not make it too heavy for you as an introduction. But now this is something very important. Let's say you cannot, for small programs, you can write your code all in a single file. But as soon as you become your projects become more complex, it's going to become time to be able to split that into multiple different files. And the way to do that in JavaScript using this setup is simple. There's the old way and there's the new way. The old way is that if you want to use multiple files, the way you do that is, let's say I create another code file, and I would say, for example, utils.js, which is going to contain a few functions that allows certain operations, like say number 1, number 2. So this is going to return the sum between those two numbers. It's a reusable piece of code I want to use in my main.js. The way you would import it in the old way is you would go back to your HTML, you would add a script tag, source, and then the path towards that file. And then, don't forget the closing brackets. And then you would go into your main.js, and then you would be able to call that function with the various numbers you want. So you would be able to use that function that is in the utils file from within your main.js file. So if I look at the result, you can see that it actually works. Now this is the old way, and this will quickly become very messy as you add a lot of script tags. This is not the way to go, because recently, well, relatively recently, there is something called a JavaScript module. So a JavaScript module, what it allows you to do is to use an import syntax. So instead of having your file here, you can just use the add function out of nowhere like that because you added the script tag before. And by the way, with this old way, the order of which you import your script tag is important, because if you import, I think, the script tag afterwards, so let's try it out just to make sure. If I do code utils, so let's say I import the utils, the add function after declaring, now it's not going to work. So here, if I look at the result, you can say add is not defined. So that was one of the very tricky things, is that you need to be careful with the order in which you put your script tags. So that's really not the way to go, I think, today. So the way to go is to use the JavaScript module feature, which what happens is that you specify a type, the type attribute. And what you're telling the browser is that this type, the JS file is going to be of the type module. That means that you can use the new import syntax. So how does it work is the following. So I have in utils.js, I can add export, the export keyword, and then from the main.js, I can do import, and then using brackets, add from utils, and you need to add .js. So utils here is the path where the function is defined. Now here it's within brackets if you just use the export, but if you use export default, that means the only thing exported, the named export is going to be add directly. So you're gonna do like that. And now the add function is going to be available and it's gonna run. Now the export, unexpected token export, export default, why is it not working? Let me remove this. Let's see if it actually works. Utils does not provide an export name default. Wait a minute. So if I do this like that, okay. So if you do export, and then you need to put this within brackets. If I go to the results, it prints out, but unexpected token export, syntax error, utils.js. If I go here, okay, by the way, you need to remove this, otherwise you're gonna get an error. So with this new method, you only need to import the entry point, which is the JS file, the main.js, your actual, this doesn't have to be called main.js, it's just the name. You decide on the entry point, and then you give it the type module when you're importing it to your HTML with a script tag, and then you can have access to the import syntax. So you can, in other JS files, you can do export function, etc., and then you can import with brackets. If you don't want brackets and import directly, you can have default, but I think you can only have one if you do this. So you might want to have a file where you have multiple functions you want to export individually. You can use the export keyword for them. So export function add, export function multiply, etc. But if you want to have only one, you can do a default, and you can mix. So I think you can mix. So you can have a default, and then you can have an export function test, let's say an empty function like that. And then that means here that while the add function is going to be empty, you can add it directly like that. So if I look at the result here, you can also do a comma and then have test as well as the other named export you can use. So if I go here, okay, I haven't used it, but yeah. So that's the way to go, I would say. All right, so now we're ready to start making games. So, and before that, it's time to just talk about what is a library, and I briefly covered it earlier on, sorry. So a library is code that is written by someone else that you can reuse in your own projects, which allows you to not have to reinvent the wheel. And a library I really like to use to make games is called Kaplay. By the way, that's the library. And I have a whole crash course that teaches you how to use it, all the functions, not all of them, but the main ones. And you have a playground where you can see examples, etc. So this is a really, really cool library to use to make games, which provides you with a bunch of things out of the box to make games. So let's use it and make a simple platformer. So here is where things are going to get different, is that for now, we have written our code using this setup where we create a localhost server and then we just index an HTML. You can actually start working on your game. This is all fine, but this is not how modern web development is done. We used Node.js and the NPM package manager and a bunch of other flavors to write our web code. So I'm going to explain how to set up that as well. Now you could use Kaplay with just a script tag. The way you would do that is you simply go to, I think I need to go on the GitHub, or in the installing Kaplay, you have the installation guide. What you do is you could have this thing here. I copy that. And then you can basically have that here. And then, by the way, even I just need this first statement basically. So here I go. So the simplest way to import Kaplay is this. So I'm gonna just go back to our main here. I can go here. At the top, I can use the import statement using native modules. And it's going to import the Kaplay library, which is going to bring you this Kaplay name. And it's going to import it from this link, this URL, which hosts the library as a .mjs file, which is for module JavaScript file. So now that you have that, you can actually start making your game. So if I call the Kaplay function, which is provided by Kaplay, it's going to initialize a canvas on your web page. So canvas is an HTML element that allows you to work with graphics. And this is basically what you use for making games in JavaScript. So you have here the canvas. Now this setup is all fine. You can start working and making your games. I usually prefer to download the file at this link and then locally put it in my project and then import from that locally without having to rely on the link being up. Otherwise, if it goes down one day, your game will not work. But I want to try something different just to teach you. I want to actually do it the way web development is done in the modern way using Node.js. So Node.js is what you're going to need to install on your machine. It allows you to run JavaScript on the actual computer outside of the browser. Now we use Node.js because we can use NPM, a bunch of package managers that allows you to use a bunch of libraries, etc. But at the end of the day, our code is still going to run on the browser. It's just going to pass through Node.js. It's going to be compiled into JavaScript that can run on the web. So JavaScript that runs on the computer using Node.js and JavaScript that runs on the web are different. They're mostly the same, but they're different. And that's why you need a compile step where it compiles your JavaScript code that runs in Node.js and then compiles it to a JavaScript code that can run in the browser. So the reason we did this is because in the past, Node.js JavaScript implemented the JavaScript standard, I think, more in a more advanced way. So it implemented new features faster, I think. And if you wanted to have a nice development experience, you had to use Node.js to get that, and it would compile the code back to JavaScript that could be used on the browser, which was less advanced. So I think that's the gist of it. But for really for this, the only thing you need to understand is that we need Node.js, we need NPM, which comes with Node.js, and we need a bundler, which is going to actually do the work to compiling the JavaScript code that runs on Node.js into JavaScript code that runs in the browser. So this bundler is going to be called Vite, and it's very like it's newish, and it's very like now it's used everywhere, so it's very convenient to use. And then after I teach you how to make the platform, I'm going to actually teach you how to put it on itch.io or some other how to publish it on the web. And that would be the end of this crash course. All right, so now what I'm going to need you to do is to install Node.js. So there's plenty of learning materials and guides on how to do that. So I'm not going to do the installation process with you. So once you're done with it, come back. So here we go in our editor. I'm just going to remove everything that we've created so far. So here I'm going to delete everything permanently. And this is where I'm going to open up the terminal by sliding my cursor here. You could have sliding here. You're going to have the terminal like that. So now I'm going to remove this. I'm going to remove that. I'm going to remove this. So we're going to have only the terminal window here. My screen is big on purpose. I don't actually develop like that, but it's just for the video so that you can have a good view of things. So if you have Node.js installed, you need to do node -- version to see that you have actually Node.js installed. So here I have version 20.11. I think the actual most current version is 22.5.1, so I should probably update soon. Okay, long-term support. So I have the long-term support version. All right, so now what I'm going to do is that once you have Node.js installed, you have access to NPM as well. And you're also going to have access to NPM-based commands. So here I'm going to create the project. So I have the folder learn.js, which is the folder I was in all that time ago. And what I'm going to do, I'm going to do npm create vite at latest dot. So this command, npm create vite at latest dot, is a quick start command that is offered by the Vite bundler, which is what I've mentioned earlier on. And I use dot here, so it's going to use the latest version, so that's why it's at latest. You can specify specific version, but I prefer for this to use the latest version. Dot means that it's going to create everything from within the folder we're currently in. If you wanted to create it in its own folder, you would type in a name here that you want the folder to be. And then here, if I press enter, it's going to give me a few options. So select a framework, and then here we're going to go with vanilla. We're not going to use React, Preact, etc., which are web frameworks. So I'm going to press enter on the vanilla option using the arrow keys and then selecting the enter. And then between TypeScript and JavaScript, TypeScript is like JavaScript with types. It's becoming more ubiquitous, I guess, used professionally because it makes your code easier to reason about. We're going to use JavaScript for this project. So by the way, if you know JavaScript, it's going to be easier for you later on to learn TypeScript if you want to. So now that we have selected our JavaScript, we have a scaffold project. So we have a few folders, and I'm going to go over them. Here it tells you to run npm install. Npm install is the general command to install all the dependencies that are listed in the package.json. And package.json is the actual file that is very important to understand because it defines your dependencies and the various commands you have access to. So here our package.json have a name, which is the name of the project. The version, you can decide it on which version. The type module, this allows us to have the import syntax using the JavaScript modules, the import from and export thing here, import from, etc. So package.json, the scripts we have access to is the dev script, which will run Vite. So typing npm run dev in the terminal will run Vite, which is the bundler we're using, which basically compiles our code from JavaScript that runs on Node.js in JavaScript that runs on the browser. Now we also have the build command here accessible to us, which allows us to build our project for the web. This is going to come in handy when we're going to actually build the project and publish it somewhere. And then Vite preview previews the build. So dev is when in development. Preview is when you have built the project and want to see if everything works correctly. And then dev dependencies is the Vite bundler tool here. So here, there's not really much to do except like we need to do npm install. So let's do that. Npm install in our terminal. It's gonna install the dependencies, the dev dependencies probably, yeah. And it's going to add a node underscore modules folder. This node underscore modules is actually where the code for the various libraries you're using is going to be stored. Usually you have a .git ignore that ignores that folder. So git is another thing you need to learn about. I'm gonna leave this for another video, but git is very handy when you're working on projects. You push them to GitHub, for example. You can have branches, commits, etc. Allows you to track your development, etc. very nicely. I'm not going to touch the file today. I'm not going to explain what Git is today, but I recommend watching a video on Git. I think you are watching a video or reading about it. It's very useful. Okay, so package.lock.json is not really important, but it contains the versions of each of our modules, etc. But package.json, if you have a project, someone gives you a Node.js project and it has a package.json, it's going to be very straightforward. You just npm install, it's going to list the dependencies, etc. So that's really great. Now here we have an index.html with a bunch of HTML that is irrelevant to our project. What I'm going to do is I'm going to remove everything. I'm going to remove everything. I'm going to put back HTML and the body tag. By the way, if you want to go more into web development, I would recommend learning HTML and CSS as well, more in depth. Here are the script tag. We're going to use the exact same code structure. I'm also going to remove javascript.svg which is just a logo. I'm going to remove style.css. I'm going to remove counter. All of these are not necessary for a project. We have public. As for the public folder, I'm going to keep it. This is where you put your assets. But actually, it's not necessary for this project. I think we're going to do without. But let's keep it for now. So what I'm going to do is in index.html, at the same level, I'm going to create a folder. I'm going to call it code, like I did. Here, I'm going to create our main.js file. I should have probably just drag and drop, but because we're not going to use any of the code, I'm just going to delete that one. In index.html, I'm going to use the source as code/main.js, and then as the path. And don't forget to actually set the type for this as a module. And then here, actually, I don't think you need that. Let me just look at what was there previously. The original, yeah, it was there, so never mind. So like we did in our simple setup, we're going to do the exact same thing here. Now you might be wondering, like, why should I use NPM? Well, actually, you don't have to. The reason you would use it is maybe you want one of the advantage of using a bundler that you can do with NPM is that you're going to be able to have your code minified into a single file, which is going to make it load faster in the browser. That's one of the main advantages. But otherwise, and also is going to make your code less readable to someone who wants to copy you. But even then, minifying code is not really a good security measure to protect your code from reverse engineering, because since your code is in the user's browser, there's nothing pretty much you can do. Now, if you want to make a paid game, I would just recommend, wrapping it as a desktop app, and I think you have more security features. But anyway, I think if anyone sufficiently motivated to reverse engineer you is going to do it, is going to be able to do it. But it shouldn't be a showstopper, I would say. For example, there are many games where you have access to this full source code. For example, Balatro is a game made in Lua with Love2D. And I saw a video on YouTube. I think it was from the channel Games from Scratch, where he showed how you could access easily the source code, because if you use Love2D, which is the framework for making games with Lua, your code isn't really protected. You can because the way you get the executable is just you zip your source code and you do something that transforms into .exe, and then you can just open it back up as a zip or something like that. So you could see the whole code of the game, but it did not prevent Balatro from becoming a very big success in the gaming world. So that's something to keep in mind. So here I'm just going to add the type module as I did earlier on. Module. Here we go. Here we go. So now we have everything. We're set up. Now it's time to install the Kaplay library. So Kaplay is the library for making games. It was this one. And for the game we're going to actually make, let's do the exact same thing here. So here they show you how to do a basic platformer in less than 30 lines of code. So let's see. So let's actually copy that code. I think we still need on key press. Yes, so it's going to be mostly in jumping mechanic. We're probably going to expand a bit on that, but yeah, that would be a good first try with Kaplay, which is the library. And then for more in-depth content regarding this, you will be well served on my channel. I have plenty of other tutorials. By the way, you don't have to use Kaplay. There are many other libraries like Phaser. By the way, if you want to use Phaser, you need to learn a bit more about object-oriented programming, something I did not mention a lot at all in this tutorial, in this course. You can use also P5 for making creative coding stuff. Very good. And I used P5 to make this game. By the way, you can watch a tutorial I made on the channel on how to build this exact game with P5.js. So that's just to tell you that there are many other options, and it's not just that one. I'm not paid to make videos on Kaplay. So yeah, it's just a library I really like, and that's why I've been using it a lot. All right, so now let's install our library. So to install Kaplay, you do npm install Kaplay. That's it, and then it's going to install it, and it's going to add it to your package.json. Here you can see in the dependencies section, it's going to add version 3001.0.0 alpha 19.1. So this is the latest version of the Kaplay library. Now, if you want to pin it to a specific version, by the way, if someone else use your project and just do npm install, it's going to install the correct version. Now, let's say you are watching this far into the future. You would do npm install Kaplay, and then a specific @ with 3000.0.0 dash alpha 19.1. If you do that, you're gonna have the exact same version. Now nothing's gonna change because it's already the version, but in case you're watching this far enough into the future, you can use that to have the exact same thing as me. So that's that. All right, so now we have Kaplay installed, and we can go to main.js and write import Kaplay from Kaplay. Kaplay like that. So when you use Node.js, you use the name of the library in strings, not the path of the library, like we did with the other setup. So now if I do Kaplay, call the Kaplay function, one nice thing about using Node.js and Vite, etc., is that you have access to documentation when you hover over things like that you don't have when you use the other setup I had. So that's one reason to use it. So we have Kaplay, which is going to initialize our canvas. So if I go here, go to the output, refresh. Okay, relative must be okay. Doesn't work for some reason. Import. Whoops. Oh, okay, I know why. Sorry. Everything we wrote is fine. The issue is just that now that we are using the other setup, this is no longer relevant. What we need to start our local development server is that you don't need live server anymore. So you can click on the go live button that was previously, and then it's going to disable the local host. But to run a server when you're using npm with Vite is you do npm run dev. Once you do that, it's going to start the server, gives you the address. I'm just going to copy it and paste it into my browser. As for you, you can just click on it with control click, and it's going to bring you to the thing here. Here you're going to get an error called favicon. So favicon icon usually on HTML pages, you need to define an icon on top. Because we're making games, this is not necessary, and if you were to host a game on itch.io, it's even more not necessary. I'm going to teach you how to prepare your game for itch.io. I'm probably not going to go into the itch.io thing, portal, etc. and do the steps, but it will just involve zipping your code base, zipping the build output, and then dropping it on itch.io. That's it. So we have a canvas that takes the whole screen and space, so that's great. Now let's look at the code here. So I'm going to copy it and I'm going to go over it. And I'm going to explain everything. So we don't need this. You can use load bean. I'm going to explain why in an instant. So if I look, you can jump, you see? And now what you can do is you can bring forward squares, rectangles, etc. that are going to act as obstacles. Now, the way I'm going to go about it is I'm going to keep that code. You know what? Just, it might be confusing for you, so I'm just going to write everything manually. So Kaplay is a method. Actually is the constructor, the way to initialize the canvas in. So the canvas element is what is used to make graphics appear on a web page. I prefer to hold it into a constant called k, because it's going to hold all the what we call methods. So methods are functions that you can call from an object. So remember, I talked about the fact that you could create objects, for example, my object, and you could have properties. And you know what? I forgot to mention, but you can have a property that is a function. So for example, you could have decided to have a function called, let's say, add, and you define it within like that. You can define it either like that or like that with using the arrow function, which is another way to declare a function. Just to not confuse you, this I think is the better way. So having this like that is basically a method. A method, that means you can, it's a function that this object can call. So yeah, so that's a method. So that means that later on you could do my object and then dot call the function like that. So yeah, it might not be very straightforward, but that's how it works. So here what I'm doing is I'm creating the Kaplay canvas, and I'm storing the context. It's called the context inside this k constant. That means that from now on, for all methods that come from Kaplay, you can do k dot and then the name of that method. How I know those methods is that you need to look at the documentation. So when a developer creates a library, they have an API, a way of using it. So an API stands for Application Programming Interface, and it's how to use what the various functions and methods are available, written by the library author, that you can use in your own project. So what you're going to do here is there are a bunch of methods and functions you can use, and they're documented inside of the documentation in the docs section here. You have various names of reference docs, and you have the name of the various things. Now for this tutorial, you don't need to look at that. We're going to just do a simple game. I just want you to have a quick win, basically, to have something at the end of this tutorial. And then later on, you can watch my Kaplay crash course where I teach you more stuff in detail, or you can watch my other tutorials. So what I'm going to do is I'm going to do a very simple game where you're going to play a character and it's going to jump over obstacles that come from the right. So think the Dino game, and the Google Chrome Dino game when you don't have internet connection. So to do that, I'm going to first pass in an object as a param to the Kaplay method. Why this is just the way that this library works, and it takes in properties that you can pass. So if you pass in an object with the following properties, Kaplay is going to do something for you. So if I pass the width property and specify a width of 1280, it's going to make the canvas, so the screen where the game is displayed, a width of 12,080. Yeah, 1,200, yeah, and 80. So now if I specify the height as 720, we're gonna have a basic resolution. So yeah, just remove that so the code works. Now if I go here, you can have our canvas here. I'm gonna keep it like that so that you can see the whole game in my screen like that. Now there's a bunch of other options you could have passed, but I'm gonna, not explain them here. So here to load assets in Kaplay, you use a load sprite function, but there is a default called load bean, which is a default sprite that is available, which is the bean character you saw in the homepage of Kaplay, which is this guy. So instead of, worrying about finding assets online, etc., I'm just going to use that for this project. So it's going to be easy to follow along. So now I'm going to create a game object, which is going to be our player. So a game object is an entity in Kaplay that takes in that is created by using the add method of the Kaplay context, and it takes in an array of components. Those components are offered by Kaplay itself. That's why you need to use k dot and then you call them. So here, yeah, so k, and then using the sprite component, I can display a specific sprite. Since I called the load bean method offered by Kaplay, I can call the bean sprite. So bean can be called with this by passing a string to the sprite component with the string being bean. That's how now, if I look at the screen, the result, you're going to see a bean appear at the top left corner. Now, let's say we want our bean character to be at the center. So Kaplay offers a way to change the position of a game object you create by using the pause component. So all this knowledge that comes from k dot, etc., k dot, it's not from JavaScript, it's from the library. So there's something to keep in mind. The separation between what comes from the library and what are concepts from JavaScript is important. So here you can use the k.pause component and then pass in either the width, the x coordinate or the y coordinate, or you can call the center method from Kaplay for it to center the to give you the position of the center, basically. So here, if I go, you can see that the character is at the center. And by the way, if you press F1, the F1 key, you're gonna have the debug mode from Kaplay, which you can see like various things, but it's not very important for now. Just remember that if you're using Edge, if you press F1, it's going to open the support Microsoft thingy, which is not something we want, but you can rebind it by using, I forgot actually, so yeah, I'm going to leave it for now like that. So now we have 3 components. So if I'm just going to display this in a more readable fashion. So we have 2 components being used, not 3. And as I said, the fact that this is an array of elements, this is JavaScript. However, sprite, pause, center, etc. are from Kaplay. So these components, when composed together, gives us our player game object. Now we're going to use the area component, which is going to create a hitbox for our player. A hitbox can be seen as a square by default that represents the body of our character. What is going to be susceptible to collisions. So if I press F1 again, even though it will open, it's going to create a box here, which is useful because Kaplay is going to offer us methods we can use and functions we can use for colliding. So by the way, every time I say method, just put in your mind that it's a function, basically. Okay, so now we have this, and then you can create a body. Oops. We're going to use the body component. So now what this is it's a bit not handy. So my code formatter does this. After 5 components or so, it's going to put them like this, so it's going to be more readable. But anyway, I use the body component from Kaplay, which is going to make our game object susceptible to gravity and collision. To gravity and collisions as well. So now we have, if you just add this like that, to gravity, and actually not to gravity, just to collisions, but to have our player affected by gravity, you need to use the set gravity method. And here I'm going to put a gravity of 1000. So now if we look at the result, our bean character is falling down. So we need to create a platform for the character to land on. So what I'm going to do is, you don't have to store your game object that you create in a constant if you're not going to use it later on, if you're not going to call it later on. So what I'm going to do, I'm going to just call the add method directly, pass in an array of components. I'm going to use the rectangular component to just create a rectangle. And this rectangle is going to have the width of the screen. So I'm going to use k.width, which is a method from Kaplay that allows us to get the width of the screen. I'm going to have a height, though, of, let's say, I think 200 or 300 should be okay. So now if I look at the result, you can see it's up there. Now I'm going to change the position, k.pause. And I'm going to put it at 1, 0, and then maybe 300. Maybe it's the correct coordinates. So by the way, in game dev, the farther you go down, the higher the value of y. So that's something very strange. If you're used to the higher the value of y, the more up you should go. So that's something you should keep in mind. So here, k.pause 0 through 100, I'm going to put it at 500. And then I'm also going to add an area component for the same reason as I did. Now this is not really handy, like you cannot barely not see the whole thing. So I'm just going to reduce the font size a bit. Maybe, you know what, I'm just going to keep it increase just so you can see and making sure that you can actually see. So k.area and then k.body are two components you're going to add. Whoops, did it add it? No. Okay. So now the only difference here is that in our array, we're going to have to pass an object and specify the isStatic property to being true. So what this is that the body, okay, you see, now it properly formats it. So what happens here is that Kaplay has the body component, which takes in an object, and the object you pass in can define the isStatic property. And isStatic, if you set it to true, what will happen is it's going to make your platform, your game object, not susceptible to gravity. So it's ideal for platforms. So if I go here, you see it lands perfectly. Now I'm going to add an outline to the platform, and you can do so with the outline component and specify a thickness. Here is the thickness of 3, should be okay. And you land on the platform. All right, so that's all good and all. Now let's implement the jumping mechanic for a player. So you can do this here. So you can have player, and then here you can have an on-key press. On-key press is a method offered by Kaplay that is also available when you create on the resulting game object that you create. So on-key press takes in as the first param the key you want to listen on, and it's going to be the space key. I decided that. So when you press the space key, you can it's going to run the function that is passed as a second param. So here, because I didn't teach you the arrow function, the arrow form, this is another way to write a function. Because I didn't teach you that, what I'm going to do is I'm just going to define the function from within here. So you define a function here. Let's say, actually, never mind. When you want to just have a throwaway function, you don't want to spend time on naming it, etc., you can use the arrow function. So an arrow function can be defined like this. You pass in, you have the parentheses, and then you have an equal sign, and then a greater than sign, which gives an arrow. and then you have brackets here. So if you want to define an arrow function outside, you would store it inside of a constant or a variable, usually constant, give it a name, and then do like that. So that's another way to define a function. There is a nuance to the difference between using the function keyword, meaning declaring a function like this with the keyword, and using the arrow function, but I think for now, just consider them the same for now. Later on, I'm gonna point you toward a great JavaScript resource that you can use to deepen your knowledge regarding that. So here what happens is that when the space key is pressed, which is what's passed as the first param, the onKeyPress method is going to run the second function. It's going to run the function passed as the second param. By the way, you can pass functions as param to other functions. So you can not only pass in numbers, arrays, objects, strings, Boolean, etc. You can also pass in functions, which is pretty handy. All right, so now what I'm going to do is write the logic. So I can just call the player from outside. Remember the global versus local thing. Because player is outside of the function definition, we can actually use it from the inside. So player dot, and then you can use the jump method from Kaplay, which is offered when you create a game object with, I think, the body component. So now if I go back to the game and I press space, you can jump. Now you can see that you can jump infinitely, because we need to actually make sure that the player can only jump when the player is grounded. Otherwise, they can just fly off like that, which is not what we want. So what we're gonna do here is we're gonna have an if statement. So this is where it's going to come in handy. So this if statement, by the way, if you have an if statement that the logic you want to run within the if statement is only one line, you don't have to have the brackets like that. You can actually just, do this, put everything on one line like that. So I'm gonna do that. So if the player is grounded, this is a method offered by Kaplay that tells you if the player is grounded. What it returns is a Boolean value. It says written here, Boolean. That means it's going to return either true or false. And if you remember, this is exactly what we want in an if statement, because if this is true, then this runs. If it's not true, then this will not run. So if I go back, I will only be able to jump while I'm grounded. So now the only thing left is to have obstacles coming from the right, and then as soon as there's collisions, we are going to basically enter a game over state. So here we go. Now what I'm going to do is I'm going to have a loop function. So actually we can use a k.loop, I think that's the name. So the loop function is something from Kaplay. So the first param is how many seconds. So every 1 second, it's going to fire the function passed as a second param. So by the way, if you have any questions, things you don't understand, feel free to ask them in the comments section. I think I've tried to teach programming in a few hours to someone probably who had never written a line of code in their lives. So if you're in this case, you might still be confused because we're doing a lot. We're speed running through a lot of concepts. So you still need to practice those basic core concepts that I've taught you, but now you actually have a base from which to further your knowledge. So that's something you know what you don't know. Basically, you know where to look for information, etc. You know what terms to use in your Google search. So that's something pretty cool, as that is going to help you a lot. So here the loop, every 1 second, we're going to spawn a game object that we're going to create here. That is going to be a rectangle, let's say 50 by 50. Oops. Using the rect component is going to have a position of, I don't know what the position would be. Let's say what happens if we go 200 by 200? I'm just gonna see it. Okay, it's gonna put you here. So if we increase the value of x, we're gonna have, let's say, 8,000 and even more, 1,000. And then here we're gonna go down, so we need to increase the value of y. If you remember why, because the higher you go in values of y, the lower you get. Okay, so here I see it here, it's a bit too low. And by the way, I'm gonna add the area component. I'm gonna add the body component, and I'm going to add the outline component. By the way, the order of the components does not matter in Kaplay, and you're using the Kaplay library. So here we go. And now what I'm gonna do, yeah, so it's increasing in place, which is not what we want, but it's a pretty cool effect. That's really nice. It's unintended, but really cool. So what I'm gonna do is, after having this, I'm going to actually have a move. The move component is you just determine the direction. So the direction at what speed. So the first param, I think it's the direction. So you use a vector2. So vector2 is just an x and y value. It's a data structure offered by Kaplay, and it's very useful for specifying coordinates, etc. So here the vector2 is just going to be, let's say, 1, 0. And then the speed. So you need to specify the speed. Yeah, the speed is the second param. I'm going to explain why 1, 0 in an instant. Here the speed, let's move at 300 speed. Let's see. Now it's more. It's better formatted. I think I better like this for format. Unfortunately, it only gets to this point after a while by my formatter, which does it yeah, automatically. Okay, so here the vector2 is used as a direction, so the x direction and then the y direction. So the x direction, that means it's going to move in the direction of x1 means to the right. So if I want this to move to the left, it needs to be -1. For the y-axis, we don't need to move in any direction. And then it multiplies this by the speed, which is 300. Here we go. So we have now our jump is a bit floaty. So maybe if we did the game as, instead of dying as soon as you get hit, what if the game was, you have those box appearing, and the goal is to survive and not be pushed outside of the bounds of the thing. It's going to be a nice twist on the dino game. So here I'm going to reduce the gravity to maybe 800. So I've reduced the gravity. It's still a bit too floaty to my taste. Maybe I should increase the gravity, not reduce it. Let's put 1,000 or 2,000, let's say. Let's say 2,000 should be a good value. All right. Yeah, 2,000 is nice. Now we could, have a speed that varies. So let's do that. So let's have a couple of different speeds the boxes can move towards. So here I'm gonna define an array. Oops. Const speeds, and then I'm gonna have either 3,000, or you move really fast at 500, or even faster at 800. And then the way I'm gonna define when to choose what is, I'm going to have a random selection. So in JavaScript, you have the math module, which is available by default. You just do math, and then random is the method I'm going to use. It's going to give me a random number from 0 to 1. Now, here I'm going to do the selection logic here. So current speed, I'm going to call the constant, and I'm going to pass it here, current speed. So you can see how declaring constants and variables is useful to make your code more readable. So here, current speed, what I'm going to do is I'm going to select the speed by using, you remember the brackets here, to select a specific index. And it's the way we're going to select the index that is going to be new concept here. So if I'm going to use the math dot random method. So it's coming from the math module, which is from JavaScript this time around. You have this access by default. There's nothing to import. It's going to give you a number between 0 and 1. And then you multiply this by using remember, multiplication is with a star symbol, by the length, speeds.length. You remember, you could get the length of any array by using a dot length. The dot length. Now, this is not going to give you a whole number. That's why you need to use another math function called mathFloor. And you need to put in parentheses because we're going to pass all of this as a param. And it's going to make sure that the number is round. So it's going to floor the number. So if it's 0.5, it's going to be 0. If it's 1.5, it's going to be 1, etc. It's going to floor it. That means we have a whole number here, which is going to act as the index. So now let's look at the result. Here we go. You see the speed varies. And then as soon as we go off screen, we're going to lose. So now it becomes the time before you lose. So here we can add different speeds. So what's nice about this piece of code is that it scales regardless of the length. So I can continue to add elements, and the code is still going to work this one. So that's something that you really want when writing code, is to have code that can be adapted, that adapts to the situation. When you are in situations when you're able to have code like that, this is really great. This is great code. So here I'm gonna, let's say 2,000. Let's say 4,000. Let's see how easy or difficult the game becomes. Ooh, okay. It becomes too fast that it doesn't impact the gravity system like the physics system struggles to handle. So let's add 1,500. Here we go. All right, so we have a game. Now the last steps is to maybe add a timer. And oops, add a timer, and yep. I'm wondering if it's too easy though. Here we go. Okay, so let's have a timer. So the way to display text is the same thing. You use game objects, and yep. So basically, we could use this. Have a counter outside. So const counter. Let's say 0, and that would be the score. And the longer you stay within the bounds, the higher the score. And every time this loop is going to run, we do counter ++, which is going to run, increase. And then here you could add at the top left corner. So what you can do is basically create a, actually you don't want to create a new game object. What you can do is you create a game object here, a const counter UI, and I'm going to use the add function. Here I'm going to use the text property, and because by default game object are positioned to the top left corner, I don't really need to specify a position or anything. I can just add a text here 0. So the text component is from Kaplay text. So I'm just gonna put 0 here, and then what you can do is after incrementing, you can have counter.ui and then have access to the text property, and then you can modify the text with a new counter. Now remember, here it's a number, and usually you want to do like toString, using the toString method to be like really, how we say, to really be in the correct, do the correct way. However, in JavaScript, it works to just transform as a text, put as a text the number directly. Because remember, if you do the plus sign, it's going to concatenate it. So yeah, so just just put the counter here, and if I go here, assignment to a constant variable. Remember, we cannot What do you mean constant variable? Okay, so this needs to be transformed into a variable, because we cannot increment it otherwise. And then that should work. So you see at the top left corner, you have 3, 4, as the loop starts. Whoops, and then I lost. So now what I'm going to do is I'm going to have the game over condition. So what happens is we need to, in the player logic, there's actually a component called the off-screen component. So if I go here at the end of the player definition, if I do off-screen, by the way, use the line numbers to find yourself. There's this off-screen component. That means if you, it's going to track when you're off-screen. So now here, which is going to allow you to have access to a new method called is, or when the off-screen is off-screen. That's a Boolean. That's not what I want. What's the function? Is off-screen on destroy on exit screen. So this method is going to take in a function as its param, and it's going to run that function when the game object leaves the screen. So here what you can do is display a message in much the same way, using the text component. Working at big fonts like that is really not handy because it hides the actual code. So hope in your editor you don't have those behaviors though. So here, game over. So at the top left corner, it's going to display game over. Now, if I let myself beaten, game over, you can see. Now you see the score continues though, which is kind of strange, but it's not what we want, basically what I meant. So what happens is we can decide that we could define, so I don't want to complicate things. So what we could do is define a scene. So in Kaplay, you have scenes. The way you can define them is just by calling the scene method, pass in a name you want to use for that scene, game over. And then the second param is going to be the logic that is going to run for that scene. And it's going to be an arrow function. Here it's more handy to use an arrow function as always. So arrow functions are really useful in Kaplay. Maybe I should have taught them at the beginning. Anyway, in a moment I'm going to teach you I'm going to point you toward a really great resource for JavaScript. So yeah, you're probably going to learn everything at once there. Anyway, so I named this scene game over. And what happens here, you can, instead of displaying the game over text here, you can display it here. Put a position, k.position component, call from within the center function method from Kaplay, which is going to center the game object. And then here in onExit screen, I'm just going to do k.go, which is the method used to go to a specific scene, and I can go to the game over scene like that. So now if I go here and I let myself beaten, it's going to be game over. And then you need to refresh the page to play the game again. Now that's it. That's the game. And hope you learned a few things. And yep, it's pretty fun to play. It's a bit too easy though, so you can tweak the values. But at least you have your very first game. Now it's time to teach you how to export that game, how to publish it. So the way you're going to do that, the simplest way, put it on itch.io, which accepts web export or GameJolt, those websites. The way you're going to do that is you're going to first open up the terminal again. And then here, you can use this is the terminal window. You can use Control-C to cancel the server you started. Terminates the server. I think in macOS it's Command C or Control C as well. I don't remember well. It's been a while since I haven't used a Mac. So now here you're gonna run npm run build. Now if you run npm run build, it's going to transform this and build it for production, and it's going to create this dist folder. Now to check that it actually works, the output, you're going to do npm run preview, which is going to preview your build. It's going to create another local host. I'm going to copy the link though manually because I'm going to put it on my Edge browser, and it works, you see. Now what you have to do is you simply open this in your file explorer, zip those into a folder, these three things, and then you can just drag and drop them in the itch.io thing. So itch.io have their own guide on how to publish the web. You just have the zip file, and then that contains the entry point, the index.html, the assets, and basically your output. You just put it there. You set it to web export, and that's it. That's how you publish your game, how you get it ready for production. So now, what are the next steps? So you've learned quite a lot, and maybe too much, and it's time to relax, and also talk about the next steps. So here is my channel. So I make JavaScript and TypeScript game dev tutorials mostly, and you can see there's plenty of tutorials that are now accessible to you that you couldn't do before because you didn't know JavaScript at all. And so I recommend you can go here, but what I recommend more at first maybe is to actually no, you can watch my tutorials immediately after this one, but you can also check this interesting resource called the Modern JavaScript Tutorial, which contains everything about JavaScript. Classes, error handling, things that promises, async await, something I did not cover at all in this project, this crash course, but is very present in my tutorials. I think I spent some time explaining it, but not all the time, not in every tutorial. So that's something I recommend you just look through, and I think it's going to really round up your knowledge. And what's really great about this resource, the javascript.info, is that you have a search bar, so you can search specific concepts. So if, for example, if I search promises, I'm gonna get specific, like the specific text that explains how it works. Now, yep, so this resource along with the MDN web docs, Mozilla, yep, these are, I would say, the highest quality docs you can find regarding JavaScript. So thanks for watching, and I hope you're going to continue with your programming journey. If you have any questions, feel free to ask them in the comment section. And if you want to dive deep into making games, there is another crash course on the channel called Learn JavaScript Game Dev with Kaplay that you can watch. Hi everyone, welcome to this new tutorial. Today I will teach you how to make a Sonic themed infinite runner game in JavaScript using the Kaplay library. So what are the prerequisites for this? You need to know JavaScript. Otherwise, there isn't much else. So the Kaplay library is a very easy to use library for making games, and I'm going to teach you how to use it in this tutorial as well. So here is the game in action. So it's a simple one-button game where you need to jump over enemies, or you can bump into them like this, and the goal is to have the highest score. As you play, the game is going to get faster, and then you get hit, and then this is how you lose, and you have a ranking at the end. So depending on your best score, you have here rank D, while now I got rank 50 F, sorry. So the goal is really to collect as many coins, but also try to have this bump. So when you jump, Sonic is invincible. So you can use this to your advantage to try to bump on enemies, and you multiply your score by doing this. So let's play it a bit and let's try to go a bit farther. So here I'm playing with the mouse, so you're going to see how we're going to use Kaplay's new input system that allows us to configure multiple inputs really easily. So here we go. As things go faster, it's going to become more and more difficult. So that's the game. Maybe one last try before we jump into it, and I will teach you how to make it. So here we go. Score 42. You can see that we have a nice parallax effect in the background. And I'm going to teach you how to achieve that as well. And yep, and when you jump, the background goes down a bit, and when you land, it goes up, and it gives this nice effect that you can see in old Sonic games. So here we go. Here we go. I just want to reach a point where it gets really fast. So that's a nice twist on the infinite runner genre, where, for example, the Chrome Dino game, if you're familiar with it, it's basically the same principles, but I added some Sonic mechanics, like the fact that Sonic, when you jump on an enemy, they die basically, and the fact that Sonic, when he jumps, he curls into a spin and then becomes slightly invincible for a while. So here we go. As things go faster, it becomes harder to succeed, but I really like the sense of speed that you have in this game. It's really like Sonic, and that's how the idea came to do it, because in those infinite runner games you usually get faster and faster and faster, etc. So that's on the game basically. So by the way, just before we jump in, if you want to know how to make infinite parallax scrolling in JavaScript using the Kaplay library, I've written a post on it. This is my Substack. It's where I write written content, and usually my Substack is complementary to my YouTube channel, where my YouTube channel has bigger projects like now, but my Substack really contains how to do stuff, very specific stuff, so that is easier to reference. So I suggest that you take a look and maybe subscribe as well to receive those in your email inbox. So I have many posts now, so the link will be in the description and in the comment section. All right, let's get started. So I'm going to use VS Code as my code editor. So VS Code is really like the most famous code editor, I guess. So feel free to use it or not. In this tutorial, we're going to use NPM as well, so you won't need to add any like extensions or anything to run a server. So you could use any editor with this tutorial. So let's create our project. So I have a VS Code opened already on an empty folder called sonic-runner-game. Call it however you'd like. So let's go into the terminal here. By the way, if you don't know how to achieve this in VS Code, you go, I think, View, and then Terminal, and then it will appear. So I'm going to write the command npm create vite at latest. So sorry if this sometimes my terminal bugs like that. I'm just going to remove that and try it again. Let's see. All right. I'm going to also increase the font size of everything so that you can see. So npm create vite at latest. So Vite is the bundler we're going to use. So by the way, I assume that you know what Node.js is. So Node.js is a way to run JavaScript outside of the browser. So NPM has become the de facto way, like you install, it's a package manager to install packages. Here, Vite is a bundler, which will allow us to bundle our code into code that is that can run on the web. So Node.js, the JavaScript code that you write in Node.js is not exactly the same as the one that you write in the browser, and there can be some differences. So by using a bundler like that, it can bundle that code and make sure that it runs on the web, but also it can make sure that the code is also minified into a single file, etc. So, yep. Now, let's hit enter. So npm create vite at latest dot will create the scaffold, the Vite project inside of the current working folder. So I'm going to choose vanilla for our framework. I'm just going to use vanilla.js. So here we go. I'm going to select JavaScript for this project, and then we can already start by removing some of the boilerplate here. So the important part here is that you have a package.json. I'm going to remove style.css, counter.js, and even main.js. We don't need those files. I'm going to create a file called source, which is going to contain all of our code. In index.html, I'm going to make sure to point the source for the script tag to source here. And inside of our source folder, I'm going to create a main.js file. Now, here for the assets, we're going to put our assets in the public folder. So what I'm going to do is I'm going to drag and drop them. So here we go. So the fonts, the graphics, etc., the sounds as well. So you're going to find this inside of the description. There should be a link that will point you towards the various assets you need for this project. So feel free to look down in the description. Also in the description, you should find a live demo of the games if you want to try it out before maybe following this tutorial, in case you're not convinced. So here we go. And now we can open back up our terminal like this by just dragging upward like that, or using the same view and then terminal. And then here, what I'm going to do is I'm going to do npm install and then Kaplay, which is the library we're going to use. So Kaplay is very easy to use to make games, and that's why I like it a lot. So now that Kaplay is installed, you should be ready to go. And now here in the main.js file, just write import Kaplay from Kaplay. By the way, we're not gonna, okay, let's just do it for now. Let's do it, and then we're gonna change this later on. So we have import Kaplay from Kaplay, and then to initialize the Kaplay canvas, you do Kaplay, like that, you call the Kaplay function. And now here in the terminal, you should write npm run dev, and then using this link, you can open up in a browser. Let's say I'm just going to open up here, and you have a canvas that takes the whole space. Now for this project, we want to have actually a fixed aspect ratio. So I'm going to specify inside of the Kaplay. So this constructor, this function, is what initializes the canvas in which the game is going to be displayed. So if you look at your index.html file, there is no canvas element here. There's actually the default div. I'm going to remove that, which is from Vite. By the way, Vite.svg here, I'm just going to keep it just to keep, so we don't get the favicon error or something like that. It doesn't matter really. If you're going to host your game on a website like itch.io, it doesn't matter. So here, main.js, this is how you initialize your game in Kaplay. Then you can optionally pass an object as a param and specify a bunch of options. So the options you can pass is the width. So the width of our game is going to be 1920 by height of 1080. So this is a full HD resolution. If I do this like that and then look at the result, yeah, so you can see that I have scroll bars, and that's not good because we want our game to adapt to our window size, but while keeping the aspect ratio. So if I go here and type in letterbox, set this to true, the letterbox option is going to make sure that it's going to scale the canvas in a way that is going to keep the aspect ratio. So here we go here. By the way, one thing I forgot to add is that for this tutorial, we wrote npm install Kaplay, which installed this version. If you look at this tutorial, if you watch this tutorial far into the future, it might not actually point to that. So I'm just going to teach you how to install a specific version. So I'm going to Control C here to terminate our web server. And here in the terminal, I'm going to do npm install and then Kaplay, and then you do @ and then the version. So here it's 3001.0.0 alpha, .0 dash alpha dot 21. So if you watch this tutorial in the future, you run this command and not just a general npm install Kaplay. Now, there is an issue with this version of Kaplay. At the moment, the mobile version. So when you try to open a Kaplay game in mobile, Android Chrome, so in the Chrome browser on an Android device, it won't work. So the game will be pitch black, but you're gonna hear the sounds. So this is an issue, an ongoing issue. I have reported the bug, and yeah, so they're probably going to fix it, maybe, hopefully. So in case you're watching this in the future, maybe bump this up by 1 or 2 versions, but I would suggest that you follow the tutorial using the exact same version, and then after you have done the tutorial, when you're playing around with the result and maybe trying to modify it, then feel free to bump the version and then upgrade to the what is latest in the future, I guess, for Kaplay. So once you do npm install Kaplay, the specific version like that, it's going to install it. Now, if you already have installed Kaplay, the exact version, nothing is going to happen. But if you had another version, this would change immediately. So you would see it change in the package.json file. All right, so now I have Letterbox 2. Let's rerun our web server. So npm run dev, because we have stopped it earlier on. So now if I go back here and refresh, you can see that our canvas really keeps its aspect ratio of 1920 by 1080, but not black bars, but here white bars are put so that the aspect ratio remains the same. And yeah, so that's an important configuration. Now for this project, I want my black bars to be black, and you can specify a background color by using the background property and then specifying the colors, so RGB values in an array. So 0, 0, 0 corresponds to black. So those values can vary for each element here by 0 to 255. So now that you have done this, and if you look at the result, you can see that everything is black. So there's nothing to see. All right, so now usually I don't do this here. I usually create a second file in the source. I call it Kaplay CTX for context. And the reason I'm going to do that is because I want to use Kaplay in a non-global way. So by default, if you just import Kaplay from Kaplay, there are many functions that are in the global namespace. That means that you can call them directly using their name, but sometimes it can occur that certain functions in Kaplay can conflict with other functions from other packages or libraries you want to use. So for example, I don't have a specific example in mind, but it could happen. So a way to mitigate that and make our code, let's say, cleaner and easier to understand is to create a context. So a specific constant from which every method from Kaplay will be called. So here in main.js, instead of having this here, I'm going to take it and paste it in the CTX, Kaplay CTX.js file. I'm going to remove everything here and hit save. Now here, I'm going to create a constant and I'm going to call it k, which is going to contain the context of Kaplay. So now when we're going to want to call Kaplay functions, we can just do k dot and then the name of the function, the Kaplay function we want to use. However, this by itself doesn't do anything. You need to specify that you want in the options object that you want Kaplay to not be imported globally. So you need to set it to false. So after you have done something like that, we should be ready to go with our project. But of course, we need to export that. So if you do export, you can export it like that, but you're going to have to use brackets. So if I do import k from Kaplay CTX, and you can use the k like that, but because the only thing we're gonna import outside of this file, so the only thing we're gonna import from this file is going to be the k. I prefer to do export default constant, but for some reason you cannot do that here. Cannot use the default in a single line. You need to first declare the constant and then type in export default k. So now what this does is that when I'm going to go here, I can just do import k from Kaplay CTX, Kaplay context. Oh, that's why I got a typo. So now let's go. So one thing also we need to do if we want our game to be supported on mobile, as I said, there's a bug currently in Android Chrome that makes the Kaplay games not work, but you can still use Firefox or other mobile browsers. So you want really to have this property activated. So touch to mouse being true. That means it's going to translate any click input to any touched input to clicks, as if it were clicks, so that you can write your code as if your game would be played on a desktop with the mouse, and it would work the exact same way on a mobile phone as well. So that's basically all of our options. There is now another one that if you are not new to the channel, there is a new system, a new input system, a way to have input. So that's very handy. And the way you configure that input system is by doing it here. So you specify a buttons object, and then here you can create your buttons, which will correspond to many different inputs. So it allows us to not have to repeat ourselves. So in the past, when you wanted to use Kaplay, you would have to write your logic for each button. So for example, if I want the same input to happen for both a mouse click, a touch, and a button press in a keyboard press, a keyboard key press, and a button press on a gamepad, I would have to call 4 different functions with the same and pass in the same handler. But now with this new input system, you don't have to do that. You just create your key. Let's say we're going to create the jump key. So this is an arbitrary name. I decide to name it this way. You could have decided on another name. And then here you can specify the keyboard property and then pass in an array of keys. So you can have multiple keys that works for the same button you created here. So here I want the space button. So for example, if you want your game to be playable by someone on their keyboard by both being able to either use WASD or the arrow keys, you can do that by specifying the keys here in this array. So I would put, for example, the A here and the arrow, I would say up, etc. So you would do this here at once, and that will save you a lot of time later on. But here in this specific game, in the Sonic game we're building, we don't really need that. What we need is actually just to have the space key on the keyboard, and we also want for the mouse to have the left click. I could have also added the gamepad, but you know what? In this tutorial, it's not really worth it to implement gamepad controls for a one-button game. All right. So nobody's gonna pull out their controllers just to play a one-button game, you know. So here we go. So now we have this. I think we have everything needed. There's one property left I want to add, is the debug property. This by default allows you to access the debug mode. I think there's also a debug key. So one thing is, in Kaplay, there's a debug mode that you access by pressing F1. However, if you use another browser, let's say the Edge browser, pressing F1 will not actually open up the debug mode. Well, it actually is going to open it up, but it's not going to, it's also going to open another page, and this can get really, really annoying. So here I'm going to specify a debug key, and let's say that our debug key is going to be D. You could decide on any key you want, but yeah, D would instead of F1, etc. So choose a key that you're not going to use in your game, and you're going to just use for debug purposes. And another property we need to add is the debug. So here, by default, when you start a Kaplay project, the debug mode is always on. That means that if you publish your project and someone knows the standard debug key, F1, they can click F1 and they will see the debug mode. So what I recommend is that when you finish developing your game, you specify the debug key and set it back to false. So by default, it's true. So here I'm going to set it to true, and hopefully I will not forget, but I always end up forgetting, except this time for this Sonic game, I actually remembered to deactivate the debug mode. So now let's look at the result. So here, by pressing D, you can see the debug mode with an FPS counter of 60. Here in debug mode is when you're going to see the, how do I say it? You're gonna see hitboxes, etc. For now, everything is pitch black, so there isn't much to see, but you're gonna see how handy it's going to become. So yeah, I recommend pick a key here and don't forget it. Alright, so now that we have our context ready, we can go back to main.js, and in main.js, we're going to start importing our assets. So for our assets, let's take a look at what we have here. We have a font, the Mania TTF font. So by the way, a lot of the, I would say all of them are from the game Sonic Mania. So I thought the sprite work was really nice in this game. So I thought I would use it. So here we have the chemical background, which is going to be the, it comes from Sonic 2, and it's the background we're gonna use in the background of our game. And I'm gonna use the technique that I've explained in the Substack post on how to have a parallax scroll with that. Here the character, the Motobug, is going to be the enemy. The platform here, it's going to be the repeating platform we have. As you go faster, this repeats itself, so it's infinite scrolling as well. We have rings animation here, a single animation, and we have Sonic here with the running animation and the jumping animation. So this project in terms of assets is very easy, and that's really great if you're a beginner. As for the sounds, we have a bunch of sounds here. Here the city.mp3 is the sound of a city, like noisy, just to have some ambience. The destroy, anyway, you're gonna hear them. So you have the when you collect a ring, when you jump, when you get hurt, etc. So those sounds also come from Sonic Mania, except the city one, I just picked it up from somewhere else. Alright, so here in our main.js, let's import our assets. So the way you import assets is you use the load sprite if it's a visual asset, so if it's an image. You specify as the first param the key you want to use, so the name you want to give to that asset. I'm going to call it chemical background, which comes from the chemical plant zone in the game Sonic 1. I think, yeah, it's the second zone of Sonic 1. Sorry if I said the Sonic 2. I meant the second zone of Sonic 1. Anyway. And then here the second param is going to be the path. So here it's going to be under the graphics folder. By the way, this is something specific to Vite, is that when you put your assets in the public folder, it's going to basically make sure that you can actually not need to specify public/graphics. You can immediately specify the path here as if it were at the root level. So this is something to keep in mind. So that's how I can just start from the graphics folder rather than saying, okay, we need to go to the public folder and then the graphics folder. So this is something specific to Vite. So here in the graphics folder, you just type in the name. So chemical-bg.png, which is the image. So this is something we're going to do for the platforms as well. So I'm just going to copy and paste that code as well. So we have two assets. Now, how do you load sprite sheets? So this is something that you might ask yourself. So sprite sheets, to be clear, this is a sprite sheet. So it's an image that contains multiple frames, multiple sprites. And you want to define the animation. So usually here we have two rows. One is the Sonic running animation and all of its frames, and down below is the Sonic jumping animation and all of its frames. So you need to tell Kaplay how this image is going to work. So this is how you do it. So you use the load sprite function. You give it a name. So I'm going to call it Sonic. And the path to find these the sprite sheet, so sonic.png. Now you have an optional third param that you can use for specifying the animations. So what you need first is to specify slice x. So slice x here is the number of frames in a row. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 frames. So you specify slice x as being 8. As for slice y, it's how many frames per column. So here we have 2. So as I said, slice x is how many frames you have per row. Slice y is how many frames you have per column. Here per column we have 2 frames. And this is how Kaplay will know how to split your image into frames, basically. And now the third param property here in the object you pass as the third param of the load sprite function is the anims, and this is where you will configure your animations. So we have two animations to configure. We have the run animation, and then you have to specify from which frame, from frame 0 to frame 7. So here we have the run animation, which is going to be from frame 0 to frame 7. How do I know this? By default, when you split your animations, when you tell Kaplay how to split your frames, your sprite sheet into frames, the first frame is always numbered 0. And then you go from left to right and then downward. So 0, 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14, and 15. So from 0 to 7 corresponds to the first row of our spreadsheet. So here I'm going to also specify whether or not I want the animation to loop. And I want it to loop indefinitely until we stop it ourselves. Now, the last thing you need is actually defining the speed. By default, there is a default speed at which the animation will play if you don't specify this. But I prefer to specify for this game. I thought 30 frames per second speed looked good for this game, since Sonic's going to run really fast. So here we go. Feel free to play with those values though, if you think that another value looks great. And then here it's the same principle, so I'm just going to copy and paste it from my original code base. So jump, it's a name I've decided to name it this way. So here you decide on the name. So if you want a name that has more than one word, you just do run and then dash something. That could be a good convention. All right, so here speed is 100. This is when the Sonic jumps, and it's from frame 8 to frame 15. All right, so now that we have this defined, we're ready to basically do the same thing for the ring and also the Motobug. So here I'm just going to copy and paste the code and explain it. So if you look at the graphics, so for the ring, it's only a single row. If you remember, if I went to ring.png, you can see that it's a single row of how many frames? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 frames. So 15 frames. Is it? Yeah, 15 frames. So that's why, actually no. 0, 1, 2, 3, okay, because I started counting at 0, so it's 16 frames. So you specify that there is 16 frames per row, and there's only one row. And you specify an animation from 0 to 15, and then you loop it, and then you decide on speed. So now that you have that, same principle for the Motobug. As an exercise, try to understand how to do it yourself. It's a single line, so that means, 5 frames. So slice x is 5 and slice y is 1, because there's only a single row, a single frame per column, sorry. Well, actually there is five frames per row, and how many frames per column? There is only 1. So here we go, and then here again I just define an animation. So now that we have all of our sprites loaded, it's time to load other kinds of assets. So how do you load fonts and sound? So for fonts, you can use the load font if you have a TTF or an OTF file. You specify the name you want to use for that font as the first param, and as the second param, the path where to find this fonts. And here it's going to be in our fonts folder. So here the fonts folder contains a single font called mania.ttf. Now for sounds, it's really the same logic again, but using the load sound method or function. So I'm just going to copy and paste the code here, and then feel free to keep the exact same names for each of the sounds that I've decided to use, so that you don't have errors later down the line. So here we go. Now we have everything we need here. Now it's time to define our scenes for our game. So in the original game, I have multiple scenes, so let's take a look at them. So if I go here to the Sonic themed and I restart the game, so I refresh my page, click on run, I have first a disclaimer scene. So in this tutorial, I'm not gonna teach you how to make this scene because it's not really that important. The reason I put it here because we are making a Sonic, not a Sony, a Sonic fan game, and Sega owns the rights to Sonic. So one of the reason I decided to make a tutorial on how to make it, I decided to make the game in the first place is that Sega is usually more permissive in terms of making fan games as opposed to Nintendo. So so here when you click, you have our first scene here. There is a reason why you should always have a scene before your menu, your main menu if you're playing sounds, or a scene actually, when making web games, you should have a scene before any sounds is played. Because the way the web works is that no sounds is going to play unless there's a first interaction by the user. So that's why, as a trick, you can see other libraries making a loading screen and then you have to click on the button to play the game. But here I prefer not to have this. I prefer to decide what to show the user, where to click, etc. So that's why if you want to put a lot of sounds in the menu, you should create a scene before that tells the player to either click or do something to arrive to that scene. Here in our case, most of the sounds, all of the sounds, are going to be played in the actual game and not in the menu. That's why it's fine if we start by making the menu itself instead of the disclaimer screen. All right, so if I press here, you can hear the sounds. All right, that's a nice combo. Anyway, so let's do that. So let's create a folder that is going to hold our scenes. I'm going to call it the scenes folder. By the way, just to teach you how it works, scenes work by calling the scene method in Kaplay. You specify the name of the scene you want to use. So let's do the groundwork here in main.js before going to the scenes folder. So here in main.js, we are first going to have to create our main menu scene. I'm going to give it the name of main-menu. And the second param is the code for that scene that is going to run when this scene is activated. So here I'm going to keep it an empty function. Now I'm going to define another scene, which is going to actually be the game. And again, I'm going to keep it empty for now with an empty function. And then finally, I'm going to define a game over screen, which will display the score. And again, I'm going to leave it empty. Now you have to, when you create those scenes, if you should always use the go function to define the default scene. So you can go to that scene by just passing in the name. So let's go to the main menu. So for now, nothing should happen visually. Everything is black. So now let's go into our scenes folder and create a file called main-menu.js. So in main menu, we're going to import our context so we can have access to Kaplay functions. And I'm going to create an export default function that is going to be the logic that is going to run when we call the scene. So main menu function. So if I go back here, I can remove this and type in main menu, and it's going to import it from our scene, from our scenes folder and scene main menu file. So by the way, I'm just passing the function name and not calling it. You don't want to call it. You want the scene function to be the one responsible for calling the function. So you don't pass in the parenthesis, otherwise you're calling the function immediately instead of when the scene decides it's appropriate. So here, what I'm going to do is I'm going to first define the best score. So the way Kaplay has a very easy way to work with local storage, and in this project, using local storage is going to be very helpful to store the best score and the current score of the player, mostly the best score, so that you can compare and give the player a rank, and so they can have a element of progression in the game. So here I'm going to have an if statement, and if k.getData is the function you use to get some data from the local storage, and I'm going to use this key. Now, for now, it doesn't exist, so that's why I've put it within an if statement. Because if this doesn't exist, I'm going to use the setData function. All of this comes from Kaplay, and set the best score here to 0. So now this should work. Okay, so now this if statement says that if the best score data doesn't exist, this is because of the bang sign here, which reverses the expression, then create the set data, then create the best score, key, and store it 0 with it. All right, so now another thing we're gonna set up is use the on button press event handler to, when the player press jump, we want them to go to the game. So you can do that like this. So on button press is an event handler. It takes as the first param the key you want to listen on. When this key is pressed, it's going to run the function that is passed as a second param. So here it's going to call the go function with the game key, and it's going to change the scene towards the game scene, basically, where the actual game is. So now let's hold a constant. Let's create a constant called background piece width. And the reason I'm doing this, so I'm going to use that to basically know when to swap the background, the first piece of the background. So the way infinite scrolling is going to work is by taking the same image twice, sticking them together, and once the first part of the image is off the screen to the left, we're gonna replace that image, this first part, behind the second part, and the second part is going to become the first part. So what was once the part 2 is going to become part 1, and what was once part 1 is going to become part 2. And by swapping in and out like that, we have an infinite scrolling effect. So if I go const background pieces, it's going to be an array, which is going to hold 2 sprites. So in Kaplay, you create game objects. So game objects are the way you create entities, etc., that are going to be visible. There are other ways. You could just decide to draw things using the onDraw method, but game objects are useful because they come with, you can use components on them. So one of the main draw of Kaplay is that it offers a lot of components that have ready built functionality for you, and you compose your game objects by adding components to an array. So the way you create a game object in Kaplay is by using k.add. It will add a game object to a scene, and it will create it from an array of components. Those components are offered by Kaplay, and they come with a bunch of features. So the first component we're going to use is a sprite component, which will take the sprite you want to display. So here you pass in the key. So if you remember, in main.js, we decided to name the chemical background to being this key. So what you do is you just take that key, and in main menu, you just call it here. And this is going to create a game object with this sprite. Now, we're also going to use the positional component called pos, which allows us to determine the position of a game object. And also, by using certain components, you will have in the resulting game object access to certain methods that will allow you to do certain things. So think of components like new abilities that you add on top. You stack on each other, and it gives you new functionality for your game objects. It's a very cool way of making games, and this is why I like Kaplay a lot with this concept. So here I'm going to specify the position to be at coordinates 0, 0. And now I'm going to also add the scale component, which will scale twice our game object. So our image is going to be twice as big. This is what looked good. This is what looked good. So you're going to see in an instant. So we have this, and then I'm going to also determine the opacity. So I can use the opacity component and set it to 0.8, which is what looked good again. So opacity is a component offered by Kaplay, scale is a component offered by Kaplay, etc. So how do you know what components are available? Well, you can go to the documentation on kaplayjs.com. So this is our first game object. Now we have a second one, which is going to be the exact same as the first one, as I explained the principle of having two pieces that follow each other, and then when one is off screen, we put it back behind like a train, and this gives us our infinite loop, infinite scrolling. So here I just copy and pasted the same exact game object, so it's going to be two game object with the same properties, same components. But here for the position, instead of having 0 here, I'm going to put the background piece width here, which corresponds to background piece width. Now here, actually, you know what? Since we're scaling twice the image. So by default, our image is of the resolution 1920 by 1080. But since we're scaling it twice, that means it's going to be twice as big as that. That means the end of our image is going to be farther along. So here, if you want our second game object to be right after the one, it needs to be twice at the position background piece width twice times 2. So that so the first image is set at 0, 0. So by default, when the game starts, and if the background pieces don't move, the first image is going to take the whole canvas, because if you remember, the canvas is 1920 by 1080 as well. So it's the same resolution as the chemical background. But if you want to place the second image right behind the image, you need to place it in such a way that the coordinate, the starting point of the second image is going to be after the first image. After first image ends, which is its width times 2, because we have scaled it twice. That means that the background image is twice as long as it normally is. So here we go. So, and also by default, something you need to understand is in game dev in general, things are drawn from their top left corner. So when you do position 0, 0, what is at position 0, 0 is the top left of the sprite of the image. You can decide, you can change the origin, but you need to use a component for that, and we're going to actually use one for other sprites. All right, so we have this. Now let's look at the result. I think it should look good. So yeah, let's test it out. Okay, so we have an error. So I'm gonna press F12, look at the console. Do we have an error actually? Okay, yeah, okay, it's not an error because I clicked. And if you remember, if you click, it's going to bring you to the game. So this is the background. Now I have some doubts because in my original code base, I actually kept the same 1920 thingy. So for the position. So yeah, maybe, you know what? I'm gonna put it as background width for now here. If we don't have any issues, that means that it doesn't matter in the end, because by the time the background is, well, actually, I don't understand why anyway. Okay, we're gonna see later on when we're actually going to implement the scrolling background. Okay, so now it's time to create another array like this with two game objects, and it's going to be our platforms. And much like our backgrounds, it's going to be replicated in the exact same way. So we're going to have a first game object, which is going to have a sprite called platforms. If you remember, that was the name we decided on for the platform sprite. So if I go here, go to main.js platforms. So now here, the other components we're going to use is a position. So I think the width of the image. So if I go here, platforms. Yeah, so let's put our first image, our first platform, the first part. Oh, let's put it at 0. Okay, pause. 0. And then for the height, it's going to be 450. So in game dev in general, the coordinate system is inversed. That means the farther you go down, the higher the value of y. So 450 is really at the bottom, towards the bottom of the screen. And now here I'm going to scale the image 4 times. So if I just do that and look at the result, You can see that we have our platform here. That looks nice. Now, again, the same logic we're going to use to have scrolling backgrounds. We need to add a second game object. This time around, this game object needs to be after the first one. And here, I think the way I did it... Okay, I think I understand why here I didn't multiply it by 2, because later on, we're going to anyway set the position per frame. So the starting position will not matter, because we're going to use an update loop, which is going to run any frame, any single frame, and 60 times per second, and it's going to modify the position. So that's why. So if I'm just going to multiply it by 2 just to be correct, but I think you need to multiply it by 2. And then here for the platforms, I think the same logic applies. Here, however, here I put it at 3 unit. Actually, I didn't. What's the width? The width of the image. So if I go to main menu, where is it? Maybe platforms. Okay, it's the width of 120. Okay, 1280 by 160. That's the width of the image. So I'm just gonna do that as well. So maybe have a constant platform width 1280, and then I'm just gonna put it here. But it scales 4 times, so if you multiply this by times 4, because we're using the scale. Okay, let's look at the result. Okay, for now it's not I cannot really identify any issues for now, so let's work on the scrolling background and then we'll see. So before adding any text, etc., let's create our update loop, which is, as I said, a function that is going to run every frame, and usually 60 frames per second, 60 times per second, if you have a frame rate of 60 frames per second. So here in this onUpdate, what it takes is a function that is going to run every frame. Now here, what I'm gonna do is, if the background pieces, so that was the array we created, we're gonna take the one at index 1, which means it's the second one. So we check the speed, not the speed, the position. If it's inferior to 0, that means that the second background piece has gone below 0. That means has gone a bit too far to the left, outside of the bounds of the canvas. That means that we can take the first background piece and put it behind. So here again, if you want more visual explanations, etc., I have the article, the post I've made. I think it does a good job with schematics to explain. So if you want to reference this in the future, you can just go to the article instead of having to rewatch this video. So here, I'm gonna, in that case, when the second part is going out of bounds to the left, that means we can take the first part, and we can use the move to function, and set its position to the position of the first one, the second image, pos.x, plus background piece width, as I said, multiply by 2, because remember we scaled it twice. And then for the y coordinates, we don't need to change anything. So now what we do here is we are simply going to change the order of our game objects in our array, so that what was once the first game object is going to be the second part, and what was once the first part is going to be the first element. So to do this simply in JavaScript, you can use the array methods. So the push array method, and then within the push array method, you can use the shift array method. So I'm going to explain what each does in case you're not familiar. So push will add whatever is within here as the last element of an array. Not as the last, we'll just add it to the end of an array. And then here, shift takes out the first element of an array and returns it. So what we're doing here, we were taking the first game object and putting it at the end, etc. So now that we have this, we can have our logic to move our background pieces to the left. So we're going to do move. So the move method allows you to move a game object, and you can specify an x velocity and a y velocity. The x velocity I'm going to use here is 100 minus 100, so it goes to the left. And what I'm going to do here is for the second piece, it's going to follow in the footsteps of the first piece. So it's going to move to the background pieces. So the first one, the first element. So we're going to take its position.x. This time around, we also need to do plus the background piece width multiplied by 2. Like that. So now everything should work. Let's look at the result. We should have an infinite scrolling of the first background. So here we go. So things are scrolling infinitely. If I not press F2. So if I refresh, I press the D button, which I specified as my debug key, you can see the skyscrapers moving. So if you want to actually see when the first image starts off and where the second finishes, or vice versa, you can go here and add an area component. So an area component is usually used to have a hitbox. So I would not recommend keeping it here for performance reason if you don't need it, but it's really helpful to see the shapes of our images and sprites. So if I do here, if I refresh, if I press the D key, you can see that this is the first image, and at one point it's going to end, and you're going to see the line, the blue line is going to go vertically. So let's wait a bit more, and then okay, is it going to scroll? So the speed is a bit too slow. So you can actually see here the end of the first background and the start of the second one. So here we go. Okay, so let's remove the area components because we don't need it. So now we're going to perform the exact same logic we did, but for our platforms. So here again, I'm just going to copy and paste those things. So here we go. So here I'm going to copy and paste it. Now there's something I need to explain here. Here it's called game speed, but this is not necessary. So let's give it a speed of minus 4,000. It's going to look really fast. So if I go here, you can see it is infinite scrolling at a faster rate, and this is what we call the parallax effect. So when in the background it scrolls slower than in the foreground, it gives this effect of depth, which is really nice. All right, so now what we're going to do is to add Sonic. So let's create a folder where we will have all of our codes for our entities. So I'm going to call it entities, and one of the entities in our game is Sonic. So I'm going to create a sonic.js file. So what happens now is a pattern I like to use is to have a function. So I'm going to export a function. So I'm going to create a function which is going to basically act as a constructor. It will construct our Sonic game object. So I'm going to call it make Sonic, and make Sonic is going to take a position param. So position param is going to be a vector2. A vector2 is a data structure offered by Kaplay, which allows you to pass in an x and y value at once. So you're going to see it in action in a moment, and it's going to be very clear. So here I'm going to create a constant. I'm going to call it Sonic, and I'm going to use again the add function, and then an array, which I'm going to pass in a bunch of components. So the first component I'm going to use is Sonic, and as the second param, optionally, you can define the default animation. So by default, I just want Sonic to run, to use the run animation that we specified in our main.js file. Now here I'm going to call the scale. So I'm going to scale the Sonic sprite 4 times because this is what looked good. I'm going to add an area component to Sonic to have an automatic hitbox for Sonic. You can specify the shape of it if you don't like the default shape, passing an object here. So here you could do shape and then passing an object. Feel free to watch my Kaplay crash course where I go over this, or watch my previous tutorials, or watch go to the docs. But for this project, we're not going to really need this here. Actually, I think for the enemies, we're going to need to specify custom area, so you might not need even to look at the other tutorials. By the way, if you enjoyed the content, the tutorial so far, feel free to subscribe and like, and even give a review of the tutorial of the course if you liked it or not, so that it can help others know if it's worth investing their time into this tutorial. Thanks for watching, by the way. So here I'm going to use the anchor component. The anchor component allows you to change the origin of a game object. If you remember earlier, I told you that by default, things are drawn from the top left corner. So a game object is drawn from the top left corner as well, the sprite. If you want to change that and you want the character to be positioned along the center of it, you need to use the anchor component and specify center here as a string. And then here I'm going to use the positional component. I'm just going to pass the positional vector 2, which you're going to see in action in a moment. And then finally, I'm going to have, for now, there's nothing else really that's needed. So what I'm going to do is, actually maybe there is. So you know what, let's keep it at that. Let's go back to our main menu scene. And then in our main menu scene, what we're going to do is right before our on update loop, I'm going to call make Sonic, which is going to import it from our Sonic.js file. So make sure this is how it looks like at the top. Usually, maybe it's the best practice to have always the context on top, and then later on all the other things. This is something really up to you. It's a convention. You can decide on how you'd like. So here I'm calling make Sonic, but I need to specify the position of Sonic. And this is where you can use the vector2 data structure by calling k.vector2 and passing in the x and y value. So 200 by 745. This is what looked good. If I look at the result, you can see k is not defined in Kaplay.ds. Okay, why is that? That makes no sense. Okay, what do you mean? Make Sonic. Oh, in our Sonic.js, we're using the k here, but we haven't imported it. So we need to do import k from Kaplay context. So now, if I go back to main menu, if I go back to look at the result, you can see Sonic running. All right, so yep, we have our main menu basically done. Now we need to add a bit of text, and then we're ready to actually tackle the meat of the game. Okay, so what we're gonna do here is right before, maybe here, before calling Sonic, let's create a game object with the sole purpose of displaying text. So yeah, in Kaplay, even if you want to just display text, you need to create a game object and then use the text component. And then here, I'm going to call it Sonic ring run. So maybe if this could get away. And then here to decide on the font, you pass in as a second param, an optional param, an object with a key font. And then the font is going to be Mania. And then the size we're going to use, maybe if this could go away. So what is going to be the size? 32 should be good. So just pass in 32. Now, this is not enough because by default, if you do this, it's going to put it at the top left corner. Sonic ring run, which is not bad, but this is not what we want. What we want is actually for this to be bigger. So the text should actually be bigger. I think 32 is too small. So let's go with 96. And then let's add the positional component so we can specify a position. And in Kaplay, you can call k.center to have the center of the center position of the canvas. So if you pass k.center, it returns a vector2, which is going to be able to use as a position. So if I go here, you can have Sonic here. Now it might look strange, like why is it to the left and not really to the center? Because if you remember, if I press the debug key, which I decided at the beginning of the project to be D, oops, I shouldn't have done that. I should do this, press D. You can see that the origin is the top left corner. And you can see the hitbox. So that looks nice. So if I go and press D again, it's going to disappear. So if you want Sonic to be at the center, if you want the text to be drawn from the center, you need to specify the anchor. But you know what? Actually, you're going to do that. So if I do this, I add k.anchor, specify the center. I look back at the result. You can see that the name Sonic Ring Run, which is the name I decided for the game, is at the center. If I press D, you can see that the dot is at the center. All right, so now what we need else, is to actually change the position so that Sonic, so that the title is at the center X coordinate, but for the Y, I want it to be at 200. So to get a specific, one of the specific coordinates, either X or Y, you just do .x once you have a vector 2. So I do this, and then if I look at the result, now it looks nice. So now we're going to add a second game object. This time around, it's just going to tell the user what to do, to press space or click or touch to start the game. So here, I'm going to add it like that. Here, I just copy and paste it from my original code base just to be fast. So you have the press space, click, font using the Mania font, and size 32. And then for the X and Y coordinate, what felt good was taking the center Y and then subtracting 200. And remember, when you subtract, when you go, the value of Y gets smaller, you actually go up. When the value of Y gets bigger, you go down, which is an inverted Cartesian plane, which is not common outside of game dev. All right, so now if I look at the result, you can see our main menu is done. So now we're ready to tackle the actual game. So I'm going to close main menu.js. I'm going to go to, I'm going to create a new file. In the scenes folder, I'm going to create a file called game.js. I'm also going to take the opportunity to create a gameover.js file. And I think we should have our 3 scenes. All right, so for game.js, I'm going to export default because it's going to be the only thing we're going to import from this file. I'm going to call it game. And it's going to contain the logic for our game. Remember, since we're going to use a lot of K here, I'm going to import the context as well. So here, what do we need? So I'm going to first set the gravity of our game. So the reason I'm going to set the gravity is so that I'm going to be able to jump later on. So here the gravity value I chose is 3,100, which is what felt good. So in Kaplay, you can set the gravity of your game by just calling set gravity. Now that doesn't mean that the gravity will do anything if you don't have game objects that have the body component. So we're going to look at that. We're going to add it to Sonic in a moment. So because he's going to be affected by gravity. So here again, it's the exact same logic for the scrolling background. So I'm going to copy and paste it here. Now you could, if you wanted to have proper programming practices, to, not copy and paste, create a modularized function and use that. But this is a pretty small project and we're just going to copy and paste this once. So you might not want to bother, and I didn't want to bother with this. So I'm just going to copy this though, and I'm just going to paste it here. And I'm going to use it here. So platform width. So this logic is the same. However, there's going to be a little bit of nuance. So here we have our 2 pieces as we discussed in the main menu.js file. However, what we're going to need to do here is different because we're going to have to create a game speed variable. So here, let's do it here. So we have a variable called game speed, which starts off at 300. Because remember, the mechanics are as you play, the game gets progressively faster, and we want the platforms to scroll faster to give that sense of speed. And by the way, a trick is that Sonic is actually stationary in this game. We just give the impression that he's moving by scrolling the background instead. So that's the secret, I guess. And then here, I'm going to use the loop function to every 1 second. Here you specify the time in seconds. It's going to fire this function. So here, every second, it's going to increment the game speed by 50. This is what looked good. And then here, if I go downwards, if we create our onUpdate loop, so k.onUpdate, like I explained earlier, it's going to run the function here every frame. So here I'm going to copy and paste the logic we had for our background. So this remains unchanged. You could decide to have this in a modular piece. And then for our platforms though, things are gonna get different slightly. Now, here we go. Now, there's one thing I did here which was pretty smart, is to use dot width. So you can get the width of an image by having dot width. So you might not need to have BG piece width. You might need to store it. You might not need to store it. So you know what? Since I've already brought the platforms width constant and it is shorter, I'm just gonna use it here. So here, remember, multiply by 4 because we scale 4 times the platforms when we created the game object for that. Here, you can see. So now here, game speed is by the speed we were going to move the first platform, which the second platform is going to follow suit. So now, as this increases, the game will get faster. So now if I look at the result, and I refresh this, click, okay, nothing happens because we haven't hooked up the scene first. So we have the function, but we need to actually go back to main.js and hook up the scene. So to hook it up, we're just going to replace this with game and import it from, remember, from our game file, from a game file. So now if I hit the save and I go back to look at the preview, I click, you can see as time will pass on, this is going to get faster. So let's just, let's see how fast it gets. So you can see speed is starting to pick up, and it's going to pick up, etc. So 50 is a value that incrementing by 50 makes sense here because it's not too fast of an increment that it goes from 1 to 100 too fast, but it's a good value so that it progressively gets faster and faster and faster and faster. So you can see actually it's getting faster. So I'm not gonna waste too much of your time now. So let's actually work on getting Sonic here. So let's close main.js. Let's go to game.js here. And now we're gonna have to do a bunch of things. So first of all, right before maybe the loop here, I'm going to create our platform, but not the platform that we saw, the sprites, but an actual rectangle that will act as a platform for Sonic when Sonic is going to be affected by physics. Because if you remove away all the sprites, what really happens is we have a box that represents Sonic that jumps stationarily on another box, which is the platform, that doesn't move as well. So we need to create a game object for that, and it's going to be invisible. So here we're going to use the rectangular component, rect, give it a width of 1920 by 3000. I'm going to give it an opacity of 0 by using the opacity component, so it's invisible. I'm going to give it an area so that it's going to have a hitbox. I'm going to give it a body component, which will make it susceptible to gravity. And if you pass to the body component an object with the isStatic property to being true, it's going to make sure that this body is going to remain fixed. So that means it's actually not going to be affected by gravity. It's going to be like a wall, an obstacle. And finally, I'm going to pass in a tag. Well, actually, I don't think I need this tag here. You're gonna see that tags are pretty useful when it comes to detecting collisions. So it's just a string that you pass in your array of components. It's not a component itself, but it's very, very handy. So let's run this. So now if I, whoops, cannot read property of undefined clone. What do you mean? Okay, did I do something wrong? Okay, add rectangle. Okay, opacity area. Oh, okay, we need a position. We need a position, so we need to specify the position. So the position that was nice was 0 byte 832. Don't remember to add your commas. So now here, if I press, you can see if I press the D key, which is the debug key I specified earlier, you can see that there's an actual stationary rectangle. It's not maybe not really visible. That doesn't move. That is this box here, which acts as the platform. So now we have this. We can actually start spawning Sonic. So Sonic is going to come. Let's put it right here. Let's do const Sonic, and then we're going to, oops, we're gonna call the make Sonic method, and then pass in the position. So the position that looked good was 200 by 347. I think it's the same that we used in our main menu. Let's look it up. 747. Okay, 747. Okay, 7, like that. Now if I look at the result, and there's an issue. Make Sonic is not defined. Okay, that's because we haven't in our game.js imported the make Sonic function. Make Sonic. Here we go. If I hit save, remember to hit save, click here, you can see Sonic is here. Whoops, I always press the F1 key here for the debug mode, but here on Edge browser it doesn't work well because it opens up a page. So here D key, you can see that we have our object, our Sonic. Now there's an issue here, is that Sonic isn't doing anything. So let's go back to our Sonic.js file, and in Sonic.js file we're gonna actually write the logic to make Sonic jump, and all of the not all of the related logic, but a lot of it. So here in Kaplay, you can also pass in your array of components an object which can contain extra properties you want, custom things. And you can also pass in, you can also use the fact that you can pass an object to define methods for your game object. So it's a bit like OOP, object-oriented programming, but we have without having to create your classes. So here I'm going to create a method called setControls, and you can do this like that. So you might not be aware of this syntax. It's equivalent to this, but it's just a shorthand. So here in setControls, what I'm going to do is I'm going to call on button press and specify when player jumps. We want to, if this, so this here corresponds to the game object, so Sonic in this case. So this is something handy when you define your methods here, is that this gives you access to all the other properties and methods you define within the object and even outside of the object, because the game, the components here that you add will add certain properties and certain methods. So you will have access to them here by calling this this dot thing. All right, so this dot, and then is grounded is a method that is available if you use the body component. So we actually didn't use it, so we need to actually use the body component here. So I'm just going to add it. So it's going to make Sonic susceptible to gravity. And now because I added this, it allows me to use this. It offers this method. So this method is going to be available on that object, on the game object. because I used the body component. So is grounded basically tells us if Sonic or the game object is on the platform. So is grounded basically. And if it's the case, we're going to first play the jump animation. So you can, since we are using the sprite component, we can have access to the play function, the play method, which you can use to specify which animation you want to play. And we want to play the jump animation. So this play.jump is going to play the jump animation, sorry. And then this dot jump, however, this is something that if you have the body component, which we have here, is going to make the game object jump. So actually jump physically in the game. So this allows you to not have to implement your own jump mechanic, and you can specify properties here like the jump force. But for now here, let's define the jump force within the body component. So you can pass in optionally an object that is going to define by how much the game object will jump. And here I thought what looked good was a jump force of 1700. Alright, so now the last thing we need to do is actually to play the jump sound. And here this is something that might confuse you because k.play and this.play are not the same thing. This.play is the game object.play, so it's a method of the game object which plays an animation, while k.play plays a sound. It's a global thing from Kaplay. So be careful with these two, it's not the same thing. So this is for playing sounds, this is for playing animations. So here the sound I'm going to play is also called jump. If you remember when we copy and pasted from our in our Kaplay main.js file here, when we imported the sounds, we decided that the jump sound was this one. So here in the Sonic is going to play the jump sound, and here because by default the sounds are too loud, you can specify as the second param an object with the volume. So that's cool. And I'm gonna set it to 0.5. So it's from 0 to 1 and defines how loud the sound is going to be. And 0.5 is what looked good, sounded good without being too loud. All right, now that we have this, we can define another set events method. These methods are just arbitrary. It's the name I've decided to call them like that. They don't do anything, like you could have called them whatever else. So here in the set events, I'm going to use, again, this to have access to the game object methods. And there's a method called onGround. So what happens is when this onGround, like the doc says, the doc disappeared. So dot onGround. So we click here. Okay, maybe if I do this. Okay, here. If you have the body component, you have access to the onGround event listener, which is going to register an event that when the game object hits the ground, then it's going to fire the function you pass as a param. So here, I'm going to pass an error function that is going to run this.play run. So basically what this does is when Sonic has done jumping and hits the ground, it's time to put back the run animation. So now that we have this, I can go back to my game, and right below Sonic, I can call these methods. So I'm going to call set controls so that the player can start jumping, and I'm going to call Sonic.setEvents so that the event listeners can start listening. So the onGround event listener. So now if I go back and to my game, click. Okay, there's an issue. Cannot read set controls. Okay, why is that? Did I call it set controls? Set controls. Okay, did I save it? What's the issue? If I go here, hit save. Normally this should work. Okay, so that's strange. Okay, cannot read properties of undefined reading set controls. Okay, why does it think it's undefined? So here we go. So on button press. That's strange. That's very, very strange. Okay, let's use another name just to test things out. Let's just use another name. So let's the name like set jump, like set jump mechanic. Let's call it this way. Let's go here. Set jump mechanic. Now if I hit here, okay, what's the issue? Set jump mechanic, reading property of undefined. Reading set jump mechanic cannot read properties of undefined. Okay, there's something missing. If I go back to Sonic here, do I have all the correct components? Scale is here. Anchor is here. Area is here. Position is here. Did I pass the correct position? I did. Oh, okay, I know why. I did not return Sonic. Because later on, we're going to add a child game object to Sonic, which is going to be its counter. When you jump or collect a coin, you're going to have a +1 near Sonic, and it's going to be created as a child of Sonic, of the Sonic game object. So here, I forgot you need to return Sonic here. And here, so that means we can just call it set controls as well, so it's not an issue of names. So if I go here, call set controls, and now hit check the game. Here we go, and then you can jump. So if I open the debug mode, you can see Sonic jumping like that. So this is something like we already have one of the big parts of the game done. So what we're gonna do now is create our mobs, basically, our enemies. There's only one type. It's the motobug. So I'm gonna call it, create a file in the entities folder, call it motobug.js, and then motobug, the way it's going to be created, I'm just gonna copy and paste it. So what I'm gonna do is here I'm gonna go over each of the components. So here we export a function, should have maybe, here you might ask yourself why you're not using export default since it's the only thing. I'm thinking that if you scale the game further, you might maybe define a few other functions here in this file. So that's why I didn't use that. So here make motobug is, again, it's going to take the same pattern of using make and then the name of the entity you want to create and then a positional param, and then it creates a game object and returns it. So it returns the game object with the following components. So the sprite component with the motobug sprite and the anim run by default. And then here it creates a custom shape. So instead of using the default shape, it's going to create a new shape by using the rect constructor from Kaplay. So you need to do new k.rect. And then the first param is the offset. So here it's a position relative to the game object. So I want the the hitbox, the area, to be -5 relative in the x coordinate to the game object itself. This is what looked good. And 0 offset for the y coordinates. And I want the rectangle, so the area, the hitbox, to be of 32 by 32. And then here again, I scale this for time. I think Sonic, I also scaled him for time. Anchor center, so that the center of the sprite is the origin, which is easier to reason about for entities. And then the position here, and then here is the off-screen component. This is going to allow us to have access to methods to check when the enemy is off-screen. And it is going to be helpful because we're going to spawn a lot of enemies in this game, and we need to destroy them basically when they leave the screen. Otherwise, it's going to affect performance severely. And then finally, we have the tag. So a tag is a way to identify a game object. So I'm going to call it the enemy tag. So you can pass in as whatever string you want to use. And it's going to be used in the onColliders event listeners that we're going to see in an instant. So here we go. We have our make motobug thing done. So now we can go back to our game. And here I'm going to create the logic to spawn those motobugs and attack Sonic. So the way I'm going to do that is I'm first going to define a small little function called spawn motobug. It's going to be an arrow function. The reason I'm doing this here is because really it's something that we're not going to use elsewhere. So for a little function like that, I usually use an arrow function like this, because remember, arrow functions have access to, well, here it's not relevant, but it might be relevant in certain cases where you want a function that has access to the same context as the parent function. So this, you want it to be the same. And one property of the arrow functions is that they don't create their own scope, their own this. So they inherit the this from their parent, so from the function that wraps them or something like that, which is pretty handy. All right, so now here, but for this specific case, it's just to have a little piece of reusable logic. So not really reusable logic, but just self-contained logic. So here I'm gonna create a motobug. So what this spawn motobug does, it first creates a motobug by calling the constructor that I defined, and then it's going to place it at 1920 by, for the x coordinate, or maybe 1950, so it's not visible at the right side of the screen at first, with the 773 as the y coordinates. This is what looked good after experimenting. So if you're wondering how I came up with those values, it's just trial and error. Now here for the motobug, I'm going to set an onUpdate loop for it. So this is something you can do in Kaplay, is you can have an update loop specific to that game object. So when the game object is destroyed, the event loop is also going to be destroyed, which is going to be good for performance, because you don't want an onUpdate loop that runs every frame to run even after the entity is dead. So for this, what you're going to do is if the game speed is actually we should have defined this, just, you know, let me remove that. Let's define it after having defined the game speed. So if the game speed is inferior to 3000, what we're going to do is we're going to actually make the motobug move to the right by a certain offset. So game speed plus 300. So it really looks like the motobug is going to the left and isn't stationary. So the move, the first param is the x velocity. By having it negative, that means we're moving to the left. And as for the y velocity, it's going to be 0. So what happens now is we're just going to return early in that case. But as soon as the game speed is superior to 3000, we stop moving. Well, actually, we still move the motobug, the enemy, but at the same speed as the platforms, the game speed. So it's at this point, it is basically stationary. And the reason I'm doing this is as the speed goes really far, the game speed increases a lot. It's going to be very difficult for the player to be able to dodge a moving motobug. So what I do is I basically make the motobug at those speeds stationary. They don't move basically, except they just follow the game speed. So they move at the same rate as the platform rather than a little bit more. So when you start the game, the plus 300 gives an impression that the motobug is actually moving to the left while the platform is also moving. But at really fast speeds, we actually just move the motobug at the same speed as the platform, and at that speed, it's not noticeable, and it makes the gameplay a little bit easier for the player. All right, so here we go. Now, as I said, I use the off-screen component so I can have access to the onExitScreen method. And what this onExitScreen method does is it runs a function when a game object that has the off-screen component goes off-screen, basically. And then here, you could go off-screen in multiple ways. So when we create the game object at first, it is off-screen to the right, but we actually want to destroy the motobug when it is off-screen to the left. So here I'm going to have an if statement called motobug pause.x. So this is how you access the position. So motobug.pause.x. Sorry, I did not explain this earlier. I just took it for granted in the previous things we did. Sorry. So this is how you access the x coordinate. Now, if this is inferior to 0, we can call the destroy function in Kaplay and pass the game object, and it's going to destroy it. And then finally, what we're going to do is we're going to set a wait time, which we can use the random function of Kaplay, and you can define a starting interval and end interval, and it's going to give you a random value between those two. So between 0.5 second and 2.5 second. Here it's just numbers, so it isn't considered seconds until we pass them to the k.wait, so the wait method. So wait method takes a time in seconds that it is going to wait and then run a function. So here we're going to use some recursive a recursive function. So we're going to basically call the function itself within itself after a certain time. And this is how you get an infinite enemy spawner. So here we have everything. Now we can just call spawn Motobug. So now if I do this and look at the game, you can see for now nothing is going to happen because they don't do anything yet. So yep. So I can still jump, and now it's time for the logic to actually make Sonic vulnerable to them, and also make Sonic, you know, not only vulnerable to them, but actually be able to bump on them as well to gain more rings. So the way we're going to do this is by using the onCollide. So Sonic dot onCollide. So the game objects have access to this method. It takes in as the first param the tag of the game object you want to check collisions with. So Sonic is going to collide with so onCollide is going to run when Sonic collides with any object, game object, that has the following tag. So the tag I decided here is enemy. So this is for the Motobugs. And when this occurs, it's going to run the function here as the second param. So this function, what it is going to do is going to first play, actually, if Sonic is not grounded. So in that case, which is a function, by the way, it returns true or false. So if Sonic is not grounded because of this, then I'm going to play the destroy sound at the volume of 0.5. I'm going to also play the hyper ring sound just to signify that the player has bumped into an enemy and is receiving more rings, basically. That's why the hyper ring sound. And then I'm going to destroy the enemy. Now you might ask how I'm going to get the enemy, since how do we do that? Well, actually, as the onCollide, what it does is that it takes the tag and it's going to pass the game object as a param to the function you call. So here, if you set it up, so choose a name for a param, what is going to be here is going to be actually the enemy itself, the game object with the tag enemy that has that collided with Sonic. So here it's going to destroy it. So there's two cases where the Motobug can be destroyed, either here or when they exit the screen to the left. So now that we have this, we destroy the enemy. Now we're going to also play the jump animation. So what happens in this case is that not only will Sonic destroy the enemy when they bump into it while they're not grounded. That means that they're jumping on top, or while they're jumping, they're hitting the enemy. So they're in their curve. Sonic is in his how we say, a rounded, curved form. So what happens, I wanted gameplay wise that when this occurs, Sonic will gain an extra jump. So we're gonna play the jump sound again. Now here, play the jump animation, sorry, not the jump sound. Even I, sometimes confuse those play methods and functions. One is for sounds, and one is for animations. And the one that is for animations is the method of a game object, while the one for sounds is directly from k.play. So here we are going to have a Sonic jump, and then we're going to actually we're going to actually make Sonic jump using the jump method that does it for us automatically. Now there's a bunch of logic we can add later on, where we're gonna add the scoring, multiplier, etc. Let's do this a little bit later. Let's see what we have now. Actually, before let's see what we have now, let's actually return early in this case, and have, if this is not true, that means Sonic hit an enemy while grounded. That means we need to play the hurt sound, so Sonic is hurt, with a volume of 0.5 to not be too loud. And then here we're gonna set the data. So here we haven't written the logic for the score yet, so I'm just gonna write a to-do comment here. And then here again, I'm just gonna go to the game over screen in that case. All right, so now if I look at the result, play the game, jump on the enemy, and I bump out. Now if I hit the enemy, I go to the game over screen. Well, also I hope you hear the sound. If not, you should hear it on your side when you're following the tutorial. So yeah. All right, so we have a big part of the gameplay done. So now let's write the logic for actually getting the scores. So setting up the scores, and then we'll write the logic for the rings, etc. So actually, let's first spawn the rings. So here, the same logic as spawn MotoBug. Again, this is something you could potentially find a way to modularize. So I'm going to leave this to you as an exercise. So yep. So I'm going to create a small little function called spawn ring. And in that function, I'm going to create a ring. And now here to do, yeah, I don't think it's valid code. So let's do this. Let's create in our entities folder another entity called ring.js. Now here, to be faster, I'm just going to copy and paste what I had. It's no new concepts except that we have different animations and a different tag. That's it. If I go back to game.js though, and yep, if I go back to game.js, let's put the ring here back. Now here we can call make ring. It's going to import it upwards, so hope it did it for you as well. So remember to check, or otherwise you're gonna spend some time debugging without knowing and waste a lot of time. Here I'm gonna put it at 1950, and for the Y value 745, like the MotoBug. And here again, it's the exact same logic, so that's why I said that you could write one function that does it for both the MotoBug and the enemy. So feel free to do this as an exercise. So here, game speed, same logic. On exit screen, same logic. The only thing that changes is the time, the wait times, which I think you can modularize this. So I'm going to leave it to you as an exercise. It's going to be a good exercise for you. All right. But sometimes, when you're developing a game, you're not sure if something is repeating yet. So you purposely write verbose code just so that in case, in the end, those two cases are not really the same. They cannot be modularized. In that case, you won't waste time by having like an early abstraction that you will have to disassemble because it wasn't the right fit. So something to think about. All right, so now if I call this spawn ring, it should spawn indefinitely because again, it's a recursive function. It calls itself every certain amount of time. So now if I go back here, press, and then you have rings. Now we don't have the logic yet to collect those rings. So let's write that. So here again, up in the, let's collapse this. Sonic on collide with the ring. Let's have the ring here. And then here. And then here again, there is some similarities. It's not exactly the same. Yeah, so here k.play, we're going to play the ring sound at a volume of 0.5. Then what we're going to do is we're going to actually destroy the ring. Again, remember, we have access to the ring game object provided by the onCollide event listener. Then here we need a score. So let's create, right above, or maybe, yeah, right above a score. Let score initially 0. And then let's also create a let score multiplier. And again, initially 0. So every time you bump, the score multiplier will increase. So here in the onCollide here, we're going to have the ring destroyed. And then here, we're going to increment the score. Now later on, we're going to update the UI for this, create the UI for this. And then, yep, so let's do the next, the rest later on. By later on, I mean just probably the next thing we do, but just to look at the results. So here we go here. If I bump, it just died. So if I refresh, let's skip this one. Let's skip, okay, you can hear the sound when collecting the rings. So that means it works. All right, so let's add our logic for our scores, etc., the score text, etc. So right above, here, I'm going to create a constant. By the way, the source code is going to be available in the description as well. So if you want to compare. So here, controls text is going to actually be the text. Okay, we're going to need a score text first, and then later on we'll think about it. The controls text is basically the text in the beginning of the game that tells you to, click, touch, etc. to jump. Basically teaching you how to play. So here we're going to create a game object. And what we're going to do here, it's going to hold the score. And here again, nothing new. So I'm just going to copy and paste what I have and paste it here. So now if I look at the results, you can see that it's at the top left corner. So now if I go back to the ring logic here, after incrementing the score, what we're going to do is, here you go, do score text, which is the game object. You can access, actually, if you want to modify the text of a game object after the fact, and you have used the text component, you can have access to it by taking your game object dot text, and then you can modify the content by assigning something new. So here what I'm going to assign is score. I'm going to use a template string and then pass in as a $sign the actual score, the current score. So here, if I go back and skip this one because we haven't written the logic 1, 2, 3, etc. 4, 5, 6, 7, etc. All right, we have our score logic, basic score logic working. Now we need to add this core logic to the motobugs, the enemy. So when there's a collision with the enemy. So the way we're going to do this is to basically have here. So after playing the hurt sound, I'm going to actually not here. What I'm going to do is first always set the score multiplier to being +1. Score multiplier when there is before, so when the Sonic jumps on an enemy the first time, it's just going to give you 10 rings more. But if you continue to basically bump on enemies one after the other, it's going to give you a multiplier. So it's going to multiply your score. So here, score plus equal 10 multiplied by the score multiplier. And then here's score text. Basically the same thing we did where we did it here. I'm just going to copy that here. So now everything should look great, should look good. Let's see if it is actually working. So if I bump on, if I bump on this one, +10. If I bump on this, okay, let's try a combo. So let's try to have a multiplier. So 10, 30, 60, 100. Nice. So now we need a little bit of visual indication, you know, because it's not enough. And also, what happens here is we need to actually reset the score multiplier to 0 when... Wait a minute, where did I do that? I don't remember actually resetting the score multiplier. Wait a minute, so let's play again. Let's say I have 1 and then 30. And then if I... Okay, we need to reset the score multiplier once you hit the ground. Otherwise, things are not going to work. So I think I did this in either the Sonic.js. This. Did I do it here or maybe... Actually, we should do it... So if you're grounded and you collide with the enemy, you do this. But actually we want that if you're grounded at all, we need to reset Sonic. Yeah. So here you're gonna add an if statement in our on update. And we're basically going to do if Sonic is... So the reason I'm doing it here instead of in the Sonic logic is that we don't have access to the score variable. So score multiplier, gonna reset that to 0. You could have decided to do it elsewhere. Maybe you could have decided to store the current score in local storage and then call from the Sonic set events here the local storage with the current score and the current score multiplier, and then set it here. That could have been a pattern you could have decided to use. Alright, but this is a very simple game, so I don't think it's really worth it. Alright, so now what we're gonna do is actually go here and remember I created this constant as a Sonic constant as a way so that we can create a child game object later. So let's create this child game object. So the way you create a child game object is that you take a game object and you just add to it. You just call the add function on it, and it's going to create a child game object. So what is going to be the game object? So this is the usual way, but to have things more convenient and organized, we're going to create a ring collect UI property that is going to be null here. And then instead of calling the Sonic add immediately and just... Because by default, if you do this, to access the children later on, you're going to have to do Sonic.children and then array 0, etc., which is less convenient and less understandable. You will not understand it if you're not familiar with the code base at all. If you see this. So what I do is Sonic.ring collect UI, and I'm going to store the child game object here as well, so that someone is going to understand. Here, the components I'm going to use are these ones. So first, an empty text with the following font and size, and then I can use the color component to have this text of a yellow color. So this is the RGB value for yellow. I'm going to put the anchor to being center, and then the position to be 30 minus 10. And this position, because what we're creating here is a child game object, it's going to be relative to Sonic. So these values are relative to Sonic. So now what I'm going to do here, it's going to be... Let's first do it with the ring. So we have a score here, but we're also going to have the UI thing. So for the UI, what I'm going to do, when you collect a ring, I'm going to first check if the score... So if the score multiplier is equal to 1, I'm just going to put it a +1. Actually, you know what? This is not here at all. Anyway, we need to actually do Sonic ring collect UI and then text, and then have a +1 text, and then wait, after 1 second we will dispose of, we will remove the UI. So we we aren't going to delete the ring collect UI game object. We're just going to set the text back to being an empty string. So if I go back and look at the result, I click here, and then here nothing happens, but +1 and then disappears. +1 and then it disappears. +1 and then it disappears. So for the enemy, the same logic applies. Here, if so, score Sonic ring collect UI, and then text. Then the text is going to be this time around the template string because it depends. Plus, oops, yeah. So plus, and then $, or actually, here it's going to be different because if by default it's going to be plus. So if the multiplier is a score of 1, so if we have a score multiplier of 1, we're just gonna have here +10. So let's just have a string. However, if okay, let's just have a second if the score multiplier is superior to 1, then we're gonna have multipliers instead being displayed. It's going to be more understandable for the player than, you know, seeing 30, 20. You might not understand why. So here I'm going to use a template string and then $, and then here I'm going to use score multiplier times 10, and then here an X sign instead because it's actually never mind, don't need to like that. Here we go. So now if I look at the result, I bump on this one +10. Okay, you need to do it more than once. Okay, I forgot the logic to actually delete what we have here. So again, like we did with the rings, we need this wait thing 1 second, and then we put it back to an empty string. So if I look at the result, I bump on this guy, and then okay, let's try to have a combo so that we can actually see the multipliers in action. Okay, can we actually multiply by 2? Ah, okay, but you actually can see, you know, multiply by 2 and then 3, etc. So 1, 2, 3, 4, 5. Oh, that's nice. This is not a pre-planned, huh? It was a matter of skill, I guess. I'm just too skilled, I guess, to my game. Anyway, so here we go, and I think that's it. So here, when you hit the enemy and you're not grounded, it's game over. We're gonna set the current score using set data so that we can have access to the current score in the game over screen. You could have decided to do this, or you could have access to it by passing it as a second param to the go function, which is going to take care of passing data from one scene to the next. But I don't really like it that much. I don't like to use it that much for stuff like that, for data. So we're gonna use it in this tutorial, but for sounds, because the one we're gonna have, you're gonna see in an instant. So what I'm gonna do is, okay, so we have the current score, and then here what we're gonna do is I'm just gonna pass this the score, and then for now that's it. Now I'm gonna add the city sound effects, so the ambiance here I wanted to add, and let's add it at the top of our scene, maybe right after the gravity or before, it doesn't matter. I'm gonna create a function, a constant called city sound effects, and it's going to play the city sound with a lower volume because it's too loud, even louder than the other sounds. So that's why I need to put it to 0.2. So volumes can vary between 0 and 1, and I'm gonna loop it. The issue is that if you use loop true and you don't store your sound inside of a constant, that means it's going to play even outside of scenes of this scene. And that's why when you hit the game over screen, I want to be able in the game over screen to remove this ambiance because it doesn't fit. So as the second param of the go function, I'm going to pass the city sound effect. By the way, this is a shorthand for doing this. If you want to pass it. So by just doing this, you can pass. So what I'm going to do here is I'm going to go, now it's time to go to the game over logic, which is empty for now. Just to be a little bit faster, what I'm going to do is I'm going to go to game over and I'm going to, you know what, let's type it out. So import k from Kaplay context. Let's create an export default function game over. And here it's going to take the CD sound effect as a param. Now this is not very elegant, I think. So maybe it would have been better to, I don't know, have a global state manager, but I didn't want to overcomplicate this tutorial. So maybe in the future we're gonna make some more complicated games as well. So in that case, so you can actually watch the Zelda-like where I used the state management. I did something for state management in that tutorial, so you can watch that. So here the function, the game over function, what it does, it takes the CD sound effect and just set the pause property to be true. That way it's going to not play. And then here we're also going to have a best score variable, which is going to get the data from local storage for best score. Remember, when you start the game, best score is created. So even if the best score is 0, it's going to be defined here. Then we're going to create a current score constant to get the actual current score of this run. It's going to again use the get data for this attribute we've defined in our game when you die, and the only way you can die in this game is if you hit the enemy while you're not while you're grounded. So here, current score is where we set the data for the current score. Now here, I'm just gonna copy and paste those two values, which is the rankings. I like to add rankings in arcade style games with a letter grade and then the rank value cutoffs here. So here you can copy and paste the code. Now, by default, we set the current rank and best rank to being in both F. And then we have a for loop. Let me just copy here, just go a bit faster. So this for loop is going to iterate through the rank values, and then if the rank values .i, so the specific rank value is inferior to the current score, then we set the current rank, and we also set the best rank at the same time. So this is how we do it. Now we could have used an easier for loop. I think you could have used the easier version of the for loop. So that's something to think about. Maybe try to use the for const off. Maybe you could get away with that. Yeah, probably I didn't think of it when I was writing the code for this. And then now we need another if statement to check. So if the best score is inferior to the current score, we will set the best score to the current score. That means a new record was beaten. And we also need to swap the best score for the current score in this the variables, because we're going to display the results, so best rank, etc. So for next time, it's going to having set the best score to the local storage, but for this time, because we're still in the scene and we're going to display things, we're just going to use just going to also modify the current best score here and best rank variables. And then finally, one of the most tedious parts is the texts for everything. So here, I'm just gonna again copy and paste. So here, nothing fancy, just game objects with text components. It should be, yeah, it would be nice to have a easier way to have just text instead of having to create a game object like that. So maybe create a reusable function, call it make text or something like that. So yeah, something you can either write yourself to save some time later on. So here we have the game over screen, size of 96, positions here, anchor center, best score, current score, etc. And then finally, we're going to create two boxes. So we're going to have, first of all, a best rank box. So you're still within the function. A best rank box, which is going to be a rectangle with a radius of 4. Its color is going to be black. But the outline is going to be this. So you can use the outline component to find the outline and then the color for that outline. So the radius is how rounded the corners are. And then the outline can define the thickness of the outline, which is 6 here, and which color. It's going to be a white outline. So it's going to be a black rectangle with a white outline. And then we're going to add as a child of that rank box the actual text, so the rank itself. So same logic applies again to the current rank box. So this was for the best rank box, but now let's do it for the current. So here we go, and then here, typo. Same logic, just different positions. And then finally, we're gonna have a wait loop function, handler, which after 1 second will display the text to press, space, click, touch to play again, and will set the on button press event listener of jump to go to the game. This so you can restart the game. The reason I delay this by 1 second is that if you're playing, you might accidentally, as soon as you lose, click again, space, and it's going to restart the game immediately without letting you have the opportunity to look at your scores. So now that we have this, we need to go here to the, we need to go back to main.js to hook up the game over scene. So here, instead of having the game over scene, you can have it this way. So just call game over here and pass it here, and then game over is here as well. So now let's play the game. So if I try my best, +10, +10, +40. Let's try picking up some rings. You can hear the city sounds on your end, hopefully. Maybe the sound for my setup is not too loud, so you won't be able to hear it in the video. So I do this. Let's okay, so +1. I think we have the, here we go, +10, +10, +10. So the current best score is 78 because it's the first time we were playing, and then press play, space, click, touch to play again. So if I press, and now if I try to beat my score just to show you the difference, +2, then okay, maybe I'm gonna beat my score. I think my score was 71 or 78, so I need to beat it just to show you the difference. So let's do that. I'm not a very good Let's Player. I cannot think of conversation subjects while playing games. I'm trying to focus on the game. Okay, so now we have beaten our score. Actually, it's the contrary. I need to not beat my score. So let's die here. So you can see that best score E rank, current score 0 F rank. And then if I die here, 10 F, etc. But I still hear the background noise, even in the game over screen. We wrote logic to not have that, so there's an issue. So how are we going to fix it? So the issue stems from probably here. So in my original code base, what I wrote was that if main.js, if you do this, so yeah, give me a second. So there's an issue here because I forgot to pass in game.js. Okay, I did pass it here, so that's strange. There's something strange here. Ah, I see. I don't need to pass this as an object because the gameover.js function, the gameover function, expects this as the first param and immediately to have access to it. So the error I did was to pass it as an object here. To just pass it as the second param of the Go function immediately. So now if I look at the result, and then you hear the city sounds, maybe you don't hear it, and then I die. Oops, I didn't die. Now everything is silence. So you hear the hurt sound of Sonic, and then everything is silence here in the game over screen. All right, so that's the game. Hope maybe I need to teach you, of course, how to put it on itch.io or some website. So what you need to do when you have done your project, so I'm just going to close a bunch of tabs just to free things up, is you need to open up your terminal, and you need also to create, first of all, you need to create a vite.config.js file. Then you need to import define config from Vite, and then you do export default define config, and then within it you pass in an object, and in this object first you need to specify the base as being /. If you don't do that, you're gonna have issues. So what you're going to do now is you close the game, you do npm run build. npm run build. It's going to build the game and create a dist folder here. And then if you want to check that the output actually works great, you do npm run preview. And then I'm just going to copy that link and then paste it here. And then your game should run without any issues. Now, the only thing left, of course, is that you take the content of your dist folder. You zip it, and then you can host it on itch.io, GameJolt, etc. So this is actually what you distribute. All right, that's how you do it. So hope this tutorial was helpful for you. If you enjoyed it, feel free to subscribe for more content like this, and thanks for watching. Bye. Hi everyone, welcome to this new tutorial. Today we were going to build a Metroidvania style game. So Metroidvania is a style of game where mostly they're usually platformers, and the difference between a normal platformer and a Metroidvania style game is that in a Metroidvania you don't have levels. You explore one big map, and some parts of the map are cut off or not available to you if you don't have certain abilities. So the whole point is to explore the map, unlock new abilities or find new items as you explore, and this will unlock certain parts of the map that you weren't able to access before. And here is the simple version of that. So here we have a little robot with a sword attack, and for now we cannot go to the right because we don't have the double jump ability. So as you explore the game, so here is a health pack. As you explore the game, for example, I go here. The goal of the game is to find the exit, which is, so basically if I start the game from scratch, you have this, escape the factory, use the arrow keys to move, X to jump, and Z to attack. So here, if I explore, you can see, for example, the second room, and there's something down below. We want to see what it is, so I'm going to go to continue my exploration. And here we have drones. So drones will follow you and self-destruct. So I'm going to teach you how to code that as well. So here I have, so just to show you a full overview of the game before we start building it. So here's the layout, etc. And now here I cannot double jump here. If I do, I'm going to die. So now let's beat the boss, which is going to allow us to unlock this ability. So the boss we're going to beat is this one. So as you enter the boss room, you cannot exit out of it. So that's a bit like the Souls games. And then this little boss has a flamethrower. And basically the way is we just avoid his flames and we hit it. So I'm just going to do this very quickly. And then after that, you're going to see that we're going to unlock a power-up, which is you unlocked a new ability. You can now double jump. And then here, I can go here. And this was previously inaccessible. It's a shortcut. And I should not die here. I just died. Anyway, the game will save. So you still have the double jump ability. And now that we have unlocked this, we can go back to where we couldn't proceed. And then I'm just going to beat this one. And here you get access to the second room. And as you see, the camera is dynamic. It will follow when the player passes through certain things. It's going to follow. I just died here. It's going to follow the player, or not follow, but just change angles and positions to better show the rest of the level. And that's the game. Now, to draw this level, to make this game, I'm going to use Kaboom, which is a library for making games in JavaScript. It's very easy to use. And so I'm going to teach it to you as well. So the prerequisite for following this course this tutorial is that you know at least the basics of JavaScript. We're also going to use Tiled, which is this program I have here, to draw our level layout. So because we're not using a traditional game engine, that means that we don't have access to a level editor like in Godot, and that means we need to use an external program for that. Otherwise, it would be too tedious to draw the level layout in code. So here, Tiled is a nice program that fills this gap. So I'm going to teach you how it works basically, but I will not go into too much details. So I'm going to teach you how this map that I made works. So these two rooms, what are all these colliders, etc. But I will not, like I did in previous tutorials, redraw the map from scratch and show you how it's done, because it's going to be too tedious to replicate the exact same layout. So consider these maps as assets. They're going to be .json files in the description that you can download, and you're basically going to import them into your game. However, I have written a guide, so I'm going to spend some time to explain how to draw maps in Tiled at a higher level, but I'm not going to go in the nitty-gritty details for this specific project. However, if you want to have a written content, I have written recently a blog post on how to use Tiled with Kaboom.js. So here's my Substack. It's where I write content. This is where I do written tutorials. So my YouTube channel is really a good fit for project-based tutorials, but sometimes you just want to know how to do a specific thing, or you want to reference something that you found in my tutorials, and referencing a video or a specific part of a video is usually tedious. So having a blog post nicely written like this is how I do things to I use this as well for myself, so I can reference back when I need it, how to import maps from Tiled, how to use Tiled, and then use them in Kaboom.js. So if you're interested, give me a subscribe here to not miss on future written content. So the link will be in the description. Alright, so now for the setup, I'm going to use VS Code for this project, and I recommend that you also do, because we're going to use the live server extension, which can be found in the extensions marketplace, live server, and then install it here. It's written uninstalled because I've already installed it. And this allows us to start a local server for a project, and it's very easy. However, if you have your own setup, feel free to use it. You can start servers in other ways. One example would be through Python. You can start a local HTTP server with it. So let's jump right into the project. So I have my workspace here. I created a folder. I called it Metroidvania tutorial, but feel free to call it however you'd like. All right, so now I'm going to create an assets folder, and this is where we're going to put the assets for our game. So the assets are mostly coming from an asset pack on itch.io. So I'm going to provide the link for that in the description. However, there are two sprite sheets within that I'm going to replace with my own, and those two will be in the description as well. The reason I'm replacing them with my own is I just reformatted them so they fit better and can be imported in Kaboom easily. All right, so let's create an assets folder here, if not already. I'm going to also create another one, which is going to be the lib folder, which is where I'm going to put the version of Kaboom. So for this tutorial, I'm not going to use Node.js. I'm just going to use the simplest setup you can for Kaboom, which is just taking the JS file and then importing it into your project using native JavaScript modules. So if you want to use Vite, for example, or a Node.js based setup, feel free to do so. And if you're not sure how to do that, look at my previous tutorial where I made a 2D developer portfolio. This is where I used Vite and NPM. So you can just take the setup portion and then follow along with the rest for this tutorial. All right, so I have the lib folder here. I'm going to put later on the library here that I'm going to download. This also will be linked in the description. I'm going to create a maps folder, which is where we're going to put the maps. So the two .json files that I've shown you earlier here. Then I'm going to have the source folder, which is going to contain most of our code, an index.html, which is important because it's the entry point of our program, and that's basically it. So for the index.html, I'm just going to write the code, start writing the code. So I'm going to write the HTML tag, a body tag. It's not very important for a game to have this markup, to have a like really deep markup, a lot of boilerplate, etc. So I'm just going to use a simple markup HTML body tag, and then within we import our script from the source folder. So I'm going to do .source.main. It's important to use a relative path, because if you're going to put this on itch.io, it uses relative paths to be able to load your game. So that's why I use a dot here instead of just writing the absolute path. This file does not yet exist, so let's create it. So main.js. And then here in index.html, we need to also add the type of it to be module. The reason we're doing this is because we can, without this, we cannot use the import syntax. You cannot use import X from Y. This is called native JavaScript modules, I think. All right, so now that we have this, let's save everything. All right, and then I'm gonna import the files now. So let's see if this works. Can I just drag and drop? Can I do? Cannot. Okay, so I'm gonna have to do this differently. So I'm gonna drag and drop the versions. So here, what I like to do when I'm not using NPM is just to have a simple text version that tells you where to get the library and the version of it. And here the .mgs file is what you need to install, to download. So the way you do that is you go to this link. It's going to be in the description, hopefully. And then you're gonna be brought to a page with random code. So let me just open it up. It's not random code, actually it's the code for the library. What you do here is you right click and you click save page as, and it's going to save it as a kaboom.mgs file. And then put that file into your project. All right. Now for the assets, I'm gonna do the same thing. So I'm just gonna import everything. So we're also going to have some sounds, by the way. Those sounds are free of use, but there's one sound that I put the credits of. So yeah, for the sounds, a link will be in the description as well. So the two sprite sheets that I've personally modified myself is the burner, which is the boss, and the u.png, which is the player. I had to tweak the jump animation and the placement of the jump animation, and for the burner I had to center everything, otherwise the character, the sprite sheet wouldn't be displayed properly. The animation were weird. Yeah, so it's a bit hard to explain what the issue was, but if you have the original and you try with the original, you're gonna soon realize the issue. And we also have this glyph mess.ttf, which is the font we're gonna use. This is provided by the asset pack. So everything here is provided by the asset pack in the description. But as I said, for burner and u.png, replace these with my custom ones. All right, so here you have the sounds, etc. Okay. Now let's go to the maps and let's import them as well. So there's four things. So I need to explain something here. So here room.1.json is the file basically with all the data needed to draw the map. This is from tiled. There's also room1.png and room2.png. And the reason we have room1 and room2 here is because in Kaboom.js, strangely enough, it is more performant to just go to tiled and then export the map as an image, and then just it would be one single sprite and display it as a single sprite rather than drawing every tile as in your logic from the sprite sheet. That's why I have exported both a room1 and room 2 as PNGs. And the reason what the JSON is for now is just to know where the colliders are. So that's the use for that. So usually in game development libraries, you would just only need the .json file. And you can do that in Kaboom.js. You just need that and not you wouldn't need the other ones, but it would be less performant because the way you would draw is you would take your original asset, so your sprite sheet, your tile set here, and then draw from there. But for some reason in Kaboom.js, if you do that, it's less performant than just baking all your world, your map into a single image and then just displaying it. So with pixel art, it isn't that big of an image, but you also need to think of the network considerations. So since this is a web game, maybe you don't want people to have to download two bigger images, and if you could only use a single small image, it would be better in terms of like loading. But I think with games, people are more forgiving when it comes to these stuff rather than a normal website. You shouldn't exaggerate, but I think that's usually the case. You're usually more willing to wait a bit before playing the game rather than if it were a website that you need to use immediately. All right, now that we have that, I think we can get started with importing Kaboom into our project. The way we're going to do this is I'm going to use a file. I'm going to create a new file. I'm going to call it the Kaboom loader.js. This file is going to be the one importing Kaboom because, okay, so I'm just going to do it and then you're going to see why. It's going to make more sense like that. So what we're going to do here is I'm going to write an import statement. I'm going to import Kaboom from, and the nice thing with JavaScript modules is that you can just do lib. You can import the MJS file immediately like that without any script tags. So once you do this, so just the path is from the lib folder. So here we are in the source folder having ... That means we go up to the root of the project and then we go back in lib, the lib folder, and then kaboom.mjs. And then here I'm going to have a constant. I'm going to call it the scale. I'm going to scale probably the game 2 times. I'm not sure actually if I use, this is going to be a fix around an issue that's going to come up later. So for now, just have this constant up as the scaling. And then here, export const k is going to be the Kaboom context. And the way you initialize the Kaboom canvas is by calling the Kaboom function and then passing it an object which contains a bunch of properties you want. For example, I can specify the width of my game. I want it to be 640, and the height I want it to be 360, and I want it to have the letterbox option to being true. So here, if for now nothing happens, but I also need to I forgot something very important. Global should be false. So global, the reason is by default, if you import Kaboom, you just can start using the Kaboom functions immediately. But what I prefer to do is to store the Kaboom context in a constant and here k, and all Kaboom function will have to be prefixed by this k dot, and then you call the Kaboom function you did. This makes the code cleaner, in my opinion. So now, so now if I go to main.js and import the, so I'm gonna import k. So import k from Kaboom loader, because we're using JavaScript modules and not using an NPM based workflow. We need to specify the file extensions, otherwise it's not gonna work. So Kaboom loader.js, and then here, just by doing this, if I click on the Go Live button, which is at the bottom right of VS Code, you should be able to see the canvas being initialized. Now, one thing I want to add for this project is in the index.html. I'm going to add a bit of styling. I want the background to be black, basically. I think it's going to be better than white. So body, And then I add the background, not necessarily color, just background, and then black. And now if I go back and look at the result, you have a black bar. So we nicely like see the difference between the canvas and the rest. Now there's one thing I wanted to do before, and the reason I had the scale here is because I want the canvas to be scaled as well. So this is a shorthand in JavaScript. When you have a property that is the same name of a variable, you don't have to do scale, not scale. You can just use scale like that as a shorthand. Now, and also I need to multiply by the scale here. The reason I'm doing this is that in Kaboom.js, the pixels, certain pixels can, it's a bit hard to explain, so I'm going to make a schematic. Excalibur.com. Alright, so we have Excalibur, maybe dark mode here as well. Do we have dark mode? Alright. So in Kaboom.js, and not necessarily only in that, but I've noticed it in Kaboom, is that when you have pixel art, so imagine this is one pixel, okay? And imagine that we have a drawing like that with multiple pixels. So let me just zoom in. It's not going to be perfect here. Okay, we have this letter, I guess. So yeah, so we have this letter. Let's see, we have it as 0. Okay. Imagine this is a sprite. The issue is that in Kaboom.js, sometimes a pixel will take more space than a pixel, and you will have like a bit of padding like that, a bit of padding like that, and that means that this pixel and this pixel, in theory, like in the sprite art, should be the same size, but somehow it's not the case. And this issue is not entirely resolved. So if I go back to the original game, is it working? Okay, I need to refresh the game. Sorry. So maybe you can notice it. So this is with the fix. Even with the fix, there's an issue. But if you look here, you see? You're probably not gonna notice it, but this pixel right here, I think it's better, it's more visible here. So maybe go full screen. This pixel is not the same size as this pixel, even though they're supposed to be the same. And this is something, a rendering padding issue, that Kaboom adds some padding, and this caused this. And this is the less worse variant of it. So this is barely noticeable, and it's barely noticeable because of the fix the hack I used here. But if, the hack is basically you set a scale value, which can be 2 here, you multiply your width, you multiply your height, and then you also set the scale as well. So this hack allows us to reduce the, to not have this issue, but to have it less visible. So it's something in Kaboom I didn't want to modify the source code itself, and even when I tried to fix it, didn't work. So if you're a Kaboom maintainer, maybe fix this, and that would be great. So yeah, so maybe you cannot unsee this anymore. So yeah, sorry for making you notice something like that. All right, let's go back to the project. So now in the Kaboom loader, the reason I call this the Kaboom loader.js is because not only we're going to load the Kaboom library here, but we're also going to load our assets from this file. So in previous tutorials, I would use a Kaboom context and then just have this one and then do the loading in the main.js. But I thought to have everything that relates to loading things from Kaboom to be in the Kaboom loader file. All right, so let's load the various assets we're gonna need. I'm trying to think, maybe it's not the best to do this directly. I think we could do, if we do this once and for all, and then we won't have to worry about anything related to animations. So this is something that is very tedious to do. I would recommend that you just copy and paste the source code. So by the way, the source code is available on GitHub. So this is something I would not like to spend much time typing it out. So I'm just going to explain everything. So how we import assets in Kaboom. So the way assets are imported in Kaboom depends on the assets, of course. We have the way to load fonts is by using the load font method provided by Kaboom, and that's why I like this pattern of having Kaboom as being non-global, is because you can immediately see that if the method is prefixed by K, that means it comes from Kaboom. So the way you load a font in Kaboom is by using the load function method here, and then you pass in the name you want to use to refer to in your code for this specific font, and then the second one would be the path to that font. So this is how you load a font. There's also load bitmap font. I think it's another one where your font is an image and then you specify each character the value, but this is not relevant to this tutorial. To load sprite, or sprite sheet, etc., you use the load sprite method, and it's basically the same thing. If it's a single image you want, so let's say you have only one frame in a .png file, you would only need to first specify a name for your sprite that you want to refer to, and then pass in the path, and that's it. You would close the parenthesis. However, in this case, we have a sprite sheet. That means that we have multiple frames located in the same image, and to tell Kaboom how to slice it, we have to pass in a third param, which is an object that is going to contain all of this information, with also the animations we're going to define. So let's have a look at the sprite. So here we have the player sprite, a sprite sheet, which is located under the sprites folder and under u.png. And here we have a bunch of frames, and I realized one thing is that it's not going to be very visible, unfortunately, because the colors, okay, maybe I should open ASprite. So this is ASprite, which is ASprite, which is the software I use to draw pixel art. So here we can better see the sprite sheet. So the way Kaboom slice sprite sheets is, first of all, you need to specify the slice x value property and the slice y property. So slice x is basically the amount of frames per row. So in our sprite sheet here, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 slots per row. So that's how we determine the slice x value to be 8 by 9 slots per column, because this is how 1, 2, 3, 4, 5, 6, 7, 8, and 9. As you see, there's a lot of animations here. We're not going to use all of them. So here it's slice 9. Now, for defining animations, you specify the anims property, and then you pass in an object, and each of these entries are going to be the various animations. So for the idle animation, so those names here are names that I have arbitrarily so those names are names that I have arbitrarily chosen for myself. So you can decide to name them however you'd like. So here I decided to name it the idle animation. And by the way, it doesn't have to be a property like that. It could be a string with I don't know, maybe idle dash player. You could have decided to name it this way, but we're not going to do this here. So here, idle, and then you pass in another object, and this object needs to have the from key, the to key, and the loop, whatever or not you want to loop. And this is optional, but the two main things is these two. You need to basically specify that. However, you can specify an animation as being a single frame. So for example, I don't know, idle 1, I guess, and then I would just specify frame 0 like that. You can do that when you need to just have one frame. So here, from 0 to 7, what does that mean? So this animation that we define as idle is going to start at frame 0. So the way frames are counted in Kaboom, once you have specified slice x and slice y properties, is as follow. So you have 0. You start at the bottom, the top corner, 0, 1, 2, 3, 4, 5, 6, 7. And by the way, you don't count the frame, you count the slots, because even this empty frame is considered frame. So you would have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14, 15, 16. So here for the idle animation, it's basically 0, 0, 1, 2, 3, 4, 5, 6, and 7. So the first row would be the animation. So from 0 to 7. And here I specified the animation to be looping. That means it will always play. When you start playing it, it will not stop playing until you stop it manually. Certain animations like running, jumping, falling, and idle itself are good to be, we want them to be infinite like that, and we decide when to cancel them. But as for explode or attack, when an enemy explode, etc., it's just a one and done animation. And for the attack animation, also it's a one and done. We want the attack animation to run and then to stop. When the attack animation is done, the attack is done. And here you also see that you have other optional properties like the speed property, which you can specify the frame rate. Here 16 was a good was a value I thought made the game look good. So that's basically it. You have also another one called the load sprite atlas. So the difference between a load sprite atlas and a normal load sprite is the following. So with a load sprite atlas, you're you're basically cutting out a specific portion of an image. So for the UI, you have this whole thing, and I only need this part, but instead of just like cutting it off, what you can do is just use a load sprite atlas in your code. You specify the file you want to load, and then here you can cut out a specific sprite from it. So here I decided to have a sprite called health bar. It's going to start from within the image at coordinate x 16 and y 16. So you take your image, the coordinate 0, 0 is at the bottom, at the top left corner, and as you move here 16, and then you drop down 16 here, and from this point onward, you're gonna cut the image with a width of 60 and a height of 40. So this is going to cut the image like that and only keep this portion. And then after having done this, I'm going to also specify a slice y as being true, 3. That means I just want to cut out the, basically set this as a sprite sheet. So first of all, I cut out from the rest of the image only this portion, and then I set it as a sprite sheet by specifying the slice y value. That means that every frame, so there's only 3 frames in this portion, and it's going to be the health bar. So the first frame is going to be frame 0, frame 1, and frame 2. So this is how you would do it. If you had, for example, this part, if you wanted to cut out this part, you would specify different x and y values, and then from there different width and height value to just keep this part. And then here it would be slice x3 because there's 3 slots per row, and by 3 slice y will be 3 by 3, so 3 by 3. Hope that was clear. And that's basically it. So here for the sounds, it used the load sound method, and then you specify the name and then the sound. As easy as it gets. So copy this from the source code on GitHub. I think it would be better that way than me typing it out. So assuming you have this done, our assets are all loaded. So yeah, I might come back here to tweak certain animation, but I shouldn't have to do that because this is taken from the final project. So if we go back to our browser tab, we still have our canvas, so nothing changed, and that's pretty normal. All right, now let's wondering what we should do next is continue creating our folder structure. So I'm gonna collapse this, collapse this, collapse this, and then here in our source folder, I'm gonna create an entities folder. This is for the player, the drones, the boss. I'm gonna put the logic there for them. I'm also going to create a scenes folder, which is going to be the various scenes. We only have 2 scenes here. We have the room 1, which is the big map here, and then we have the room 2, which is going to be just a smaller one. So you can see that if you were to expand this project, you would have a multiple images like the multiple rooms like this that would comprise the whole world. So after the scenes folder is created, I'm going to also create a state component, folder. This is where we're gonna hold the global state. Yep. So I think, and finally, sorry, I forgot. We need the UI folder for the UI. So now we have a neatly organized folder structure. So let's start with the scenes. I think this is the most important part. So let's define our first scene. So our scene, I'm gonna use the concept of rooms, even though this is much bigger than a room, but I started with this. Initially, I didn't think Kaboom could handle bigger maps, so I thought that I would just have multiple rooms stitched together, but in the end it was able to, so that's great. So that's why the name stuck, because it felt too much of a hassle to just change everything now. So let's create a file called room1.js. And in this file, I'm going to have to export a function, async. It's going to be async. I'm going to explain why later on. That's probably because we are going to have to import the map. Actually, I don't think we're going to need the async here. So you know what? Instead of writing async and not knowing why, I will just write a normal function. And then when a time comes and we see that we need it, I'm just going to add it back. So why I'm doing this. So for now, let's create an empty function called room1, and it's going to contain all the logic defining our scene, this scene. So, yep, and I'm gonna leave it empty for now. Let's create another file in the scenes folder. I'm going to call it room2.js, and it's going to be again the same pattern: export export function room2, and it's going to be empty. Not page transition. Sorry. I messed up. So export function room2. Come on. I'm struggling with my own keyboard. And I made a typo as well. All right. So another function here. And also, like with room1, it's going to contain all the logic we need for our scene. And then in main.js, I think it was in main.js. Yeah. So in main.js, we're going to define our scenes. So here, I'm going to create a function. I'm going to call it main. Actually, you know what? Let's do it directly. So to define a scene in Kaboom.js, use the scene method. And the scene method takes a name, which is going to be the name you want to use for your scene, to refer to that scene. It's a key, basically. It can be anything you want, as long as it's a string. And then the second param is a function, an arrow function, but just a function. And this function is going to run when the scene is called. So here, for now, I'm just going to import room1 from that file and just call it. For now, there's nothing that will happen from this. Optionally, you could have decided to just pass in room1 without the arrow function and just the name. And because room1 is a function definition, it's going to call that function definition. But the reason I'm using an arrow here, an arrow function, is because we want to have like the previous data of the scene at one point, which is Kaboom is going to pass it to this function, and later on it's going to be clear. So for now, I'm just going to leave it empty. So I'm going to define another scene. I'm going to call it room2. And I'm going to have an arrow function as well. And room2. I should import it. Yep. So bubble. Your editor should here we go. I have room2, and I'm going to call it. Okay, that's for now. And let's have the intro scene, which is the scene you saw that just tells you the control. I know it's a bit lazy to have a scene like that, but because this is for a tutorial, I didn't felt like having a whole menu and yeah, all that stuff. So I just stitch together a simple intro scene that just tells you the controls. All right, and then finally we're gonna use the go method, which basically tells Kaboom to go to a scene. This is important. When you define scenes, you need to use that go function. Otherwise, actually, you don't have to. I don't think you have to. You could have the default code. For example, you could start writing your logic here, and it's going to display. But usually, the pattern is that you define your scenes, and then you call the default one, couple one. Otherwise, you're gonna not know why your scene is not displaying if you don't call it within the main.js file. All right, so we have this here, and I think we're ready to see if anything changed in our project. I don't think anything changed, but you see the loading bar. That means that the assets are indeed being loaded. The loading bar, sorry. All right, so now let's go back to room 1, and here for room 1, I'm gonna first have our first param, which is going to be the k. Instead of having to import k from the Kaboom loader, oftentimes I will just, pass this k around here. That way I don't have to write this import statement. But I think both approach could work. You could decide to import every time you need k, you just import it from this file. But for some reason I find myself doing this, and I think it's more convenient, I guess. You don't have to import anything extra. All right, so I'm gonna import the context here, and just to test things out, let's create our first game object. So if you're not familiar with what game objects are in Kaboom, well, it's time to explain this. So Kaboom allows you to create game objects. Think of game objects as entities for your game. They can be platforms, they can be players, enemies, drones, etc. But most importantly than not is that a game object is an array of components. It's made of an array of components. Those components are mostly all, but you can make your custom components, are offered by Kaboom. And this is what one of the driving strengths of Kaboom is, that it makes creating game objects very easy, and it speeds up your game because there's a ton of functionality that you get for free. So that's why Kaboom.js, I think, could be like literally called a game engine rather than a library, because it offers that much. So to create a game object in Kaboom, you can use two functions, two methods. You can either use the add method, or you could use the make method. The make method creates the game object but does not add it to the scene, so it won't be visible, while the add method creates the game object and then display it on the scene as well. So here, for just testing, we want to add to the scene, so to the canvas, and we're going to use the add method. The add method takes one param, which is an array of components. So components, so for example, you can have the text component. This is offered by Kaboom. You can just pass in some text, hello world, and then you pass a second component, which is the positional component. This is also offered by Kaboom, and it's where you want to put this on the canvas. Let's put it at 100 by 100 just to test things out. So here we have our first game object, which is a basically text-based game object. So if I go to see the result, and it's not going to display because we wrote this code in the room scene, but we first went to the intro scene. So let's change this temporarily to room 1. So we go immediately to the room 1 scene. So here you can see hello world in the default font. Now, because we already imported the font in here, we can just use glyph mess here. So something specific to the text components that can take a second param, which is where you define the font with the font property. Glyph mess, oops. And there's a bunch of other properties like the size, the text wrapping, etc. But for now, let's use one property. So now if I go here, you can see hello world written in the font we're going to use for the game. So this is how we create a game object. So, but this is not what we actually want to do for this project. What we want is the actual to actually display the room level. So this is what we're going to do in the next portion of this tutorial. We're going to write the logic to display the maps. I'm going to spend some time hopefully explaining how tiled work and how all these layers, etc., how to make sense of all of this. I also recommend just also reading the blog post I wrote, which is a stripped down, very simplified version of this, just to explain how tiled work. And I think it does a better job than I could do right now. But I'm gonna try to explain those also. Okay, so now we're gonna write the logic to load the map. And the way you load the map, well, before that, let's first color the background. So the background color, I usually don't do that in tiled. So if you see the map here in tiled, it's transparent. Here, the uttermost layer, and that's because it's better to just do color the map, color the background in the game itself. So to do that, I'm just going to create a small utility. So for all logic that is going to be common to both room 1 and 2, or just rooms in general, if you decide to expand upon the project, is to create a room utils.js file here. And in that file, I'm going to create a function that I'm going to call export. First, we're going to export that function. I'm going to call it set background color. And it's going to take the context, the Kaboom context, so that we can use Kaboom related functions. And the second param is going to be the hex color code, which is going to be the color that we want to display. So here I'm just going to create, use a game object that is going to be a rectangle that is going to take the whole width and height of the screen and color it a certain way. It's better to use that than the set background method from Kaboom, because the set background method from Kaboom is going to color everything, including the rest of the body of the page, which means we won't have the nice looking bars here in the game. By the way, the game is responsive. I mean, 3 sizes, because we activated the letterbox option. In case I forgot to explain this, sorry. But the letterbox is really so that on any screen size, it retain the same aspect ratio. So here, letterbox here. All right. So now that we have this, I'm going to go back here and I'm going to create the rectangle. I'm going to use the rectangular component, which is just rect, specify a width and a height, and you can get the height of the current canvas and the width of that canvas by using the height and width methods. So you have the width method, width method and height, so like that. And then I'm going to use the color component, which allows us to color a given game object with a single color, and I'm going to use the color, I think it's an abstract class, but the from hex method, which allows us to color it by specifying a hexadecimal value, which is used usually, it's most used for colors. It's the thing here in Sprite, for example. And the reason we need to do this is because by default the color component takes a 3 params, which is the RGB values and not an hexadecimal value. And now we have this hexadecimal. And then one thing we need to also use is the fixed component. This will make sure that the camera, this game object in particular is not affected by the camera. So that means it will always remain at the same position regardless. And this is what we want for the background. We don't want this rectangle to basically not cover the whole world, because as the player moves and the camera moves, the part that the rectangle covered is not going to be there anymore. It's not going to be covered anymore because the camera has moved on from the position of the rectangle. By default, if you do not specify a positional component, what happens is basically that the game object will be placed at 0, 0 in your canvas. So that's why I haven't specified a positional component here, because it's not really needed. All right, I saved this, and I'm gonna call that inside this the room 1 logic. So I'm gonna pass in the k here, the context, and here the hexadecimal value we're gonna use, it's going to be a specific value. I don't have it memorized, but it's this one. Oops, I should have done this properly. So this is the color. So now if I go back to the game, and there's an issue. And the issue is because we forgot to add a .js in room.util, actually in the import. Remember, because we're not using npm, it is required to have the .js here, because if you don't do that, the error you're gonna have, let me just see if I can zoom in, it's going to be blocked because of disallowed MIME type text/HTML. By specifying a .js extension, it basically tells us, or tells the browser, etc., that this is a JavaScript MIME type, so it will allow it to run. Now we have the background. All right, so we're making progress, and that's great. Okay, so now the next thing we're going to need is to load the data. So I'm going to do this outside of the room logic. So I'm going to have a room data param, and then back in the main.js file we created earlier on, main.js, here is where we're going to need to use async await, and we're going to have to wrap both these two scenes inside of an async function, because we cannot use top level await, and we cannot need that. So I'm going to have an I'm going to define an async function, main. I'm going to call it this way, main. Maybe a better name, but for now, let's just call it main. And I'm going to take those two scene definitions. I'm going to put it here. And the reason for that is going to be clear very early. We don't really need to put the intro scene here, because the reason I'm going to need to use async here is because we want to first load the data from our JSON file that contains the map data from tiled. So let me just write the logic for that, and then after that I'm going to explain how do you actually get the .json file. So I explained earlier, you can find this in the description, but for the actual map, like how you draw it, etc., I'm just going to do the explanation now. So await fetch. So this is similar like to how you do in web development, where you want to request an API, but this time you just request a JSON immediately. So we're going to take this from the maps /maps, and then the name room1.json. So room1.json, and I'm gonna just do this on one line. So usually people, what they do when you see example on how to make a fetch request is they first put this inside of a variable, they call it response, and then they JSONify it later on. But I'm just gonna do this in one fell swoop. So await fetch, and then that means as long as the fetch call is not resolved, we won't move further, and this is what we want, and that's why I'm using async await, because as long as we haven't loaded the data for the room, we don't want to display the room data. So here we have the JSON as well. So here after you have fetched the data, it's going to give you a response, and then you need to actually convert that to the JSON. So if I go to the actual content of room1.json, you can see this is the content we have. For this project, we don't need really to dive into the tile layers. So tile layers are layers where the data is basically the tiles placed. We don't need that because we don't actually need to render those tiles in Kaboom, because we can just use the image that we have exported from tiled. But for colliders, you have here how it looks like. So I'm going to dive into this later on. So now that we have this, we have the room data. We're going to do the exact same thing for room2 data, and then await, and then await again. Oops. And then I'm going to fetch .maps / and then room2.json, and then we do this. All right, so we have both of these room data collected. Now for the room1, I'm going to pass in the room1 data. So now if I go back to the, there is one issue though, is that we have defined the main function, but we actually have to call it so that it fetches the data. So the reason I'm actually doing all of this inside of a main function, as I explained earlier, I cannot use await outside of a function in JavaScript. I don't think that's possible. So that's what I'm doing. So I'm calling the main, which collects the data for both rooms, and then define the scenes for both rooms, and then we define the scene for the intro, and then we go to the intro, but for now I have replaced it with the room1 for now. just to make our development easier. So I go here and I have an issue. Scene not found, room 1. Okay, now that's because it's called before this is resolved, because it's an async function. Okay, so maybe I'm going to go back to the intro, and then here let's actually take some user input. So the way you take user input, you can use the onKeyPress method in Kaboom, and then here you can specify as the first param the key. So here I'm just want the player presses enter. I'm just going to let me just do this like that. So when the player presses enter, I'm going to call the go to the room 1 now. So now if I look back, I have an empty scene because that's normal, because that's the intro scene. There's nothing. By the way, we should probably just let's do that later on. But for now, let's leave it empty with just this event handler within the scene. So event handlers like these are scoped to the scene. So you have to re-enable them, recall them when you move on to another scene. So that's one thing that you have to keep in mind if you make a, for example, game where you can move in various scenes. So every time you load a new scene, you have to recall those methods. So yeah, you can write a reusable function for that. Okay, so we have a onKeyPress. When the player presses enter, we go to the room 1. So let's try it out. So here, press enter, and then everything is loaded, etc. Everything works. So if I refresh and do that really quickly, does it actually work? All right, oh, yeah, it works. Okay, nice. So let's go back to room 1. Now that we have the data, it's time to print it out. So actually, I'm going to store the room layers first. And I think this is a good time to stop writing code and start explaining where do I get all of these. So I'm going to go back to tiled. So tiled is an editor like I explained. So let me explain what we have here. So we have our room, which contains various layers. So the layers inspector is on the top right. It's all the layers I have created. You create a layer by clicking on this button and then selecting the type. There are basically two major types that I use are the tile layer and the object layer. Tile layers are for placing tiles. So here down below you have tile, a little tile. So yeah, what I'm going to do is I'm going to explain just how the current room setup in tiled work, but feel free to please reference to the blog post, which gives you a better picture. So here I have the tile sets here defined. So the way you do this is basically when you create a new project, new file, new map, and then you can import the tile. I said this is all covered in the blog post. So here we have multiple layers. So by the way, this is hidden. So tile layers are for placing tiles. For example, I'm going to hide everything and just show you one by one. So the first layer I created was the platform layer, which contains only the platforms, etc. and various things here. Now I should have probably created this inside of a props layer instead, but sometimes mistakes happen. So that's that. And then here I have the second, so those are tiles. You basically select the tile you want and then you draw. Make sure to select, of course, the layer you want to draw, and then you can just start drawing like that. But this, so yeah, the second layer I created was the props layer, which adds various props, and then here you, like I said, you can select multiple ones like that, and you just place them. So this is the advantage of tile layers. This is what they allow you to do. Now I have background 1, which is again small things, and then background 2, which is basically some buildings, etc. Same logic here. Just use this second tile set. You can load more than one tile set. So to add a new tile set, you click on here, and then you browse, and then you click on OK. So that's how you do that. Okay, now we are done with the tile layers, so layers used to draw things, render things out. Now the collider, the second type of layer is the object layer, and those are used for colliders, so the platforms and visible stuff. Basically, it's more efficient to do this than to have every tile have their own colliders. Otherwise, it's going to be more performance intensive. So just drawing the rectangles here by selecting. So when you create a object layer, you have a bunch of tools here above, and if you just select a rectangle, you can trace a collider. So I'm just gonna Control Z here. And one thing I want to also mention is that if you go to View, you can go to Snapping and make sure to have Snap to Grid or no snapping, depending on the situation. So here, for example, is a collider which is very small, and if the snapping is set to grid, it won't allow you to draw a rectangle that is smaller than a tile. So that's why sometimes you need to disable to no snapping, or snap to fine grid, or snap to pixels, etc. So yeah. And one thing is that when you draw a collider, you can have, so if you click on this pink white rectangle thing, I don't know how to explain it. If you click on that, you have to the left side the properties tab, which contains a bunch of properties, and those are the actual important data. The x and y coordinates of where the collider should be placed and the width and the height of it is important, and it's data that is exported to JSON and is going to be imported in our game, and this is how we know this is the data we use to draw those colliders in our game and to make them basically. So by the way, once you have your map, you need to save as, and then you save as to your specific to the folder where you want to use those maps, and then you just write a .json extension. By default, it will give you the option to save as a .tmx, but just doing it as a JSON is fine. So here, one example of how this properties tab come in handy is that, for example, here, if I click on that, there's a dog outside barking, so sorry if you hear that in the recording. So here, when you click on that, you can give a name or a class to any of your colliders. And this is useful because I want to give a class of pass-through. This is a name I have decided for myself, but it's important to be consistent because you're going to use that name in your code to know how to what logic needs to be applied to this collider. And pass-through here is logic that I'm going to apply so that the player can jump through that platform and land on it, which is important here. And yep, so we have this is the colliders layer. The positions layer is a bunch of pins. You place those pins here, and basically those are x and y coordinate. They can have a, I think if I select this, they don't have a width and height. They just have an x and y coordinate, and they are mostly useful to know where to place things. So here, for example, this is I'm going to place a drone. So depending on the situation here, when you have multiple pins that are going to spawn multiple, like the same enemy type, I prefer to just use a class and call it drone. Otherwise, if it's only a unique thing, I can give it a name. So basically, the only thing that changes is in your code how you access those properties. In your code, you can access the name property by just having a .name on the object. I'm going to show you the code for that later. But for the class, you just use a .type property to have access to the class. So this is how it works. For example, I've placed the boss here. There's only one boss, so I used a name instead of a class. And as for the those drones, there's the pins. And for the health pack, also it's a class because it's the same thing repeated over and over again. And that's basically it. Now the cameras is something new to this project that I haven't done in the previous project. Those are colliders that when the player will collide with them, they won't cause a collision or anything like that, but they will change the camera. Most importantly, they usually change the Y position. So something you can do in Tile is create custom properties. You do that by just having, for example, this one doesn't have custom properties. You just right click, add a property. So here if I go back to the cameras layer, so I've put this in a different layer, so just to not confuse, I'm going to hide the collider layer. So here, if I have a property, I want a new property, I do add property and give it a name and a type. And here I used the int type. So this is a value. So when the player collides with this camera collider, I'm going to take this property and the value for it, and then set the camera Y position to that value. So this is how I can make sure that the camera shows specific things and slides, etc. So there's a bunch of them here. So for example, we drop here, the camera will move. When you drop here, it's gonna also move or go up, etc., depending on the situation. So here it's going to go up, here it's going to go up. So it mostly just affects the Y positioning. So only the Y position of the camera. So actually, yeah. So if you're not familiar with game development, usually when the Y value is high, that means we're going up the canvas or down. Yeah, I'm confused. Yeah. Actually, the least the value of Y is, the higher on the canvas you are. That's because yeah, so the higher the value of Y, the lower you get on the canvas. That's something I've explained in previous tutorials, but that's how it is done in game development, in graphics library, etc. Okay, now what I want to yeah, so there's a bunch of colliders here, and yep, and finally we have the exits collider. And I think one thing before that, for the position, the camera collider, actually the colliders itself, there's this specific boss barrier, which is a specific collider. So if I go back to the colliders here, and this one, I have specified a unique CamPos X property this time around. This is an arbitrary name, by the way. I forgot to mention, because when you arrive to the boss gate barrier, I want to slide the camera to the X axis, not necessarily the Y axis, as I used to do with other cameras. And yeah, it's a collider because it's going to be an actual collider, because the barrier is going to be visible as you fight the boss and you cannot move, and that's why I've put it into the colliders layer. And that's basically it. And then finally, so we have position, I've explained this, and then the exits layer, which is another object layer, and this is just to know where to spawn the player in the room 2. So I've named it exit 1, and I've named it sorry, exit 2. And yep, so when the player is gonna hit that, I'm gonna know that the name of the exit, and I'm just gonna spawn you either in entrance 2, or actually this is the spawn point here, entrance 2 spawn point, or entrance 1. So that's how I link those scenes together. And here again, it's basically the same layers. So feel free to open those up in tiled, because they were just JSON file. You can just open them up and play with them. So I'm not going to spend more time on that, but I'm just going to explain one thing though. So to do the exporting as a single image, what you do is you hide every object layer. Object layer, because you just want the graphics. So, and you go to export as image, and then once you click on export that image, you have the path to it, and then you must check this to only include visible layers and keep all the other things unchecked, and then you export. And it's going to give you the room1 or room2.png, depending on which one you export, here and there. So that's an overview of how to use tile. So like I said, the blog post goes into more details on how to do this from scratch. So give it a read. All right, so now let's look at the export to the JSON. So the .json that it was saved. So you don't have to click export, you just have to save your map as a .json, and you can immediately access the various properties. So if I go to room1.json, maybe room2 is going to be easier to parse because it's smaller. So if you were to use a tile, so every tile layer has the data prop. So first of all, let's collapse everything and let's go at it one step at a time. The most important part here, the most important property, is the layers property. The layers property contains all of our layers, and here it is. I'm just going to collapse everything. So each object here is a layer, and let me just collapse. So we have 1, 2, 3, 4, 5, 6, 7, 8 layers, and this corresponds to what we had in tiled, which is 1, 2, 3, 4, 5, 6, 7, 8 layers. But it's reversed. So the first layer here in the array is going to be the lowest layer, because the way usually graphics library works is that the first thing drawn is the thing drawn at the lowest level, the lowest layer. So if you have a tile layer and not an object layer, what you will have is the data property. So this data property specify for each tile which tile in the sprite sheet to draw. If it's 0, it's going to be 0. So it's going to be the absence of the tile, so nothing. And here the number, it corresponds to the frame in the sprite sheet. But because we aren't drawing the tiles in Kaboom, but rather just using a .png that contains everything, because somehow it's more performant, and I don't know exactly how Kaboom implements this and why it's the case. We don't need to parse this layer at all. So any tile layer we have here, we can just safely ignore it. So we're gonna ignore that. And yep, so the way I'm gonna do this in the code later on is I'm just gonna check the type here. So you have this property called type that is either tile layer or object layer. So if we see that we have a type of a tile layer, we can just continue in the for loop. So we're gonna write some code to iterate through that. So the second layer also is a tile layer, the third one, the fourth one, the fifth one is where things get interesting. We are now having a object group. So the object layer is named in the actual JSON file as object group, and the difference is that it does not have a data property like with the tile layer. It has instead an objects property, and it's an array that will contain every object. So here every collider with the width, the height, and the x and y coordinates. However, if it's a pin, it's just going to contain the x and y coordinates. So mostly for the positions layer, it's going to be that. And using this information, this data, we're going to be able to draw the hitboxes and place the players, the positions, etc. So here I'm gonna put in a constant the layers of our room data, and by just using the layers property, accessing that, we don't need the rest. And then here I'm gonna create a game object that is going to act as the parent of everything. It's going to be the map game object for the scene. And the way I'm gonna do this is by having the add function and placing this at positional 0, 0. You do not need to do that, I think, because by default, if you don't specify, it's going to put it at 0, 0. But just, if in case you want to move the map elsewhere, like the whole map, you're just gonna modify this value anyway. So I'm gonna set it to 0, 0 explicitly, but feel free to not do that. I don't think it's gonna cause an issue. And here we're gonna load the room, the image, the room 1. So if you remember, when I told you to copy and paste the code from GitHub, we loaded the images for the room 1 and room 2 PNG here, and using the room 1 and room 2 keys here. And then if I go back to room1.js, we can just use the sprite that you have already loaded by using the sprite component in Kaboom. So this will work also for all the other things that need sprites, and specify this as the sprite name. So here we have an object that is going to act as the parent of all game objects. So in Kaboom.js, you can create game objects that are going to act as children of other game objects. So you have here, for now, this game object, the map, doesn't have any parent. The reason we're doing this, by the way, is because the positions are relative to where the map starts in the tiled export, so in the JSON file. So if you were to just create the game object separately, you would have the positions of everything being off. That's why I prefer to just use a map, a parent game object, which is represents the whole map, and then put everything relative to that, as a child of that game object. Okay, so now we can just continue. So then the next thing is to create the colliders, to store in the constant the colliders, which is just going to be room layers and then the actual number. So instead of like, I'm just gonna pick the specific layer that corresponds to objects, and I'm just gonna have the dot object. So here, if we go back to the export, I guess room 2, this is going to be index 4. So if I just collapse everything here, so 0, 1, 2, 3, and 4. 0 because we are in an array, So the fourth element is going to actually contain the objects for the colliders. So the objects property is basically all the colliders data. So that's why I use this. Maybe you shouldn't do this if you want more flexibility, but for this project, I don't think it's needed. I have decided to have 8 layers, but maybe if you decide to add more or less layers or replace them, maybe you want a more flexible system where you're just gonna check, you're gonna iterate through the layers and then check if the name correspond to colliders and then use that. So actually I could spend the time writing this logic like that, so maybe we should do that actually. Yeah, so if I were to do const for layer of room layers, and then here I'm going to have instead a colliders. I don't like that. I really don't like that. So I'm gonna do this because in JavaScript an array, even if you put it even if you put this as a const, you can modify the content of the array. It's not actually constant. So if I do let here, but I'm gonna assume you know JavaScript. So here I'm going to have if the layer dot name is colliders, then I'm going to do colliders, and I'm going to use the I'm going to push to it the layer itself, layer dot objects. So I'm going to spread it over and then push it all at once. I think it's not going to do what I think it's going to do, right? Okay, let me just if I put the spread operator, it's just going to create an array within the array. No, actually it should spread it, but anyway, I'm just gonna console.log the result. I don't think this will work, but yeah, so this is something I think is a better coding practice. Layer.object, I forgot typo here, it's objects. So if I go here, okay, we have an array with all the elements, and that's great. So it works. Okay, it works. So here, as soon as we do this, we're just gonna break. And then if I making sure the code actually works. Yep, it works. All right, nice. So this is a better way. That means regardless of how you structure your tiled, as long as you have the names right, you can find the layer. It's more computationally expensive to do that because you have to do a for loop and iterate through the layers. Actually, the name of the layers, not necessarily every element in the layer, but I think it's worth it. So here we go. And we break here because we don't need to do any more calculations as we go. Okay, so we have that. And then now what we're gonna do is actually we're gonna write some utils. So in the ream.utils, we're gonna write in a reusable function the logic to place the colliders in the map. So I'm gonna call it set map colliders. And in that, I'm going to need the constant, of course. I'm going to need the map parent game object, and I'm going to need the colliders themselves to know where to place them. And yep, so here, and then okay, so we have everything, and then here we go. We have the collider. So for const collider of colliders, and then so we iterate through them. So here we're going to have, actually, there's one thing I forgot to mention, is that in our collider layer, there's a specific kind of collider that is different from the rest. It's the slope here. It's not a normal rectangle that has been drawn with this, and you won't find this in the blog post because I haven't mentioned it. Here we need to have a polygon. So if I draw a polygon, maybe I should so I need to select colliders. So a polygon allows us to, have slopes like that. For example, I have a triangle here. The difference is the following. So if I select that polygon, we have an X and Y, but wait a minute, there's something missing. It should does it actually do anything? So X, Y, rotation, template. There is another property. For some reason, it's not appearing. So basically, what I want to say is that for polygons, it gives you coordinates. There is going to be a coordinates prop. For some reason, this is not appearing here in this part. Okay, parallax offset. Okay, that's strange, but okay, so I'm just gonna delete that. So if I go to the, oh, maybe that was why. So I'm gonna redraw it here, a triangle. And then what happens if I do this? Okay, so it doesn't seem to appear on its own in the inspector here. But if we go to the tile export and look for the slope, this is not going to be in room2.json. It's going to only be in room1. So if I go to room1.json, and I'm going to do a quick search here with Control F and try to find the polygon property. You see? Okay, so it's a polygon property that gives you an object, an array of the coordinates of each of the point of that polygon. This is a specific thing for those colliders that you draw using the polygon tool. So the polygon tool is this one here. So that means in our room utils, we're going to have to first iterate through all the colliders. But now if the collider has the polygon property, then we're going to first create a coordinate array. And then I'm going to have a for loop, and I'm going to iterate through each of the points of the collider polygon. So collider.polygon, which is the property that contains an array of each of the coordinates for each of the points of that polygon. And then I'm going to push inside my coordinates array those coordinates, but this time around I want to use a vector too. So in Kaboom.js, the way you specify positional components is by, if I remember correctly, here I set to 0, 0, but another option is to pass in a vector 2. So you could have done vector 2 and then 0, 0. So the reason this using vector 2 is useful is that when you want to set the position after the fact, so if you want to do this map and then set the position, it's often handier to just do that. You cannot do other than that, or have to do map.pos.x and then a specific value, and then map.pos.y and then a specific value. So that's a way to make things easier for us later on. So that's why I push them into this coordinates array, and then I just collect point1.x, point1.y. So here we go. And then here, I'm going to add them to the map. So the way you add child game objects to the main game, to a game object, is you take the game object and then you use the add function, the add method on it. So to the earlier on, we used the add function in Kaboom to create a game object. But each game object has the add method available to them to add child game objects to them. So not only this add method creates a new game object, but it appends it as a child of that map, at that parent game object. Sorry. So here, specify the position, and then here I can just do. Okay, that was a bit. So in the original source code, I just did collider x, collider y, which basically defeats the purpose of having created a vector 2. So I'm just gonna use coordinate. Wait a minute. Okay, what's the point of it? Okay, maybe I have created this for nothing. Okay, no, never mind. This is different because we have the position of the collider, which is defined in the collider properties X and Y, but now we also need to have the area component, and so there's two things to explain here, sorry. The first thing, what is the area component? So the area component in Kaboom.js creates a hitbox for your game object. By default, it takes the shape of your sprite component or the rectangle component, the rect component, or any shape you have already specified earlier. But if you don't have a shape specified, you can specify custom shape by using the shape property passed inside of it. And here I'm going to create a new polygon, which is a class constructor in Kaboom.js that allows you to create a polygon based on the coordinates, an array of coordinates. And this is where the coordinate constant we have here is useful, because we can just pass it as directly here. And actually, this is why here it was important to convert this to a vector 2, because this constructor takes an array of vector 2. That's why we had to do it as well. It's not just because it's handy as well. So yep, we have this. And another thing I'm going to use, and this is to increase the performance, is I'm going to have set the collision ignore property, which is something that Kaboom offers as well, where you pass in an array of tags. So each game object can have a tag. A tag is basically a way to identify this game object. So the way you define tags is in your arrays of component. When you are creating the game object, you can just pass in a string as well, and this is going to act as the tag. And you can have more than one tag. So here I'm going to pass the tag collider. It's just a name I have decided to identify all game objects that are created this way. And in the collision ignore property in the area component, I can pass in that name collider, and it will make sure to ignore any collisions, calculations, etc. When two collider game objects collide with each other. And this is useful for performance because we don't really want to calculate the collision between this and this or this and this. It's kind of useless. So, and it's going to be more performance intensive for no reason. So that's a trick to have more performance. And then finally, we have the collider type. Here it's important to pass the collider type because if you remember, not every collider has a type in our map here, but those oops, I didn't want to create a new polygon, so I'm just gonna Control Z. So if I select it with the pink tool here, if you select this, the class here, pass through, is going to be referenced. You can access this name through the type property. I don't understand why they're different. Maybe the class property is a reserved keyword in JavaScript. I don't remember. I don't know why exactly they decided to have the different names, but this is useful because now we can have create a new tag, which basically is a string, specific for the pass-through platforms by just passing the type here. So if a collider doesn't have a type, it's just going to be an empty string, and an empty string is just basically not a tag, not considered a tag in Kaboom. So that's hope I was clear here. Feel free to ask questions, by the way, in the comments section if you have any issues. And then we continue. So the reason we continue here is because if it's not a polygon collider, we need to write different logic. So here, the next case is that if we have a collider and the name of the collider is a boss barrier, which is one of the exceptions here, what we're going to do is... oops, here we go. So if the collider name is a equal boss barrier, we're going to create the boss barrier, but this time around we're going to store the reference to that game object. It's still going to be a parent, a child of the map game object. So one thing is handy with the add function and the make function as well, you're going to see later on, is that it gives you a reference. It returns a reference to that game object when you use that. So you can keep it here, keep it handy here. So here the boss barrier, I think I'm going to, actually, you know what, for now, let's skip that. I'm gonna do to do, and we're gonna do that later on. And if I'm gonna continue to the next iteration. And then the last case, yeah, so all the other cases are just normal colliders, and we can just add them as a child of the map and specify collider X, collider Y. But for all those normal colliders, the shape we're going to define is just going to be a normal rectangle. We can specify this by using the rect constructor here. It's different. It's different than the rect component. The rect component actually draws the rectangle, while the shape, the creating a rectangular shape, is just going to make the hitbox. All hitboxes like this can be viewed if you press the F1 key and enter debug mode. Well, actually, you enter debug mode by pressing the F1 key. So if I do this, so here for the rectangle constructor, the way you create a rectangle, you have to pass 3 params. The first one is the position, and I'm just gonna pass an empty vector 2. This basically tells that there is no difference from, because if you were to specify values here, X and Y coordinates, it's going to draw the shape, the hitbox relative to the game object. And in certain cases, you want that. You want the hitbox to not be directly aligned on the same position as the game object, but sometimes you don't want that, so you just specify a 0, 0 vector 2 here as the first param. And then the second param is the collider width, and the collider here. So here we go, and here we're gonna use the body component. So the body component is a component that can only be used when you have the area component defined. So you first need to have the area component defined because you need the hitbox, and the body components for physics. So here we want to have the physics of, so by default, if you just call k.body, if you just add the body component, it's going to make your game object susceptible to gravity. If you specify though inside of it the isStatic property and set it to true, it's going to be a wall, basically a static body. It won't move when collided with. It's going to act basically as a wall, an obstacle. And here I'm going to also have the collider tag. And I forgot to add the collision ignore as well. Collision ignore. Oops, collider. So I've explained this already. So, and we also pass the collider type. As I said, for the pass-through platforms, this is going to be useful because for some of them, it's going to... Actually, you know what? Since we have only one slope, if we go back to the polygon, we actually don't need to pass this type here. Because in case you want to, in the future, to maybe have pass-through platforms that are also slopes like that, I guess we can just let it be. So, yep. So, yep, we have done this, and now it's time to call that function in room1.js. So in room1, yeah, here we have the colliders. So right below, I'm going to call it set map colliders. It's going to import it from roomutils.js. Make sure that this is a .js. And here, okay, and then pass in the map. So k for the context, and then the colliders, we can just pass the colliders. Here we go. Let's test everything out. So if I go to the browser, hit enter, you can see the map being fully drawn and the colliders also by pressing the F1 key. Now, for now, the performance isn't very good, but you're gonna see later on we're gonna do a bunch of stuff. I think we're gonna add a few things that makes it, I think, the off-screen component. Actually, I think the performance is good. It's just my PC, where when it's unplugged, it runs at a lower frame rate. Yeah, and also the fact that when you open up the debug mode, it adds a bunch of drawing calls to draw the layers, and that's why the FPS count drops. But the actual game performance as you're playing, it should be 60 FPS. So now, because this is not very inviting to look at because it's too small, I'm going to do a bunch of camera operations. So in Kaboom.js, you can control the camera relatively easily. So here, I'm just going to call the cam scale method, allows us to zoom the camera. I'm going to zoom it four times. I think this is what will look good. For the cam position, I'm going to put the default position at 170 by 100. Those are all arbitrary values. I just came up with them by experimenting. And then I'm going to set the gravity to being a value of 1000. I don't know what the metric is, the unit for that is, but 1000 is what felt good. But for now, it shouldn't have any impact because we don't have any kinematic body or any player or enemies yet. So if I go here, press enter, you can see the map. So in the next part of the tutorial, we're going to hopefully start working on the player and the logic for that and making the player move, etc. All right, now that we have the map here displayed, we could proceed on and work on the rest of the map, cameras, etc. Or we could start and work on the player. So I think we should actually go and work on the player logic. I think that would be the best, so we can start implementing movement, etc. And since we have the map, it's going to be easy to test things out. So now what I'm going to do is I'm going to go to the folder structure and then create in the entities folder a new file. This file is going to be called the player.js and it's going to contain all the logic we need for the player. So here we go. So here, what do we need? So I'm just going to collapse this. So what do we need is, first of all, I'm going to create a function. And this function, I'm going to call it make player. So in Kaboom.js, usually there's nothing against object-oriented programming, but usually don't use classes. Well, I usually don't use classes. And if you look at the examples on the docs, etc., usually don't use classes. So here the make player is going to act as our constructor, but yep, so it's going to, we're going to use the make function this time around, the make method. So yep, the make method is like the add method in Kaboom, but instead of creating a game object and then displaying it on the screen, what it does, it only creates the game object. So later on, you can take the game object and then put it inside of an add call to really add it to the scene. So here I prefer to use this make function to actually make the game object, and then in the room logic, in the actual scene, I'm gonna make the call to actually put it as a child of the map. So here we go. So here, what are the components we're gonna need to make our player? So just to circle back on the reason object-oriented might not be really used, but you can actually use it. But the reason is that when making a game object, you can pass in an array of components. You can pass a string that will act as a tag, but you can also pass an object. And this object can contain basically your methods for your game object. So you don't need to create a class. So for example, here, let's first add our game object, our components that we're going to need for this player character, and then as we go on, I'm going to add a bunch of methods for the actual behavior, etc. we're going to need inside of that object. So first of all, the positional component is very important. Now, one thing I forgot to mention is that you need to call this, you need to actually use the positional component, even though by default it's going to just put the player at the position 0, 0. And that's because if you want to modify the position afterwards, it's important to have the positional component used here. Otherwise, it's not going to work. Now, I'm not really sure about that, but I think I remembered it that way. So maybe try it out and see if you can do without. So now I'm going to also use the sprite component. And I'm going to here use the player sprite. This was defined earlier on in the Kaboom loader. So if I go here, Kaboom loader, and to the first load sprite call here was where we loaded our player. So here, yeah, we just load the sprite, and then later on we're going to pick an animation and play them. Okay, what do we need else is the hitbox. So as I mentioned earlier on, hitboxes can be created by using the area component. By default, if you just don't do anything except just using the area component, just calling it, you're going to have a default hitbox that takes roughly the size of the sprite. But I want more granular control over that. The reason I want more control is because I want to actually the hitbox to be the constant and the same regardless of the various animations, and I want to place the hitbox in such a way that the player is going to look good in terms of movement, etc. So the frames should be well positioned. So here I'm going to use the shape property that I've shown earlier on, and again call it new and then k. And here, of course, I forgot to pass in the k, the Kaboom context here. So I'm going to use the React constructor as I explained. Here, for the first param, we're actually going to offset the hitbox to be at 0.18. So this 18 y coordinate relative to the actual position of the game object. And here I forgot a comma, so maybe here I should probably have this to have it well formatted. So shape new k.rect, and then as the first param here. Now this is a value I've played with. Later on, when we're gonna actually look at the results, you're gonna see that like what looks good. The second param is going to be the width, and here it's going to be a width of 12, and the height is also going to be of 12. This way, the actual sprites I think are 16 or 32 by 32. The reason I'm using 12 by 12 here is because it's the hitbox is going to be small enough so that there are still some collisions. The player cannot move in weird places, but it's also small enough so that the player doesn't get hit all the time. So it's a generous, I guess, hitbox to be small. Okay, now I think that's it for this one, and we can move on to the next one. The next component, sorry. So the next component we're going to use is the body, the anchor component. So the anchor component, it's a new component that I haven't explained yet. This allows you to center, to determine from where the sprite, the game object is drawn or centered. By default, all game objects are placed or centered from the top left, from their top left corner. If we don't want that, we want actually the center of the game object to be the position, we can use the anchor component to specify that. You can specify center, top left, top right, and you can even pass, I think, a vector 2 as well if you want more control. I'm not sure about that last one, but I think in the platformer tutorial, the one, my 7-hour, almost 8-hour tutorial, I think I did something where I control actually set the anchor to be a specific value. I'm not sure though. I don't remember that project that much. Anyway, once we have this, I'm gonna also use the body component. This is very important because since this Metroidvania is a 2D side scroller, it's basically a platformer, so we need to use the body component so that the player is going to be affected by gravity. That means that it's going to be like it's going to fall, etc. And here we can specify a bunch of other properties. So we can specify the mass of our player. I'm going to use 100 as the value. How I came up with this was just by tweaking. And we can also set the jump force. So this is when we're going to implement jumping. You can set up in Kaboom.js the jump force. And here 320 was a value which I thought was powerful enough so that the player can have a nice jump, but not too much so that they hit the ceiling of the levels. So here we go. And we are also going to add the double jump component. So double jump is a component that is provided by Kaboom that allows you to easily implement multiple jumps. It doesn't have to be double, so you could have more than that. Now here for double jump, it's I usually set it to 1 initially, so I'm gonna set it to 1, and then as we unlock we beat the boss, it's going to be set to 2. But the logic for this isn't here yet, and actually, you know what? It's a good time, I think, to start handling our state, setting the groundwork for that. So we want to have global state to keep track of our player's progress. and I'm just going to create that in a folder called state. I'm going to call the file global state manager.js. And the way the pattern I'm going to use is going to be very simple. So here, what I'm going to do is simply, I'm going to create two things. I'm going to create first a constant that is going to be the state props enum, and you're going to see why in an instant. And the second one is going to be a function, and I'm going to call it init state manager. And what it does, it's going to return, actually first we define a state object, which is going to contain a bunch of state we want to keep track of. For example, the player HP. By default, we want the player HP to be 3. Then the max player HP, we want it to not exceed 3, because for this project specifically, the health bar in the sprite work, the assets, is basically 3. And it's not very flexible. So instead of fighting this, etc., I'm just gonna make sure the player only has 3 lives. If you were to actually expand upon the game, I would recommend just making your own UI components yourself, or maybe tweaking those sprite. For example, you could just take the outer frame of the UI. Here you could take the outer frame. So for example, you would cut out all of this pixel art and have all of this part transparent, and then you would fill it in with color. Actually, I should have done this with a rectangle that grows and shrinks. So yeah, just some ideas you can try. And then here I'm gonna have it is double jump unlocked, and I'm gonna set it as false. Player is in boss fight. And I'm gonna also set it as false. And then is boss defeated, and then I'm gonna set it as false. So as you make this game grow in complexity, you can have a bunch more events here that you want to listen on, and state you want to keep track of. Now I'm gonna return here. I'm going to return one thing, a current method. So by the way, in JavaScript, you can define functions like this within objects. This is a shorthand for this, which you might be more familiar with. So I prefer to just do that. And here, in this current method, we're going to return a copy, a read-only copy of the state. So while the user of so the one who calls the current method can modify the object here, it will not affect the actual state. So for actually setting the state, we want to create a setter. I'm gonna call it set here. It takes in a property as a string and a value you want to change, and then here internally it sets the actual state here for the given property to be the value here. Oops, not value. Here we go. So here we go. And here it's where things could get messy, is that since this is a string, you could pass in whatever you'd like. That's why I created this state props enum, where you can actually, maybe I'm just going to copy and paste this. You just have names like that. Player HP refers to the player HP string. Now, this isn't ideal in terms of, like, if we were working with TypeScript, we wouldn't have to do something like that. But I think it gives us a much nicer way and less error-prone way of setting the state. So just to explain, if here I want to only unlock the double jump for the player who has defeated well, actually, if I want to only enable the double jump if the player has the double jump unlocked, then what I would do here is I would do state, and then did I export it? Sorry, I forgot one very important stuff, is to have another export where this is just a function that we call, and then we have export const state, and then this is what we're going to actually export. So we're going to initiate the state manager, and then this is the state that we export. So here in the jump, I'm going to type state, and then import it. Here we go. And then don't forget to add the .js. Then once you do that, you can do state current, which is the method which is going to give us the current state. And then you can immediately just have access to the properties here. So is the double jump unlocked? And if that's the case, we're going to use a ternary here, ternary condition expression, because it's compact. And if it's the case, what we're gonna do is simply set the number of jumps to being 2. Otherwise, by default, the player can only jump once. So double jump is a component offered by Kaboom.js. It allows us to really build this feature out very quickly, and that's great. Another component we're going to need is the opacity component. This allows us to control the opacity of the game object. This is going to be useful when we want to make the player blink when they get damage. That way, when that happens, we can just control the opacity. Otherwise, you cannot control the opacity. And then I think that's it. The last one is the health component. So Kaboom offers the health component, which allows you to manage health very easily. And here what I'm going to do is initially you initialize the health component with the HP for the player. And this we're going to pick this up from the state. So for example, if in room 2, the player, in room 1, the player takes damage. So in room 2, we want to actually keep track of the player health. That's why we recreate the game object for the player every scene. So when we go from scene 1 to scene 2, the make player function is going to be recalled, and that's why we need actually to keep track of the health. So that's why, otherwise it will reset to the value if we were to hard code it here to 3, even though the player is just exploring another portion of the same world. So state.current and then player HP. All right. And then finally, we'll have a player tag. This is going to be useful when we want to have on collide events. We can just use that tag so that other entities can just check for that. All right, so now that we have this done, it's time to actually fill this object. So one thing, the reason why object-oriented programming in terms of using classes is not that necessary when working with Kaboom.js is because you can specify properties within here. So here I created the speed property. I want my player to move at the speed of 150. I also want to set the is attacking property to being false. So this is a property I created just to keep track of when the player is attacking. For example, when the player is attacking, we want to make them not vulnerable. So they can't take damage when the attack animation is running. Otherwise, it would be... I think it was a better way to go about for this project. Okay, so here is our first method. It's going to be set position. Now for this, really, I don't think this method is really necessary. We could just have a position here. We could call it the initial pause. I don't think I ever call this ever again except for placing the player, so I can just do this like that. So I'm not gonna use that. If there's any issues, I hope I will remember to just check here and re-add it. So okay, so the first actual method we're gonna use create for our player is the set controls. Set controls is going to be a method that is I always mistype and press the P key instead of the brackets, which they're near each other, so that's why. And then it auto completes with page transitions. So, okay, so this set controls, what it's going to do is basically set the player controls. One thing that's great with this, wait a minute, yeah. One thing is great with this, creating methods within the object, is that you can use this, like in a class, and create attributes that can be used by other methods. So it's basically just object-oriented programming. So here, this control... I'm going to create a new property, and the way you could do that is just this, and then the name of the new properties you want to create. I'm going to call it control handlers, and it's going to be an array that will contain event listeners, reference to event listeners for the various controls. And the reason I create this is so that I can cancel all of these events, event listeners, when the player dies. Otherwise, the player could die, explode, and then continue to move while the exploding animation is playing. So here is the first call. So I'm gonna create this control handlers. I'm gonna push into it our first event listener that I'm going to define within this push call, this push method. I'm gonna use the onKeyPress event listener like I've shown you earlier. And this time around, I'm gonna use a different form of the keypress event handler from Kaboom. Instead of specifying the key here, for example, enter like I did in the main.js file, what I'm gonna do is I just pass the arrow function, and as the first param, you can get the key. By the way, this is an arbitrary name. The first param is going to be the key, regardless of what it's named, just for your information. So here, key on key press, the key here. So what I'm going to do, I'm going to have an if statement. And then if the key is for x, let's say we have x, and if from within this dot current animation. So what is this from? So one thing is that this not only gives you access to the properties you created, but gives you access to the whole game object. And usually in Kaboom.js, when you create a game object, it has access to new methods and new methods depending on the components you have used. By default, all game objects that uses the sprite component have access, once they're created, to the current animation current anim method. Now this is going to be called when the game object is going to create, so that's why we can actually start using them here. So here, this current anim allows us to know to check what is the current animation. So if the current animation is not the jump animation, then wait a minute, what we want to play, actually we can use the other method that is available for all game objects that uses the sprite component. It's going to be the play function, allows us to play the play method, sorry, that allows us to play animations. So here I'm going to play the jump animation. All right, so if you remember, the jump animation is what we defined earlier on in the where is it, the Kaboom loader.js. So load sprite player, and here it is. So from frame 51 to 51, so it's basically just one frame. And you know what, actually I realized this, you could just have set this up like that, one frame. Instead, if it's one frame, you don't need to have all this, you can just have one like that. All right, so let's do this. So if the player, okay, press the X key, we first check if the current animation is the jump animation. If it's not the case, we play the jump animation. That's important because if the player press more than once the X key, we don't want to cancel it, but it doesn't really matter in this case because the animation is one frame. So even if you spam again, it won't matter because the same frame will play. However, this would have been useful if the jump animation has more than one frame. So I'm going to keep it in case you want to modify the jump animation to have more than one frame. And then finally, we just call the double jump component. And this is going to take care of either making the jump for the player. So if the player is allowed to do more than one jump, they're going to be able to do, and it's the double jump component that takes care of that. If you're new to Kaboom, by default, you also have the jump component. So this jump component is unlimited, so don't use it if you want to use this double jump mechanic. One thing, if you use the jump animation, the jump method, what you need to do is check if the player is grounded. So there is the isGrounded method on every game object that uses the body component, and by checking, you can actually allow then the call for this jump. Just for your information, you can look at previous tutorials. Usually by default you implement the jump mechanic using the jump component, but this is a special case where we actually want to allow more than one jump as part of the ability that the player unlocks after beating a boss. Here you could have decided to have a switch case statement, but since we only have two cases, I'm going to just go with one if statement. So the next key is going to be the Z key. Now, depending on if you're in a European keyboard, the Z and the X key might not be the same in the same place as the QWERTY layout. So in that case, either in Kaboom.js you cannot have the keyboard layout independent keys. You cannot set that on key press. So as a workaround to this, what I would recommend is maybe allow the player to remap the keys in a settings menu. That you can do. All right, so if the Z key is pressed, and here we can also check. So the reason this is in another if statement instead of being on the same one is that we want to allow the double jump if possible, even if the animation was already playing. But for this case, if the Z key is pressed and the current animation is not an attack, current anim is not the attack, only then we will allow the attack to go. Otherwise, yeah, because the attack is already in motion, if not the case. And we also want to check that the player is grounded. So this is something that is particular. So it might sound strange. Why would the attack only be available on the ground? Well, the reason for that is that the asset pack doesn't have animations for jumping attacks, and I didn't feel like adding an animation. So just for the gameplay not to be weird, the animation not to be weird, I just decided to, you can, this robot, the robot character that we play can only attack when they're grounded. So what happens when an actual attack is fired? So here is the logic. You need to write this logic here. So first of all, we're gonna set the isAttacking property to being true during the attack. We are also going to create a new game object. This time around, this game object is not going to be a parent of the map. The reason for that is that actually thinking about it, it's not necessary. Yeah, I should have probably. Never mind. This game object is going to be a child of the game object, the player, which is a child of the parent. So never mind. We use the add function, the add method to create a new game object. It's going to be the hitbox for the sword attack. So the way we're going to implement this is that when the player attacks, we create an invisible hitbox that is that if the enemy collides with it, then we register an attack and we deal damage to the enemy. So here I'm going to set the position of that game object to be this. First, flip.x. I'm going to explain this line of code in an instant. Let me just write it out. So here we go. So what does this do? Why I'm doing this? So flipx is a property that is available on all game objects that uses the sprite component. What it allows you to do is to flip like a mirror the sprite. And what that means is that instead of having a left-facing sprite and the right-facing sprite, you can just get away with one and then just flip it around. So if the flip animation, so if the sprite is facing left, because by default the sprite is facing right if you look at the images. So if if the flip x attribute or property is true, that means the player is now facing left. That means we need to move the hitbox to be to the left. And that's why I have this ternary operation that does this. It will subtract -25 to the current position of the hitbox, which is by default, since it's a child of the player, its position is going to be relative to the player. So -25 is relative to the player. Otherwise, it's going to be 0 and 10. So 0, 10 is what looked good. So the hitbox is going to be drawn from, remember, the top left corner. Every game object by default is drawn by the top left corner. It's only when you specify with an anchor component, center, etc., that you can center that instead of being drawn from the top left. But for this, the attack hitbox, we don't need that. All right. The second game object is going to be the area component. So the area component is going to have a specific shape. So here again, it's the hitbox. I'm going to use the rectangle. It's the simplest shape. Here we don't need an offset for the position, and we're going to make our sword hitbox 25 by 10. This is what looked good relative to the animation. And then finally, we're going to also have a tag. So the tag is going to be not here, outside here, sword hitbox, which is going to be used to create event listeners that listens on collisions with this particular tag. All right, we have this, and then of course we need to play the attack animation, again defined in the Kaboom loader that we did earlier on. And then here we're going to have a on_anim end, which is a event listener offered, a method offered by Kaboom for every game object that probably used a sprite component. And what it takes is it gives you actually the animation name, and then you can write some logic. If the animation was the attack, then we can first get the sword hitbox. The way you can get a game object by its tag is by using the get function method, for a function actually. This is a function from Kaboom, and we pass in the tag. And since this sword hitbox is a child of another game object, that means we're going to have to use recursive true, and the get method function gets all game objects with this tag. That means if there's more than one, it's going to get them and return an array. So because it always returns an array even if there's only one, I'm gonna just pick the first element. There's only anyway going to be one sword hitbox created at a time. So if the sword hitbox, we first get a reference to it because we don't have access to this. Actually, you could have decided to create another property within the but since we destroy that game object, it's better to just use the get function, get the current sword hitbox that exists, and then destroy it. So here we do this, and then only if the sword hitbox actually exists, because sometimes the sword hitbox might already be destroyed before a new one is created if the player hits the attack key again. So in that time, sword hitbox will be undefined. So that's why we need to guard this with an if statement, otherwise it's going to fail. So here I need to, and then only if the sword hitbox exists, then we can call the destroy function offered by Kaboom to destroy a game object, and we pass the reference to that game object. And that's it. And one thing we want to do is set the is attacking attribute now to being false, since the attack is finished, and we want to play the idle animation back. By default, the idle animation always plays all the time when the player isn't doing anything. So even after an attack, we set it back to idle only, and then when the player decides to move or do something else, then we will play other animations. So this is our first control handler, and let's do our second one. Our second one is going to be, again, I'm going to push it to the array in much the same way. This time around, what I'm going to do is do a key on key down instead of on key press, on key down, and yep, on key down, and then again pass the key here. And now here, if the key is either left, if the key is left, so if it's the left key is down, and the player is not attacking, this again, it makes no sense gameplay wise. It might be strange, a strange gameplay design decision, but as I said, because I do not have the animations for the left and right attack as you move, and it just looks weird because the player is basically standing still and attacking. So that's why I made sure that you can only attack when you don't press any other keys except the attack button. So if key equal left, and this is attacking, what we're going to do is we're going to have another if statement. If this dot current animation, so this again is the animation guarding logic. So if the current anim is not the run animation, and we also need to make sure that the player is grounded before we play any running animation, because otherwise running while in air is kind of going to look weird. So because of that, we need to use the isGrounded. Again, isGrounded is a method offered by Kaboom for all the game objects that have the body component. Okay, so we have that, and if that's the case, we can do a this play and then actually play the run animation. So we have all the conditions to play the run animations, but again, this is an if statement within an if statement, because we can conceive of a case where we want the player to still move even though we don't want to reset the run animation because it's already playing. So here we go, and I'm gonna make sure that you need to make sure actually that the flip x value is false, because the way that flip x works is that if you set it to true, your player is going to be mirrored all the time unless you actually set it back to false. And because by default it seems here that the player is actually facing left by default and not right. No, actually that's contrary, it's facing right, so this should be true. We want to always make sure that the flip x value is true, so that the player is flipped when they press the left key. And in the other if statement, where it's going to be the exact same logic but for the right key, we're gonna make sure that the flip x is always true, always is false, set to false, so that the player will return back to their original orientation, I guess. And then finally, for moving the character, we can just call the move function a method. Again, this move method is offered by Kaboom for all game objects that have the body component. And here the move method takes two params. The first one is the speed in the x-axis, and the second one is the speed in the y-axis you want to go for. Because we want to only move left and right, we're only going to do a negative speed value and then 0 for the y coordinate. So here we have the speed here defined here, so we can only need to modify the speed in one place, and negative because we want to go left. So the value of the speed should be negative. All right, we have that, and we can return early. We don't need to go further down, and the rest of the logic is the same thing, but for the right direction. So here's the same thing. You don't actually need the return statement, only if you were to want to have some extra logic here. But I'm going to keep it just for consistency. So here it is, the second one, just copy the code. It's the same logic, just two values. You could maybe have a reusable block here. Yeah, you could have some reusable logic, but it didn't feel worth it. So now that we have this, I'm going to save, and then I'm going to have the last control handler. So this control handlers and then push. This time around is for when the player releases a key. So to do that, we're gonna do on key release, and then we don't need to actually check which key is released. We want to run this logic for any keys that is released. So if this current animation, okay, this is going to be really tedious to write, but it's kind of necessary, so I'm just gonna paste it here and go over it. So this is the logic. So we want to make sure, as long when a key is released, any key, if the player is not idle, if the current animation is not idle, the current animation is not jump, the current animation is not fall, and the current animation is not attack, if any of those animations are not currently playing, then we go back to the idle animation. And I think that's it. Now let's go back to the let's go back to the main.js file. Actually, no, to the room1.js, and let's create our player here, just so we can see something on the screen. So what I'm gonna do, okay, I see why I created the set position. Let's create our method here to set the position it's actually going to be used. So set position x and y value, and then I'll put page transition, and then here. Okay. So this position dot x, we set the x new x position. This position dot y, we set a new position. All right. Here we're gonna remove the initial position here as well. Not needed. And here we go. All right. In room 1, what we're gonna do is right after setting the map colliders, I'm going to actually define the player here and add it to the scene, but without specifying a position. So here I'm just gonna call, actually you don't need that. You just call the make player function from within, pass indicate, like that. So when you use the make function, you only need to call the add method on top, and we actually need to add this as part of the map. So now that we have a player created, let's write the logic for the position. So in much the same way here, I'm gonna create another const. I'm gonna call it positions, and it's going to be an empty array. And then here, instead of breaking, I'm going to have a continue, and I will have a second or first if statement that checks the layer name for positions. And if that's the case, then we're gonna push to the positions array. Push. Yeah, we're gonna push the layer. We're gonna spread the objects here. So the spread operator, look it up. It allows us to take an array and then spread it back into another array without like having an array in an array. So you take the element of one array and you put that into the second array, rather than putting the first array inside of the second. So it's basically, instead of having this, you'll have this and then every element 1, 2. So imagine 3 and then 1, 2, 3. So if you were to not use the spread operator, like this 3 dot, this is what you would get. But because you use the spread operator, it takes the elements of the first array and puts it inside of the second. Hope this was a clear explanation in case you're not familiar with this syntax. Okay, so positions, push, layer objects, okay. And then we should have all of our objects. So I'm gonna continue here as well. So here for now, this is not necessary. Okay, so now what I'm gonna do is for const position of positions, and then here, if the position, for now, let's do it simple. If the position is of the player, position.name is the players, is how we detect the player pin. So this one, if you remember, here we go. So here, it's named player. So by checking for the name, so if it's the player name, what we're gonna do is we're gonna have the set position, call to the set position method, and we're gonna take the data from this positional pin and set it as the position for our player. Now we're also going to set the controls by calling the set controls method. And for now, that's it. So if I look at the result, let's see what we get. Press enter, and we have our player. And our player can move. Can it jump? It can jump, but this time, yeah, you see the animations aren't resetting properly because we didn't add yet the handlers, not the handlers, the events. You're gonna see in a moment what I mean by that. So one thing also, if I press F1, you can see the hitbox, how it is positioned, etc. And when I use the sword, you can see how the hitbox change direction. All right, now that we have this, I'm gonna go back to the player, set the events. So the events are things. It's a new feature that I've discovered in Kaboom.js. It's not actually new. It was probably there, but it's new to me. So okay, before doing that, yeah, okay. So set events. This is the method I'm gonna call, and within this, we're going to set a bunch of events. So onFall is an event offered by Kaboom. It checks for when the player falls after jumping. And this is where we're going to just play the fall animation when that happens. So the onFall is something offered by Kaboom. This onFallOff, though, is another event offered by Kaboom, but this time around, those events are all specific to the game object, so it's not a global event. OnFallOff, the difference is that it's for when the player falls off a platform. That means there was no jumping before that. Here again, we need to play the fall animation. Now we also have this onGround, which is another event offered by Kaboom. And when the player is on the ground, we want to play the idle animation. And then finally, when actually it's not finally, there's a bunch of others, but for now, there's this the onHeadbutt event, which is when the player hits his head on a platform, or when the player hits an obstacle with its head. So for example, when the player jumps and hits the ceiling of a level, then this event will fire, and here we're gonna play the fall animation. So now let's just test this out. So I'm gonna go back to main.js. I'm going to actually room1.js, and here I'm gonna set those up. So player.setEvents. And now if I go and check the result, hit enter. You see, the animations are now perfectly correct. And then if I hit, so this is oops, we don't have the camera system working yet, but here is the natural progression. Here we go. If you hit headbutt, immediately the fall animation will play. And that's that. We have a bunch of other controls, and that looks good. Now we want to make sure that the player can pass through these platforms. So we're going to create another method. I'm going to call it, what's the name I'm going to use? It's going to be an enable pass through. So maybe, where should I put it? Okay, let's put it right here. So enable pass through, and here we go. And here, how to do this feature is there's something in Kaboom, a method called the onBeforePhysicsResolve. What it does, it gives us the collision that happens as the first param here, and then you can check for that collision. So if this collision is a specific target, so if the collision is with pass through, which was the tag you remember we had for those specific platforms where we want them to pass through, that we set up in tiled and then added to when we create the game object in the set colliders method function. And then here we make sure that the player is jumping as well. And this again is a method offered by Kaboom to know when the player is jumping. So, and then if those two conditions are met, so that the collision is supposed to be with a pass-through, is happening with a pass-through, and the player was jumping, we want to prevent the resolution of the collision. That means we don't want the collision to actually take effect. So that's why we call the collision dot prevent resolution. Okay, so once you call that, I think that's it. The feature is implemented. For more details, I have a blog post regarding this, so go to my Substack for that. So if I go here to room 1 and call the player.set pass through method, enable pass through, not set pass through. Actually, enable is a better name, but set would have worked as well. So if I do this, press enter, and then let's try it out. Even though with the camera it doesn't work, you can see I can pass through the platform, and even here as well. But here I cannot jump enough anyway. So So here we go. But when you're going to be able to double jump, you should be able to pass through that platform as well. All right, we have everything we need for our basic player movement. There is a bunch of logic when it comes to dealing and taking damage that we're gonna write later on. Now, okay, let's do the camera system. So for the camera system, what I'm going to do is we're gonna have to go back to our room1.js. And the same thing with what that we did for the colliders and positions, we're also going to need that. But this time around, yeah, we're also going to need to get the colliders for the cameras. The way I did it in my, yeah, that's strange. Okay, it's going to be a bit different. So let's go to room.utils and write a utility for that, because it's going to be used for both the room 1 and room 2. So here I'm going to create an export a function. This always make this mistake. Function set set camera controls, and then here we're gonna pass in first the player, first the K for accessing all the Kaboom functions, the player, the map, and the actual room data. And then here we're gonna need, first of all, actually never mind, this is not the this function is going to be useful, and it's going to be mostly used to control the camera. So I'm not gonna write the body of it right now. What I'm gonna do though is right below, I'm going to write the function for the camera zones. So the camera colliders, I just call them camera zones, and we need to just have 3 params, which is like we did with the colliders. It's basically the same thing. So we're gonna have 3 params. The first one is the Kaboom context, the second one is the map object, and the third one is going to be the camera's name, in much the same way that we did for the colliders. So let's assume that we have all those 3 for this for the time being, and then we will write the logic for that in the room1.js. So we have a for loop, and then we're gonna get the camera of cameras, which is our colliders, our data for those colliders that we had entiled. And then here for the cameras, for each of those camera colliders data we have entiled, we're gonna create a camera zone game object. That game object is going to, of course, be added as a child of the map. And we're going to have basically the same exact way we did for the colliders. So I'm just going to copy and paste the code here and explain over it. So an area component, which is a rectangle with the width and the height, and collision ignore being the colliders. Since the camera really don't ever enter in collision with themselves, we don't need to add a tag for cameras. Okay, so now the reason I created this and stored it in a camera zone constant is to have set our first event listener, which is going to be our camera on collide. So I'm just going to copy and explain here. So on collide is a method available on all game objects that have the area component. So here how it actually works. So you have your first game object, you have its method on collide, and you can pass in a tag as the first param, which is what tag you want, what game object with the following tag you want to listen on when regarding collisions, in regards to collisions, sorry. And the second param is the function that is going to fire when that event happens. So here, when the player collides with the camera zone, we're going to run this logic. This logic is simple. We get the current camera position by using the campause method function offered by Kaboom, which returns in vector2. That means we can have access to x and y properties for the camera position. So we make sure that if the x position of the camera is not equal to camera properties 0.value. So okay, so what is this? So this is, if I go to the export, okay, so the room1.json, maybe room 2. So let's go to room 2 because it's smaller and easier to detect or parse because of its smaller nature. So here in not positions, but in we have positions. Okay, in cameras, you see here the custom property that I created called CamPausY is added to a new properties tab here with this array. And in that array, for each new property you add, it adds a new object with the name, the type, and the value. Since we only have one new attributes and I don't really need to check for the name of it, I just decided to access the first element and access directly the value without having to check for the name. In case you want to expand this game further and want to use more custom properties, make sure to check the name first before accessing the value. Okay, so here I go, and then details. So we get the value, which is going to be the actual new camera position. If you remember here, when I click on the camera zone, CamPausY is the custom property with a value, and that value is basically the value we want for the camera. And here we're going to use a tween. So a tween is a way for gradually changing the value of something using a function, a mathematical function, an easing function. Here we're using a linear easing function. So the tween in Kaboom.js takes 1, 2, 3, 4, 5 params. The first param is the original position, but actually no, not just that, the reference to modify the value. So the original value, but a reference to the game object or the thing controlling that original value. Actually, never mind, that's not true. It's here we do the modification. So the first param is the initial value, the second param is the final value you want, and the third param is in how much time you want in how much time you want the transition to happen. So here I want the transition to happen 0.8 seconds from this initial value to this final value. And the fourth param is the function that will replace the gradually to the new value. So here val is called multiple times as following this function's pattern, the linear function. And for each call, it has an intermediate value between this and this that progressively gets closer to the final value. And here in Kaboom, to modify the camera position, you can also call the CamPause function and then pass in as the first param the x coordinate and the y coordinate. Since we only want to modify the y value of our camera, we will simply put back the same x value, x position for the camera, and just tweak just set the new y position instead by using this. So value here. This is an arbitrary name. You could have decided to name it however you'd like. And then finally, k.easings.linear are the various easing functions you have access to. If you look at the documentation, you can have sign, sign in, sign out, etc. Linear is just the one I decided to use here. It's the one that looked good to me. All right, we have this. And let's go to room 1. And here again, we're going to do the exact same logic we did. So const cameras, and then empty array. And then here we can either do it like that. If layer.name equal cameras, what you're going to do is, or maybe you should do this here on top. It doesn't really matter that much in the end. So if the layer.name is the cameras, what we're going to do is we're going to push to the cameras array and spread from within layer.objects, which is again going to give us the collider, the collider data for the cameras. And then here, now for the actual usage, where did I use this? I'm just going to make a call to set camera zones, maybe right after this. Doesn't really matter. So I'm going to do this here. Actually, it probably is better to call this here. So set camera zones from here. K dot map dot cameras. There we go. Okay, let's look at the results. Press enter. Now if I do this, the camera slides downwards. If I drop down, again, it follows everywhere. Maybe not the left hand side, because we only control the y position. We need to actually write the logic for the X position. So the X position, we just want the camera to follow the player, and that's the role of the first utility function that I was about to write is called set camera controls. So here, what we do, the reason we need also the room data, because there's specific data that is going to allow us to bound the camera to certain limits. So here in room.utils, let me just check it out. Okay, so how we're going to do this is we're going to use a onUpdate method, a Kaboom method. So onUpdate is called every 60 frames. It's where you can write more granular stuff. So here, if the state.current and then player in boss Vite, then we return early. Well, why we do this? Because when we're going to have the actual boss fight, we want to make sure that the camera isn't controlled, is fixed basically to only the room, the boss battle room. Here I'm just going to import the state from the global manager. So player in boss fight, I think that was the state. Let me look. Is boss defeated? Player in boss fight. Yep. And here, player is in boss fight. I made a typo error later on. So fix that in state global state manager. So here, if state.current, if player is in boss fight, we just won't run the logic, what comes next, because we don't want actually the camera to follow the player. And then the next stuff that comes right after, I'm going to copy and paste it, is if the map position X is plus 160 is superior to the player position, then we're going to clamp the camera position to be stuck at this value. This is so that when the player cannot go too much to the left, the camera cannot go too much to the left to the point that we can see outside of the bounds of the map. And then finally, the last if statement here we need is this. So if the player position.x is superior to the map position.x plus the room data.width, this is the actual width of the whole map, multiplied by the room data.tiledWidth, which is supposed to be like 32 or 16 minus a certain value. This is what looked good. Then we're going to clamp the camera, but to the left, to the right. So it won't go past a certain point to the right. And that way we will never allow the player to see outside the bounds of the map. And otherwise, if those conditions are not met, so we just make sure that the camera just follows the player from the x-axis, but the y-axis remains intact. So that's why I only modify the x coordinate and not the y. So for the y, we just take the current camera position. All right, let's check the result for that. So here we go. If I move to, maybe I should drop down. And then, okay, I forgot to actually call the function. So set camera controls needs to be called, and where we're going to call it is in room.1.js, maybe right after here. Okay, but this is an issue because the player isn't yet added to the scene. So we need to first wait for the player to be declared, and then we do this. So now if I look at the result, press enter, set camera is not defined. I forgot to import it here. Set camera controls. Now everything should work. So let's look at the result. Press enter, and now the camera follows us. That's nice. So if I drop down, it also follows us on the y-axis. So we cannot go past this point. We will never see the bounds, the outer bounds of the map. And then even if I go here, everything works all right. So yep, we have the camera now done, and this is not done. I fall. So that's something we need to fix. Why? Let me check. Let me debug. Why is this an issue? If I go here, we have a collider. We have a collider, but no body component. So we need to go back to VS Code, where we defined the in Rumio.utils the set map colliders. If it's yep, here, we forgot to add for the polygon colliders the body component with the is static property, because at the end of the day it's a wall type, it's an obstacle. So now if I look back at the result, press enter, and it should hopefully work. So here I drop down and yep, it works. All right, we have the camera system up and running. That's great. We can pass through those platforms as well. Let me see if I can go back here. So now what is left is to do the start implementing the enemies. After the enemies, the boss fight, and after the boss fight, the linking with the other scenes. So for now, if I go here, there's nothing that happens, and I am out of bounds. So now it's time to work on the drones. So it's an enemy type that will follow the player and explode when entering in contact with the player. So in the entities folder, I'm going to create a new folder. I'm going to call it enemy drone.js. Here we're going to follow the exact same pattern I did for the player, which is create a function that is going to act as a constructor. I'm going to call it make drone. Here I'm going to use as the first param set the k, the context, and then as a second param I'm going to have an initial position, because here we're just going to create the drone and set the position immediately. Then here we're going to return a make call, which is going to create the game object, but not add it to the scene. And then here we're going to have a bunch of components. So the positional component is important here with the initial pause. We're going to need to have a sprite component. The sprite component is going to be the drone sprite with the anim flying. This was defined in the Kaboom loader function, by the way. Kaboom loader file, sorry. And then next, we're going to need to set the hitbox, so the area component is going to be used. Here we're going to have a shape with a new k.rectangle, and then k.vector2. We don't need an offset really. 12 by 12 would be a good hitbox. The anchor is going to be centered this time around, as I did with, I think we did the same thing for the player. I don't remember. And then here for the body, here things are going to be different. We're going to set the gravity scale. So gravity scale is another property you can set within the body component. And I'm going to set it to 0. So basically, we want our drone to have basically not be affected by gravity at all. So it's going to be floating around. I'm also going to use a new component that I haven't explained yet called the off-screen component, and set the distance to 400. So this, what it does is that when when the drone is going to be off screen, so that means as the camera is scrolling and the player is moving around, let's say we have a drone that was following the player, and then the player was able to get away, basically. And what we want to do is that if the distance between the camera, the screen, and the player, the drone is at 400 units, I guess, pixels, whatever, then we're going to respawn. We're gonna not respawn, but reposition the drone to its original position. So here we're just using the off-screen component. Then later on, I think we're gonna use some of the event listeners that comes with it. So when you use the component, you have access to a bunch of methods that you can use later on. So not right now. And then here we're gonna play around with a state machine, which is basically what we're gonna use to code the AI. So I'm gonna explain what a state machine is in an instant, but for now, let me just teach you how to use the state component. So the state component starts with a first state. States here are just arbitrary names that you decide for yourself. I decided to create 1, 2, 3, 4, 5 states here, and I'm gonna paste them as to not waste too much time. So here are all the states I have decided to create, and you need to specify a default state, and that default state must be one of the states you have decided to create here. And the default state I'm going to pick is going to be the patrol right. So what is this? What is a state machine? So a state machine is a way for you to code an AI. So if I open up the Excalidraw and try to do a schematic, so we have, imagine you have a bunch of nodes, and then for each of those nodes there are states associated. So patrol right. Okay, that's too big. Maybe okay, zooming out. So I'm gonna just here. So we have our first state patrol right. We have, I'm gonna just copy that around, patrol left. Okay, that's kind of strange why it's behaving this way. Patrol. Okay, that's strange. Okay, my point here is that by having those names, you're able to define behaviors. Okay, so here, let's try to explain without a diagram. So those are names that are arbitrary, and for each of those names, we're going to define a couple of events that happens when the entity, the game object, will enter or be in those states. So here, I have decided to name patrol right, patrol left, alert, attack, and retreat. And for each of those state that I've decided to name, I'm going to write logic that is specific to them. So when the drone enters a specific state, a specific logic is going to run while they enter in the state, while they're in the state, and when they get out of the state. Depending on the state we want, depending on the state, we're going to do different things. So let's just add the health component. I'm not going to re-explain here. Basically setting the health for 1 health point for. Actually, did we set the health for the player? Did I do that? Yeah, we did. Okay. So just I'm gonna just set the health to be 1, and then add a tag to be of drone. And then here is we're gonna do the AI coding, the state, etc. So you're gonna understand this more in a moment. Okay, so here are a few properties I want to define. So I'm going to have a speed of 100, a pursuit speed of 150. So this speed is going to be the one used when the player when the drone is following the player. The range is going to be 100. That's the range in which the drone is going to start is patrolling and is going to start following the player if they detect the player. And then here I'm going to create a method called setBehavior, and it's where we're going to define the logic related to the state machine. The state machine. So the first thing I want to do is I want to get the player, because I'm going to have to do a bunch of things, compare the distance between the drone and the player. And one way to do that is just to have a constant called player and then use the get function to get the player by using the tag. And as I explained earlier, since the player is going to be added or is already added as a child of the map object, we need to use recursive and true property, and so for it to work. And then here I'm gonna set we only want the first element. There is only one player. By default, get always gives you back an array. Okay, this is where things get interesting. Since we used the state component, we have access to a bunch of methods called the onStateEnter method. It's an event listener that you pass in as the first param the name of the state you want to define an event for. Here, patrol right. And then the second param is going to be the logic that is going to run when the drone will enter this state. So here, what I want to do, I'm going to use an async await here, because what I want to do is I want to await and then call the wait function in Kaboom. So here what it does, the wait function basically will wait 3 seconds before running what comes next. That's due to the await. So await, you have to wait for it before you can continue on. I'm not going to dive deeper into the async await. I have done so in previous tutorials, so maybe reference that. I might write a post on this, but the reason we're using await here is specifically so that we wait those 3 seconds before running any other logic that comes after here within that function. Then we're going to have a check. So if this dot state is how you access the current state, if that state is patrol right, what I'm going to do is I'm going to call the enter state method, again provided by Kaboom if you use the state component, and I want to enter the patrol left state. Now this might sound strange. You're already in the patrol right state. Why would you check that? Well, actually you don't know, because what comes after is another event listener, and this one is called onStateUpdate, and it runs every frame, every 60 frames, every frame. 60 frames per second. Yeah. I think every frame. All right. So here we have the onStateUpdate patrol right. So what is this? It allows us to create an event listener on a specific state while that will fire the second param, which is a function that is going to run all the time during the time that the drone is within that state. So here, while we are, so imagine this is while we are in the patrol right state, run this logic and it will run it every frame. So here, what we're going to do is to have an if statement that will check this position distance. So dist is a method provided by Kaboom for vector2 components. It allows us to calculate the distance between one vector2 with another. So here, player.pos is the position of the player and is accessible because we imported the player here. And then if that distance is inferior to this dot range, that means we are within the range of the drone, and this time we want the drone to enter into the alert state. And then we return early. Otherwise, we want this dot flip x to be false. That means we want make sure that the drone is facing right, and then we want to make the drone move at a normal speed. So now I hope this makes a little bit more clear why we do the if statement here. Because when we enter the state, this runs once. And while we wait 3 seconds here, this is running multiple times because it runs every frame. So the situation can change, the state can change within this before we arrive to this line of code. So I hope you understand that. So just to repeat, here it runs once when the drone enters the state. Because it's the default state, this is also going to run once without having to call an enter state by default. And then here it's going to wait 3 seconds before moving on to this line. However, while we do that, this state update is running every frame. So in that time, during it runs every frame, the drone is moving as long as the player is not within the range. As soon as the player is within the range, we enter a new state. We enter the alert state. That means by the time that after the 3 seconds elapse, we arrive here, this state could potentially no longer be patrol right. Now we're going to do the same thing, but for patrol left. So I'm just going to copy and paste and mention a few things. So here we have patrol left, same logic, but instead of patrol left, here right it's left, and here it's left instead of right. And then here the only difference here is that we want to flip, because by default the sprite for the drone is facing right, so we want to flip it for it to face left, and we move to the left by adding a negative sign to the speed. So now it's time to define the logic for the alert state. So on state, when we enter this alert state, we want to run the following logic. We want to wait 1 second before initiating a pursuit of the player. once we have waited, we want to check if the distance between the drone and the player is still inferior to the range. If that's the case, we can enter, we're going to enter the attack state. So attack is basically following the player. You could have named it pursuit instead. So attack state. And then we return early. Otherwise, we're going to enter the patrol right again and reinitiate the loop of patrolling normally. Left, right, left, right, left, right. So just to diagram this, imagine you have patrol right here. Hope this works now. We have patrol left. What's the issue? Okay. Okay, for some reason. Okay, now it works. So we have patrol right, patrol left, and then we have alert. So here's the alert state. Alert. And then we have the attack state. So maybe I'm gonna put it here. Attack. Whoops. Oh. All right. So let's diagram this out. So initially we have the patrolling. So patrolling is basically going from patrol right to patrol left, and from patrol left to patrol right. However, sometimes if the player is too close, we go into the alert state. So while patrolling right or patrolling left, if the distance of the player is if the drone is close enough to the player, then the drone will enter the alert state. And then after 1 second, if it's still the case, the drone will attack. So I hope that illustrates the situation. So we have that. And then for the attack state, we're not going to need to define an on state enter, but we only need to define the on state update for it, because we just want the action to immediately go, the movement, the following of the player. So here, if the player, that position, distance, and then player position, if that is superior to the range, that means as soon as the player is able to get away, is getting far enough away from the drone, we will enter back to the alert state. And then from the alert state, after 1 second, if it's still the case where the player is far enough, it's going to go back to the patrol right state. And then we return early here. Now, on the other hand, if this dot enter, so if it's not the case, wait a minute, no, never mind. So we return early, yes, but now it's time to follow the player to attack him. So this flip X is going to depend on where the player is. So we can just have this Boolean expression where we check whether or not the player position is inferior to the position of the drone. If that's the case, then it's going to be true. And if it's true, that means the player is to the left. So that means the drone should also be facing left. Same logic for the right. So if it's false, that means the player is to the right of the drone, and that means the drone should be facing right. And then here I'm going to use the move to method offered by Kaboom on on objects that have the body component. And you can specify destination. So here I'm going to specify vector2. I want the player position .x, but for the player position .y, it's going to be +12, just to have a little bit of a gap. And then I'm going to explain everything. Let me just finish typing and I'll explain things. So pursuit speed. Okay, what happens here? So move2 is the function from Kaboom. It takes two params. The first param is the destination. The second param is at what speed you want the drone to move towards. Here, instead of just taking the exact same position, having a bit of an offset makes sure that the player, the drone will actually, how do I say, will try to collide into the to go outside of the player. So it's a bit hard to explain. Let me make a drawing. So by having the target here, so imagine this is a target and this is the player. By having the drone target this, we are making sure that basically if the drone arrives to the player, it's going to collide with the player. However, if we were to just have the exact same position here, so depending on the situation, the drone could stop just right here and remain here. So the collision would never end. That would be the thing, because you have on collide and then the collision would never end. Well, actually, never mind. It's not the collision would never end. Basically, I think that's the reason I did it initially. But thinking about it again, maybe it doesn't make any sense. So you know what? Instead of trying to justify it, let's just remove it for now, and then we'll see. We'll re-add it back when we see if it causes any issues. All right, so we have this, and then we have the attack, state, everything, and then that's it. That's basically it. That's the AI logic. Now we also need to set the events for it. So I'm gonna create another method called set events. By the way, set events, etc., and set behavior are just methods that I created, in which we use a bunch of methods offered by Kaboom. So for set events, I'm also going to have a reference to the player. So we're gonna have the exact same logic, recursive true. Remember that because the player is a child game object of the map. And then here we're gonna have this.onCollide, which is an event listener provided by Kaboom. When we collide with the player, we want a few things. So, whoops, not that. If the player is attacking, that means we want to return early. We don't want to destroy the player. That means we want this invulnerability to the player. If, however, that's not the case, then we first hurt ourselves, the drone, because the drone self-destructs and it has only one life. So using the heart method, which is provided by Kaboom if you use the health component. And then here we're going to have a new feature in Kaboom called, well, actually we can, never mind. It's not a new feature. Here for the player, we can also call the hurt function and reduce the life by 1. Why we do this, how we can do this, because remember the player also uses the health component. That means it comes with methods to manage health. So here by calling hurt, it's a nice and easy way for you to deduct life from the player. Now here on anim end, again, another event listener provided by Kaboom. We want specifically to check if the anim that ended was the explosion, the explode anim. Again, these animations are all imported at the beginning of the project in the Kaboom loader file. If it's the case, we just want to destroy the drone. Now here, this.onExplode. So this is a custom event. It's a feature in Kaboom that I discovered recently and makes your code very, how do I say, more clean. So you can define custom events by using this on function. I have written a blog post about it. Again, if you're interested, I will put the link in the description, hopefully, if I don't forget. So yeah, and here, so the way you define custom events is you use the on method here, and then you decide on a name, and then the second param is what is going to run when this event is triggered. You can later on you use the trigger method to trigger a specific event. I'm going to show it to you. Here, I'm going to play a sound. So you play a sound by using the k.play function. and passing in the name of the sound. So here, boom. Where does this come from? It comes from the Kaboom loader. We imported those sounds initially here. So here is all the sound imports. All right. Then what we want to do is not only play the sounds when we trigger this explode event, we want to also have a collision ignore. We want to avoid the drone from colliding multiple times with the player by just like removing any, making sure that any collisions with the player is avoided, is negated or ignored when the drone is exploded, because we have already deducted life points, one life point from the player, so we don't want to have a situation where we do this multiple times because the drone is still colliding with the player while it explodes. We also want to use the unuse method, which allows you to unuse a component that you added to a game object initially when you created that. So here you can just use a string and refer to the name of the component. So I want to unuse the body component. And finally, I want to play the explode animation. So here, be careful to not mistake this and this. This is for playing sound and is a method from Kaboom. And this is a method offered by Kaboom, but from the game object. So this is for playing animation, while this is for audio. Now here, we're going to have another onCollide. Here we're going to have another onCollide, and then, yeah, so we have a sword hitbox. So this is the logic we want to run when the player hits with the sword the drone. And here we're going to only hurt the drone itself. So by having the hurt 1 here, it's going to reduce 1 life point. Basically similar to this, but we don't have to worry about the player logic. And then here is when we define the... So here it's not a custom event. The hurt event is a specific already existing event offered by Kaboom. What it does is that it allows you to run something when you use the hurt function. So when I say hurt, when I call the hurt function, it's going to trigger the hurt event also offered by Kaboom. So here what I want to do is that when we reduce the life point of the drone, I want to check if this.hp gives you the current HP of the game object that uses the health component. If it's equal to 0, so if it's equal to 0, I want to trigger the explode custom event that I just created earlier on, which is going to take care of exploding, playing the sound, and making the drone actually explode with the animation, etc. And then that's it. One thing left is this on exit screen, which is offered by the off-screen component, allows us to have this method available. So when the drone is no longer visible on screen, if this.pause.dist initial pause is superior to 400, then this, I'm going to explain everything. This dot pause is equal to initial pause. So here what it does. Did I have the initial pause right defined? Oh, I made a mistake, a typo here. Initial pause position. So what does this do? Well, here is that when this will run when the distance, the player is off screen with a distance of 400. And then here, actually, I don't think you need to have this. You can just set the position to being the initial position, basically respawning the drone where it originally was. And that's it. That's the whole logic for the drone. So let's actually use it now. let's place the, so here I'm gonna go in room1.js, and then room1.js, and then here, yeah, so for room1.js, for the positions layer, so here, so I'm gonna have a continue here. Now if the position.type was drone, remember for classes in tiled, you can access the name with the .type instead, which is kind of strange, but it's that. I think class is probably a reserved keyword anyway. So here, position.type equal drone. We're gonna create the drone game object, but place it as a child. Here I'm keeping a reference to it because we're gonna do gonna call the two methods we created. So here map add, and then here make drone, and then here pass k, and then position, and then here we need to pass a vector 2 with the position.x, and then position.y, and then drone.set behavior, which is the method we defined, and then drone.set events. All right, now that we have this, arctic2, I think the drone should appear in our game. So I'm gonna refresh, hit enter, and then we have a little drone. So let's see if we can, yeah, you see, that's the issue. That is that the drone remains kind of stuck above the player, but not exactly colliding fully with the player. That's why I added a initially here, instead of following exactly, I added an offset of 12. And now if we look back, if I let the drone come to me, it explodes, you see? So yeah, that's a quirk of the move to method in Kaboom, I think. And then we have another. Now let's see if I can attack this one. Let's see if we can attack. Okay, it's a, yep, I was able to attack. So that's pretty nice. So now what's left is the boss, and after the boss, I think we're gonna display the cartridges which are health pack, and then we link the two scenes, and then the game is mostly done, I think. We probably have to just add an intro and etc. By the way, if you cannot hear the sounds of the drone exploding, that's on me. That's my setup. Sorry. Maybe it's too late for me to verify if it actually recorded it properly. But yeah, just for your information, on my end, I can hear the sounds of the explosions when playing the game. So the first thing we're going to implement is the boss barrier. So for the boss barrier, we're going to go to the room 1 because it's something that is very exclusive to this room where the actual boss battle is. Now I think it was in the room utils instead, and here when I left it to do. So for the map colliders, so if we have the boss barrier map collider, what we're going to do is to have the following code. So here, so I'm first going to create a constant where I will hold a reference to the boss barrier. So first we create the game object that of course is a child of the map. Now here it's not that interesting, but okay, let's yeah, I'm just gonna copy and paste most of the concepts we have already seen. So here are the components we're going to use for this object. So a rectangle with a width and a height. The reason I'm using here the rect component instead of doing this inside of the area is because at one point we're actually going to see the rectangle. And we're going to set this color for the rectangle for the gate. And then the collider X and Y, and then ignore collisions with other colliders. And set initially the opacity to 0. And finally the boss barrier tag. Now we're gonna also have an object where we're gonna have a few methods. So the two methods we're gonna have is the activate method. So this is a method which takes care of, by using tweens, it's going to make the gate, the boss barrier, sorry, from invisible to visible. So here we're gonna first set the opacity from 0 to 0.3 in 1 second using the linear here. I have already explained how to use tweens here previously. Now here the tween is going to be the camera. So as we are changing the opacity of the gate, we're also moving the camera, so that we're gonna make the boss battle arena take center stage. And this is the reason I'm not using any await here, because we're doing this at the same time. So when you run this, because tween is asynchronous, it will run on its own, and then the code execution will continue to the next one, even though this is not done yet. So that's that. And then after this activate method, we're gonna have a deactivate method as well. And for this one, I'm also going to paste the code here. I don't think there's much need to manually type it. So here we have an async deactivate method that takes the current X position of the player. It will make the gate, the boss barrier, disappear. So here. And then it will move back the camera to the player's position. And then it will destroy the gate after after it has fully disappeared, so that the player can move out of the arena. And then here's some other logic we're gonna need. So here, this is within the boss barrier, but now we have also content outside of it. I mean, not content, I mean logic to write outside of it in an onCollide event listener. So when it collides with the player, we're gonna have it in async. And here, one thing in Kaboom.js is that when you use an onCollide with the tag here, onCollide will pass to the function you use as the second param the game object that is collided with, that the tag that the game object is colliding with. So here it's the player tag, so it's going to give you the player game object. So that means we don't have to use k.get here. So that's pretty handy. So here I'm going to first have a current state constant, just as a shorthand for this. Actually, it's barely less characters, barely less. Anyway, I'm just gonna keep it. And then here we're gonna have a first an if statement, and then if the current state is boss defeated true, whoops, if that's the case, then I'm gonna set a new state, so state.set. And what I'm gonna set is here this is where it's handy to have the state props enum. It makes things less error prone. I can immediately select the is boss defeated and then set that to being true. Or actually, it's not that. We want to set if the player is in a boss fight. So if player in boss fight, I should have named this is, but anyway, just to not generate any confusion, I'm gonna do this like that. So now I'm gonna set that to being true, actually false, because the boss has been defeated, sorry. And then we're going to make a call to the deactivate method and pass in the player position X. Now, after doing all of that, we return. So when the boss is defeated, we set back the players in boss fight player in boss fight Boolean to false. We deactivate the boss barrier. Then if it was not the case, then we also need to check another case. If the current state dot player in boss fight, so actually if now the player is in a boss fight, we also need to skip, so we won't process the logic that comes after. So we have two cases that we want to avoid going further. The first case is if the boss is defeated. That means we just want to destroy the gate. However, if the player is in the boss fight, we just want to return early. So colliding with the boss barrier will do nothing special. So now the case here that we're gonna write now, the default case is when the player first collides with the boss barrier. So when that happens, we are going to first disable the player controls. So this is something I did not write in the player logic, so I need to do that. So if I go to player.js, and then from player.js, let's write a method maybe here, right? Disable controls. And this is where we are going to use the control handlers that we had initially. So what I need is simply to have a for loop that will iterate through the various handlers that we stored in this dot control handlers, and then cancel them. So the way you do that is by calling the cancel method. By default, all of these handlers have access to that method. And then of course, don't forget to add the comma here. All right. So now we have disable control. And there's also another logic another method I should probably add is called respawn if out of bounds. So we want to make sure the player respawns if they fall off a platform. So here I'm gonna set 3 value, the bound value, the destination, 3 param, sorry, the destination name, and then the previous scene data. And by default, it's going to be exit name null. So this is going to make sense in a moment. So actually for now, I'm just going to leave it to do. It's going to make sense when we're going to link up the various scenes with each other. So now I'm going to go back to the room utils. And then from there, after having written the boss player on collide, I can write okay, first I make a call to disable the player controls because we want to basically force the player to go through the gate and not arrive with a situation where the player doesn't avoids the gate. Basically, as the gate is sucking the player in, the player is trying to could avoid it and move to the other direction. We don't want to have this situation. Otherwise, you're gonna have a bunch of bugs. So by disabling the controls of the player and forcing him to go to the gate through the gate if they collide with it, to go to the boss battle, and it's a bit like that in the Souls game. Once you commit to going through the gate, there is no going back basically. And then I'm gonna play the idle animation while we do this. And then here I'm gonna again have an await for a tween, which is going to be responsible for changing the player position from this to player pause.x but plus 25 pixels, so that we make sure that the player goes through the gate. We want to do that in 0.2 seconds. And here we have the value function that basically do the adjustments of the value until the destination is reached. And then here with an easings linear. And then once this is done, we are safe to do player.setControls again, so that we give back the player controls, the controls to the player. So this is a wait, so that as long as this is not done, we want to proceed forward. Otherwise, if you were to remove that, this would run while this would also run. So that means the player could escape and go out of the gate, out of the boss arena, while the transition would happen. All right. Now another one. So after having the onCollide with the player, the boss barrier, we also have the onCollide end. So not only can we in Kaboom.js know when you collide with something, but we can know when a collision ends with a game object as well. And then here, we don't really need to have the player game object here. What we want to do is that once the the collision is over, first I'm gonna hold the current state like that, just for it's handier, I guess. And then I'm going to have current state, and then if the current state is a player boss fight, so if the player is in a boss fight, or current state dot so if either the player is in boss fight or the boss is defeated, so is boss defeated, then we return early. We don't do anything. And then otherwise we're going to set, so state dot set, so state param enum to make things less error prone, and what we're going to set is the player in boss fight, and here we're going to set it to true, so that the boss fight is actually starts, and then the boss barrier will activate, preventing any, what actually the activate does is just going to show the boss barrier, and then we're going to assign to the boss barrier a body component. So the way you add a component after the fact, after having created an object, you use the use method. And then here we want it to be static because it's an obstacle. And then here we go. And that's basically it. So now if I go back to the game and hit enter, and if I just go back to the boss arena, and then this is following me. Yep, you can see the boss arena is here. And I cannot escape. So maybe let me just retry this time around without activating debug mode so that you can clearly see. So here we go. I'm playing around. Then as soon as I hit, I'm transported and I'm stuck here. So now it's time to code the boss battle itself, so the boss itself. So how we're going to do that is we're going to create a new file in the entities folder. That file is going to be called enemy boss.js, and it's going to take the exact same, mostly the same properties, etc. So what I'm going to do is I'm going to copy and paste a bunch of stuff, but for now let's first write the constructor function, so make boss, and then pass in the k and the initial position. As for the components, we're going to of course return a k.make, and then here for the components, I'm just going to copy and paste the first few components here. So we have a state machine with different states. We have the idle state, the follow state, where the boss follows the player, the open fire state, where the player, the boss starts opening fire from their flamethrower, and then the fire state where it's firing, and then the shut fire when the animation to close the flamethrower will play, and then finally the explode state, which is where when the player, the boss dies. And then here we have a mass of 100 and a jump force. Initially I made the boss jumping as well, but I haven't used this anymore, so feel free to remove it. Here it's again the same thing. Here the animation is burner, the sprite, and the animation by default is going to be idle. And then the health, I gave him 15 points of health, and opacity initially it's 1, but as with the player, when it gets hit, when the boss gets hit, it flashes, so it blinks. So now what we have here is our various methods. So let's first, I'm going to copy and paste the various properties as well. So pursuit speed, fire range, and duration of the fire. And then right below, we're going to have the set behavior and set events. So set behavior and set events. Much of the same structure as I did with the player and the drones and etc. So here we go, and yep, I'm going before going onward, I'm gonna just define a reusable function that will make any game object blink. As I explained, it's when the player or the bosses or the enemies take damage, except for the drone because they immediately die when they jump on when they hit you. So, but for the boss and the player, there is some reusable logic we can write. And I think I'm gonna create a new file in the entities folder. I'm gonna call it entity shared logic.js. So what does this do? It will make, gonna have a single function. I'm just gonna copy and paste it here and then go over it. So basically we have a make blink function that takes the context, the entity, the game object, and then its time span. By default, it is 0.1. You can specify a different one if you want. So it's an optional parameter. And then here, we use tweens to make first the opacity go from 1 to 0 in a certain time span, and then the reverse. So the first one is important to have await so that this doesn't run as this is running. But the second one, there is no need to have an await because it's the only thing here. So hope I made this clear. All right, so now for the boss, if I go to set behavior, I'm going to, actually, first of all, let's add the blink logic to the player. So in the set events here, I'm gonna add a bunch of events to handle that. So for the player, remember the heal and hurt events, so we can use that. So this dot on heal event listener is something that is offered by Kaboom if you use the health component on your game object. So here what I'm gonna do is I'm gonna set the health state as follows. So state props enum, and then here player HP, and I'm gonna set it to the current, so this dot HP of the component. And then I'm going to trigger, actually hit here to do health bar logic. So of course we're going to have a UI element that is going to update, or so here we're going to trigger a custom event for the health bar. We haven't created the health bar yet, so that's why I'm just going to put a to-do message here. The other one, which is actually why I came in this file first, is because we wanted to make the player blink when they get hurt. So we're going to do that inside of the hurt event listener. That of course is offered because when you use the hurt function, the hurt method, to reduce the life point of the player, the health of the player, this gets fired. And here, this is where we're going to call make blink, and should normally automatically import it. So if you go upward, it should be imported. All right. So make blink is going to take okay, and then this, which is the game object itself, the player itself. And then here in this logic, if the HP, as long as the HP is superior to 0, so if the HP is superior to 0, I'm going to set the state of the state props enum.player HP, and then set to the new updated HP. So remember, the HP method gives you the up-to-date HP. Calling the hurt on the player fires this event, because not only the hurt actually changes the value, the health value, but also by having this event, we can make the player blink, but also make sure to set the state for the global state, so that when we move on to the second room, it's going to keep track. It's going to have the same health value. Otherwise, everything is scoped. So by default, the comp, the component HP health is scoped on the scene where the player is created. Actually, I think there is maybe a method called stay in Kaboom.js that allows you to have the same game object stay in the next scene. I haven't yet learned about it much, but I just remembered that it exists. So maybe we could have gotten away with not having to deal with global state like that. So something to check if you want on kaboomjs.com, which is the official doc site. Here we're gonna also have a health bar update. So I'm just gonna leave a comment here, and then we return early, because otherwise we will simply have the following code. So in case the HP is not superior to 0, I'm just going to copy and paste this part, we're going to set the state of the player HP to be the max player HP. So the reason for this is that we're basically respawning. Now you could put this later on. You could put this after. So that first you have the boom sound, then the explosion, then the health bar, the health of the player is set to being full health because they were going to respawn. And then right below that, this on anim end. Anim. Here we go. So if the anim is equal to explode, which was triggered here right above. Explode. What's with the weird spacing here? We're going to go back to the same room 1 scene. So it's effectively respawning. So I think we have this, and yep, we have everything we need. So let's save that. Let's of course save this as well. So now if I look at the game, press enter, let's see if we take them, if we blink, if the player is going to blink. Yep, they blinked. So as you can see. All right, so let's do the state machine for the boss. So much like the drone, it's gonna basically have the same pattern. So a couple of this on state update or on state enter. So let's start with the idle state. So on state update we're gonna need here. And then so for the idle state, what we're gonna do is make sure that if the state and then current. All right, so now we need to check for the current state if the player is in a boss fight. So state.current and then player in boss fight. If that's the case, we're going to move to the following. So enter state, and then we move to the follow. So this makes sense because as soon as, so when the player is not in a boss fight, so that means they haven't passed through the gate. We don't want the boss to do anything. We want it to remain idle. However, as soon as the player, enters the gate, this is set to true, and that means that it's time for the boss to start following the player. So here we don't really need actually, in fact, this shouldn't be a on state update. It should be an on state enter. So, oh no, it's an update because when the room is initialized, the boss is placed. So we need to check this every frame until it actually happens. The player actually enters the arena. All right, the next event we need to listen on is on state, the follow event. So on state enter follow. What we're going to do is we're just gonna play the run animation. So here, so we have the play. Okay, so we play the run animation, and then for this on state update, for the follow as well, the follow state, we're going to, in case you didn't copy, here are the various state we're gonna use. So here, so for the follow state, every frame, what we're gonna do is we're going to first set the flip x value in much the same way we did for the drone. So if the player position is inferior to the boss's position, that means that the player is to the left, and that means that the boss should face left. That's why we do flip x equal true, because by default the sprites are drawn facing right. Now here, this dot move to, so we're gonna use the move to again as we did for the drones, and we're going to again do exactly the same thing. So move towards the player position with an offset of 12 here, so that we don't have this weird case where the player is, the boss will basically be stuck with the player, but nothing will happen. So then here we're gonna have a pursuit speed as well. Actually, in fact, I don't think it's needed here for this specific case, because at the end of the day, even if the boss gets stuck with the player can just move around. So yeah. Now the pursuit speed is the same as for this boss. For the boss, we only have a pursuit speed. so we don't have a normal regular speed like with the drones. And that's basically it for this logic. We also need to add an if statement, which will determine if we move out of the follow state. So if the position of the player position, no, if the position of the boss, sorry, is if the position of the player is near enough the position of the boss, and this we do this by checking for a specific range, so the fire range, so 40. So if this distance is inferior to 40 in this case, what we're going to do is we're going to enter into a new state, which is the open fire state. And then for the open fire state, on state, enter open fire, and then what we're going to do here is just play the open fire animation. I made a mistake here. It should be lowercase. And now, after this animation is done, we're going to actually have an on-anim end here. But for now, we're going to have this on-anim end logic inside of the set events and not here. So let's continue defining our various other states, and then we will tackle this later on. So here we could have this on state enter for the fire. So let's define the logic for the fire state. So what we're going to do here is create the flamethrower sound, which is going to be a reference to the sound of the flamethrower, which we can play like this. Remember, we imported this sound in the Kaboom loader.js file. Now, what we do next here is to have the fire hitbox. We need to create the hitbox for that. And we're going to basically add it as a child of the boss game object. And here again, it's the same logic we did for the sword attack for the player, just various different values here. So I'm just going to copy and paste that to go quicker. And then here for the logic for when the player collides with the hitbox, again, this is very similar logic that we did with the sword attack. But this time around we hurt the player, and then if the HP is equal to 0, we set the state. We set the player in boss fight to being false. That means that the player just died, and that means simply that they're no longer in a boss fight. And then here finally we have the k wait, which is going to wait. This is another form of the wait variant. So here I'm just gonna put the fire duration. So how long does the fire attack last? It's a property we created here, 1 second. And then we run this logic. So the second param is the logic to run. This is another form. You could have used a wait here and then did your logic right after here. But I felt that it wasn't really needed to use a wait here because we can just use this form. And then here what happens is that when the fire duration, so when the fire attack ends, we will stop the sound. So that's why I stored the sound here, the sound listener reference, so that I can easily use the stop method on it, which is offered by Kaboom as well. And then after we have stopped the sound, the boss will enter the shut fire state. Now for the open fire and shut fire, we haven't defined anything. For the shut fire and open fire, we haven't defined any on state enter or stuff like that. We're going to do this in the set events. We're going to actually just in our on anim and event listener, just run into enter those states. All right, so now let's define those. Let's define the remaining on-state enters, on-state end and on-state update for the fire. So this on-state end for fire state. So this happens here. And then inside of this, we just use that state to delete the fire hitbox. So as we did with the sword attack, you get the fire hitbox and then you check if it exists before trying to destroy it. And then finally, we have two things. We have the shot fire. So sorry, I was inaccurate later on. I said we wouldn't define a on-state enter for shot fire, but we actually do here. We just play the shot fire animation here. And as here, the on-state update for fire, this is useful to simply play the fire animation if it's not already playing as we go here. But here I realized that we could have just defined this here. So yeah, I think this is not a necessary state. We can take this line of code. I'm gonna just comment this out and I'm gonna paste it here. So we just play the animation of fire right here. And like that. So now let's go to our set events. Here again, we're gonna get the player. So as we did, oh, actually we didn't do this here. So const player k.get player and then recursive true and then index 0. And then here we're going to define an onCollide here. So this time around it's the reverse. It's when the boss collides with the sword hitbox. We play the boom sound and then we hurt the boss, so we reduced its health. And this is an important part that I referenced earlier on. We're talking here about the this on anim end. We're going to use a switch case statement here. So if we are in the open fire state, we enter the fire state. So here open fire, if I remember correctly, we just play the open fire animation. This open fire animation ends. It's not an infinite loop. The loop property wasn't set to true there. If you look at the Kaboom loader.js file, if you remember. So if we go here to the boss, the burner, yep, is the boss. So for open fire, there's no loop set to true. So that means that the animation plays once and then when it ends, it ends. That's why we can use in our code here, where is it? Where is it? Here. That's why we can use here the on anim end listener. So we do the same thing for the shot fire here as well. So when the shot fire animation ends, we enter the follow state. And finally, when the explode animation runs, after it runs actually, we call the destroy method function from Kaboom to destroy the boss. So the boss has been defeated. And then right below that, this is where we're actually going to define a custom event called this on explode. This is exactly the same thing we did for the drone enemy. So here we enter the explode state. Now here explode state, we haven't defined it, I think. Did we do? So the purpose of this is just to have a state that is different than what is the other states. So it doesn't do anything really, but yeah, that's that. It's just so if we weren't to do this, it would the state machine would enter other states and then it would conflict. So by having a dedicated state, useless state, quote unquote, we were able to not enter this case. And remember that here the explode, you need to add it as well here in the state array at the beginning. So what we do here, we set collision ignore to the player for the same reason. We unuse the body, we play the boom sound again. We play the explode animation, which after it's done, it's going to destroy the enemy, the boss. We set the isBoss defeated to true state to true. We set the isDoubleJump unlocked to true. And then here I have enable double jump method. We haven't written this, so let's just write it out quickly. So it's a one line, basically one line method. So I'm gonna put it maybe at the end of the player. So let me collapse this so it's clear, like that. So enable double jump, the way you have access to the num jumps property if you use the double jump component, and you can set it to a number you want, and here we're gonna set it to 2. So now if I go back to enemy boss, it's gonna do that. We're gonna play the notify sound, which is a sound that basically will display this notification box. Now make notification box does not exist yet, so let's create it out. Let's create this UI element. So I'm gonna go here. I'm going to go to the UI folder, which is empty, and I'm going to create a new file. So this file is going to be called notification box.js. And what it's going to contain is the following. So we first have as a first param the context as always, and the second param is the content. Then here we're going to make a game object, which is going to be a rectangle and with a darkish blue or purple color. And then we're going to use the fixed component so that it is not affected by the camera. We're going to center the position by calling k.center, which gives us the coordinates for the center of the canvas. The area component is important here because we want to set the anchor as a center, and the method we're going to use is create is simply a close method that just destroys the notification box. And then as a child of that container, because initially it's a container, we're going to put a text component, so a child game object that is going to have a text component that is going to use the glyph mess font that I showed you at the beginning of the tutorial, and the size is going to be 32. This is what looked good. As for the color of the text, this is what looks good and fits with the color palette. Here area and anchor center again so that the text is centered, and then we return the container. So that's our notification box. If I go to the enemy boss, here you can see the text I have put. You unlocked a new ability. You can now double jump. And then after 3 seconds, we're going to call the close method that we defined here so that the notification box is closed. So here we just add it to the general canvas instead of the map because it's a UI element. And we just store it here so that we can have access to close. We can call the close method. All right, now let's import that properly because it didn't do it for us automatically. So here, import make notification box. Remember to add a .js, or otherwise you're gonna get a MIME type error. And and that's it. So now that we have that, I think we have everything we need for the boss. And it's now time to test it out. So let me just make sure that's the case. We have one last thing, one last event. So the hurt event for the boss. So as I explained multiple times now, the hurt event is something offered by Kaboom if you use the health component. And here we're going to make blink the boss. If the HP is superior to 0, though, we return early, as we don't want to trigger the explode event, which will take care of destroying the boss. All right, and let's import that also. Import make blink. And that's it. Yep, that's the whole logic. So now in our room1.js, so in room1.js, if I go to the positions here, and then here I'm just going to add a continue. So the reason I'm adding a continue here is that if for this position we enter here, there's no point in running the other if statement that comes next. So because we already know that it's a drone here for this iteration, so we need to go to the next iteration to have to check for the other entities. So if the position here, name, and then here I think it was boss. Yeah, if we have a boss, and of course we only spawn the boss if the state dot current dot is I think is boss defeated is false. So only if the boss is not defeated that we will spawn the boss. And here const boss, we add it as a child of the map, and then we call the make boss. Now that we have the make boss, we just put here k.vector2 for the position. Whoops. I can't seem to write it well. And then position x, position y, and here. And then finally we call boss set behavior, which is going to set the AI for the boss, and boss set events, because it's going to set the various events for it. And that's it. And also for the cartridge. So the cartridge are basically health. But before doing that, let's just test it out. So if I look, I refresh, state is not defined. Okay, where is that issue from? State not Kaboom, room 1. Okay, we forgot to import the state. So here, let's import it here. Import state. Here we go. Now, if I refresh, press enter. Okay, okay, I forgot vector 2. Room 1, line 64. Line 64. Yep, I made a stupid mistake here. A typo. And then if I press enter, what I mean state is not defined. We're in enemy boss. Forgot to import the state here as well. So import state. Hopefully now it works. Press enter, and yep. So now let's play through the game. All right. Let's see if we can fight the boss. Player is not defined. Come on. Player is not defined. Enemy boss line 35. Okay, line 35 for the enemy boss. Where's that? Player to position. Okay, I guess I should have const player equal k dot get player recursive true, and then here we go. And then now if I play the game, normally everything should work all right. And then here we go. Yeah, the boss seems to work. Does he follow me? Yep. State prop enums is not defined. So this is probably again in the enemy boss. State props enum. Here we go. So if I fight the boss again, here we go, and then I move forward. Here we go. All right, you unlocked a new ability. You can now double jump. And now I can indeed double jump. So, okay, so the game works all right. Now what we need is two things. We need the health bar and we need to do the health bar, and then after that we'll add the cartridge, and then after that the only thing left is really the rooms, the second room. So for room 1, actually no, for the UI, I'm going to create a new file. I'm going to call it healthbar.js. I think it would be better to just tackle the cartridge. So for the cartridge, what I'm going to do, cartridge are basically health packs, and we can just go to room1.js and then add a simple if statement here again. It's a single line. If the position type is equal to cartridge. Actually, we're gonna need to create a new entity for that. Map, add, and then we're gonna add the cartridge here. So in entities, create a new file, call it health cartridge.js, and then here in health cartridge, we're gonna have a simple component here. Let me just explain. So make cartridge the constructor, okay, and then the position, and then the position is just set here. And then we use the sprite cartridge with the default animation, and then we set the on collide with the player, and then every time the player collides with the cartridge, we play the health sound with the volume of 0.5 because the original sound was too loud. And then if the player HP is inferior to the max player HP, we allow a heal. Otherwise, we do nothing. We don't heal. And either way, we destroy the cartridge. So if I go to room 1, now call make cartridge, pass in k.vector2, and then position x, position y, and then that should be it. So if I go and test this out, we have our cartridge here. Let's try colliding with one, and you hear the sound. So there is not much. Let me just test something. So there isn't much to do here to test without the health bar. So the health bar is really key now. So I'm going to go back to healthbar.js, which we created here in the UI component. And then health bar is basically simple as well, and not a lot of line of codes. So I'm just going to copy and explain everything. So we have this constructor, which is makes this health bar component, uses this health bar sprite, sets the frame to 0 because we have 3 frames. We don't have any animations for this one. As if you remember earlier on in Kaboom loader, what we had here in the sprite atlas was the health bar with a slice y of 3. That means that we have 3 frames. So in Kaboom.js, you can just display a specific frame by using the frame property. So that's what I did here, the frame 0. And then here I scaled it 4 times because this we actually scale the camera, I think 4 or 2 times. But for the UI to look good here, we need to scale the sprite 4 times. And here the HP mapping just tells you that for any amount of health, so one amount of health, we need to display the frame 2. For 2 health point, we need to display frame 1, and for 3 health point, we need to display frame 0. The reason this makes sense is simply that if you go to the UI.png, you can see that this is going to this is going to be frame 0, frame 1, and frame 2. So when we have full health, we have actually the frame 0. And yeah, frame 1 is when we have 2 health point, and frame 2 is when we have 1 HP left. And then here, that's why I created this mapping, so we can easily set it here. So then I called the set events event listener. I created the set events method, sorry, which is where we define this custom update method. Event, sorry. And then what it does, it takes the current HP, and then if the current HP is equal to 0, we destroy the health bar because we're gonna just recreate it. And regardless, we set the frame, the current frame to be used to being the current HP mapping. So here we go. So this makes a bit less sense because you could maybe just go here. If you're gonna destroy the health bar, might as well not do that. So it becomes pointless to set the frames afterward. And then we're just gonna create one health bar here that we use here. So instead of creating that in our various rooms, we just create one here and we import it where we need it. So let's add this to room1.js. So we're gonna add it at the end of our file here, actually outside of the for loop. Health bar, and then we set the event, which is just one. We call the trigger, we actually trigger the update event once. Health bar dot trigger the update. And then of course remember that we need to actually add the health bar to the scene because we have only used it with make, so we haven't added it anywhere in the canvas yet. All right, so now that we have that, if you remember earlier on, I had two to-dos. So to do. No, not that one. Health bar. Come on, I had a comment to do. Did I forget about this? Seriously? Okay, never mind. Never mind. So I think it was in the player logic in the events for it. Yeah, okay, so it was here, health bar. So here we're just gonna call the health bar and then trigger an update. We're going to do the same thing here as well. So now if I look at the result, press enter, we have our health bar. Let's take some damage just to test things out. And then you can see our life is reduced. And then when I get healed, damaged again. And then let's get damaged again. And then let's let this droid kill us. Here we go. And then we respawn. All right. Sounds good to me. And yep, so the game is basically done, except now we need to have the other room. So yep, let's work on that. All right, so one quick thing we're gonna do before proceeding on to writing the logic for the other room is we're just gonna write some logic that when the player falls here, so after a certain Y position, they respawn. To do something like that, we're gonna fill this function that I left as a to-do. So the way we're going to go about it is the following. So if respawn, if out of bounds. So here I'm going to create a onUpdate loop. This onUpdate loop, what it's going to do is it's going to check every frame if the position of the player. So here I'm in player.js in this method that we wrote but didn't write the body of previously. And then here, so if this is the player, the position Y is superior to the bound value, which is going to be the maximum Y position we want to allow, then yeah, superior. So remember, in a canvas, in game dev usually, the farther you go down, the higher the value of Y. That's why we have this statement here. So now what I do is that if the player exceeds this bound value, we can just go to the destination name, which is going to be the room you want to go to, that we're going to define later. And then we're going to pass the previous scene data as the other. By the way, the go function in Kaboom.js allows you to switch to another scene, but it can also take, in addition to the name of the scene you want to go to, you can pass some data. And here the data we're going to pass is going to be the exit name. So here in our what is exit name is going to refer to the exits of the that we had on our map. So here the exit layer in tiled, you have exit 1 and exit 2. So the way we're going to go about this is we're going to use this previous scene data to tell Kaboom when to spawn, where to spawn in the other room. In this particular case though, what we do is that we're not going to add anything. We're going to make the exit name null because we want to just respawn in the current scene. So here it doesn't make much sense for now, but bear with me. So here it's time now to use the respawn if out of bounds, and we're gonna call this inside of the room1.js. In this file, I'm just gonna have the player here, player respawn if out of bounds. All right, so we have this respawn if out of bounds. So what we're gonna do now is we need to actually pass in the params. So I'm just gonna pull the player.js file for reference because I need to find it just to know what to do. So the bound value, I think the bound value I did in my original was 1000. So 1000 will be the maximum y value we want to allow. Otherwise, we would spawn into room 1. So what we want to do here is to set the respawn if out of bounds value, the bound value to 1000. This is what looked good. And then immediately go to room 1 if we go out of bounds. So let's try it out. So if I go here, okay, it's not a function. Why is that? So here, respawn if out of, I made a mistake here in player.js, of bounds. Now everything should work, so let's try it out. Now if I drop off, I should respawn. All right, everything is working nice. So now we have finished every gameplay features, and now what is left is just to make the scene transition to the other room and repeat some of the logic for the next room, so room 2. So to be able to pass data between the scenes, as I have shown initially by using this second param to the go function, we can actually receive that data. We haven't written the logic for it. So if I go back to main.js, you can see that we just pass the room 1 data here, but the room 1 data, we can receive it here. So if I go to main.js, I can create a param here called previous scene data, and then I can just decide to pass this as a third param to this room 1, and I'm gonna have to, of course, create a new param here for the room 1 function in our room1.js file. So this can be passed by the go function. By default, we want to make sure that this is null. So you have to specify this by default. We could have decided that here by default, if it's not, never mind, you have to. So by calling k.go room1 to go to the room and specifying an object as a second param, it's going to be our previous scene data. So this refers to this. All right. Now you can see that for our case here, we haven't had anything here. So let's set the data we want to pass as exit name null. We're just coming from the menu, so there's no previous exit we're coming from. But this is going to be useful for room 2. So here I'm just going to pass the exact same data, but just instead of room 1, it's going to be room 2, and then previous scene data here as well. And now we need to actually write the code in room 2.js, which is pretty empty for now. We're going to have to do basically the same thing. So set the background color with the color I specified previously, which was hashtag A2AED5. Remember to add the .js to the import statement. Make sure to cam scale 4 times, like we did in room 1. Make sure to add to set the initial camera position to 170 by 100, like the initial camera position we did for the room 1, and then set the gravity as well to being 1000, like we did with the first scene, the room 1 scene. Then we're gonna get the room. I'm gonna store the room layers inside of room data dot layers. Actually, we're gonna store the layers inside of the constant room layers. Sorry. And then we're gonna do the same thing we did. So create a map game object, add it to this scene, and then set the position to being 0, 0 as a reference, or just you can easily modify it later on, and then set the sprite to being k.sprite, and then room 2. Remember, we have this loaded from the Kaboom loader.js file, and that's basically it. So now if I okay, yeah, so that's basically it. Now we can do I'm just gonna copy and paste the exact same logic we had here. So I'm gonna take room 1 and then copy all of these, and then all of these as well, and even the player as well. So really everything comes except for the there aren't any mobs. There are cartridges, so we're just gonna modify a few things. So let's copy all of that, and then go here, and then paste it right below. Now, of course, there's a bunch of import statements that are missing, so we're gonna have to figure this out. I'm also going to remove the drone here because there are no drones in this room, and also the boss. So what is left is the cartridge and the player. And then here we're gonna have to import everything. So let's import the player, the make player, function. Let's import the make cartridge function. We also need to import the state. Do we use the state here? I'm not sure. No, we don't. We actually need the health bar as well. So let's import that as well. Health bar. And then, okay, we have the health bar. We have everything. And then the various set camera zone, map colliders, etc. So here again, I'm just gonna go here to the room1.js and copy and paste this from room utils. So take this import statement, paste it here, and then save. And then I think we should have everything we need. Let's try it out. So what I'm gonna do now is I'm gonna actually have to set the exit zones now. So one thing that we didn't write in the room utils is a function to handle when you exit a given room, etc., etc. So right below set maybe at the end of the file, I'm gonna go to room utils and then create a new function, export function, and then this function you're gonna call it, as I said, set exit zones, and then it takes the context, the map game object, the exits, and the destination name. I'm gonna call it this way, this param. All right, so here so where does this exits come from? So here in our room 2, there's another layer we're gonna look for is the exit. So I'm gonna add right above here if the layer name equal exits. By the way, we need to also add this in the room 1 logic because there are exits as well. So let me just verify here. So we have the exits layer. So now we're gonna push, we're gonna create a new array. So you could also like make this more modular. So all this part that we copied and pasted from room 1, you could have a single source of truth. So a big function that does all of this. I didn't do it for this project because it's a relatively small scope, and in case you want to push this further, I recommend that you start modularizing and abstracting things from here. So here we're going to have the exits array that I'm going to create. And then in the exits array, here, I'm going to push exit.push dot layer dot objects, just to not have an error later. And of course continue, because otherwise there's no point in running the last if statement if we arrive to this condition. So you could have decided also to have this as a switch case statement in hindsight. So feel free to refactor. So I'm just going to copy that part in room 1 as well. And now we can go back to room utils and then go back to the set exit zones. So for set exit zones, we're going to iterate through the exits. So exit const exit of exits. And then we're going to create the exit zone game object, which is a child of the map game object. We're going to set the position to be exit X, exit Y, because they offer the position. So yeah, so we have the positional data inside of this exit constant. And then we're going to have, yeah, now I'm just going to copy and paste because it's roughly the same thing you've been used to with the other ones. So the area is specific, we ignore collisions with colliders, and then we pass in the exit name. This is important because this tag is unique to the exit name. So here, for exit 1, this is going to be the tag. For exit 2, this is going to be the tag. And then for here, room 2, the exit 1 here, exit 2, and then final exit as well. Okay, so now that we have that, right below, we can set a collider on collide event listener. So if the exit zone on collide, so collides with the player, we're going to have the following. So we're going to use an async function here. And I'm just going to copy and paste the code just to go a bit faster. And then I'll explain it every line. So what do we do here? So we set the background. So this to have a nice transition. So we create a rectangle that takes the whole screen that will move via a tween. And then if the exit name is the final exit, we go to the final exit scene. We haven't created that scene yet. So just copy and paste that for now. Otherwise, we go to the destination name, which is either room 1 or room 2, depending on where you're coming from. And we pass in this object to that next scene, which is going to tell us the exit name we're coming from. That way we can know where to spawn the player, either in entrance 1 or 2. So we're going to have to add some logic to room 1 and room 2.js to control the spawning of the player. So now that this is done, we are ready to use it. So in room, let's add it to room 1 and then to room 2 as well. So for room 1, I have added it here. So let's do it last, or yeah, we can do it last. It doesn't matter. Okay, let's do it right after here. So right after the camera control. So set exit zones, and then pass in K, the map, the exits, and then the destination name is room 2. In room 1, we need to take this same logic in room 2, but instead of room 1, instead of room 2 here, it's room 1. And now here in room 1, let's go here. So for the player position, actually it's going to be a bit more complex than only one if statement. So if I go back to the player, the room 1 logic, so we're here, we're gonna have two other if statements. So if the previous, so for the first one, we're gonna add the condition that if the previous scene data was null, didn't exist, actually we need to do if the exit name is null. So we would spawn the player in the original initial position. Otherwise, if the position dot name is entrance, so yeah, so we had a pin. If I go here, if I go to the positions layer in room 1, so I'm just gonna make it visible. We have this entrance 1 and entrance 2 pins. This is where we determine where to spawn the player if they're coming back from a scene. So for this if statement, if the pin was entrance 1, so the position was entrance 1, and we had a previous scene data exit name passed through this to arrive to room 1, and it's exit 1, then we would place the player into the position of that pin, and then continue on, and then set the camera position to be the one of the new player position, because otherwise the camera would still be up there in the level. And then finally, exactly the same logic. So here again, I was at the end of the project, so I just wanted to get it done as quickly as possible. So there's a bunch of repetition, but at least with repeating code that is simple like that, it's easy to abstract it when you need it into a more reusable version. So here is the same logic. All right, now we do the exact same thing in room 2. So for room 2, I'm just gonna copy and paste the logic, but this time around, we only access room 2 from either of those two exits that you saw initially. So we don't need this default if. There's no default spawn point for room 2. So it's either entrance 1 or entrance 2. If you look in tiled, room 2, you can see the player can either spawn here or there, or there. There is no two options, sorry. So here the same logic. This time around, we set the position as the, never mind. So why is this the case? Map position.x. I don't think we actually need that. So if I go back to room 1, I just set the position normally. Since we have the player as still a child of the map, we can remove this. This was an error on my part because the position is already relative to the map anyway. So let me just remove that. Hope it will work. And here we go. So hope I was clear. If there is anything unclear, feel free to comment in the comment section. Ask your questions there so I can see them. All right, I think we're basically done. Let's try it out. So there's an error already. So set background color, room 2, probably missed an import statement. Set background color. What's the issue? A redeclaration of import set background color previously declared at line 1. Okay, right. So it was redeclared at line 3 or 6. Ah, okay, I see. I copied it twice, so I'm just gonna remove the first one. Now if I press enter, exit is not defined. Okay, line 40 of room 1. So line 40, it's not exits. I thought this layer existed. Let me look it up. Exits, yes, this layer exists. Did I mess something up? Layer name. Exits.push. Ah, I forgot to create the original, the array for holding all the exits. So let's do the same in room 2 because we're gonna have the, okay, we did it for room 2, did not do it for room 1. That's why. So if I press enter, and then we have our game. Okay, now let's test it out. So I'm gonna just go to the left, and we have previous scene data is not defined. Okay, where's this error from? Main.js. Okay, main.js, previous scene data. Okay, we need to pass this here. So now it should work. Let's test it out. Pressing enter. Here we go. Now let's go here. And then K is not defined. Okay. So what's the error now? K is not defined in room 2, line 12. Room 2, line 12. So room 2, line 12. Okay, we didn't pass in the K here, and we didn't pass in the room 2 data as well, and we didn't pass the room data as well, and we didn't pass in the previous scene data. So forgot to add all of these params that we did for room 1. Now it should work, hopefully. So I'm gonna make this full screen. Set exit zone is not defined. Again, forgot this in room 2. Let's add it to set exit zones here. Did we add it for here as well? Okay, for room 1 and room 2 we have them. So now let's test it out again. And now it should hopefully work. And it does. And then if I exit back in, we're back at the correct position. So now I'm just going to go to the other one. So actually I have to beat the boss first to unlock the double jump ability. Okay, let me just hit the... Let me just beat it and then we'll... Alright, now we should have the double jump unlocked. And now I can go to the other side here. And we spawn in the correct place. And now here, it's normal if it bugs here because the scene doesn't exist. Or did we actually create that scene? Yeah, final exit, we didn't create it. So the game is mostly done now. The only thing left is really to create those last scenes. So the intro scene with a message that tells you like how to play, and the final exit scene. So we're gonna do this in main.js. For the final scene, I'm just gonna create it here, right below the intro scene, and then I'm just gonna make a call to the notification box with this message. I'm gonna do the same thing for the intro scene, and the project is done. So here I'm gonna import make notification box, and then for the intro scene I'm just gonna add the following as well. So right below here. And then one thing I also want to add is, I'm not sure if it does anything, but the audio on the web page, unless you do a gesture, the audio will not activate. So if the first sound of your game is the sound effect from getting hit, and before that there were no sounds played, then it's going to have a lag between the time the sounds actually play and what happens on the screen for the first sound that is heard on a web page. So I thought this would fix the issue, but I'm not sure if it does anything. So I'm gonna keep it here. So it's about creating a new audio context, but I'm not sure if that it works because we should actually resume the already existing audio context, but I'm not sure how to get access to that. So this is something with Kaboom. I don't know if there is a fix, except that you start immediately playing some background sound when or in the menu playing some sounds. That way you wouldn't have this issue. All right, let's test it out. And okay, set background color is not defined. Import set background color. All right, the game should be done. Let's play it. So escape the factory, use the arrow keys to move, X to jump, and Z to attack. And then press start. So let's play. Let's see if everything works all right. So I hit the enemy. All right. I took some damage. Can I go to the left? Yep. By the way, this is intentional that the enemies respawn when you go to another room. That's a bit like in Souls games. The enemies respawn like that. But so I'm just gonna beat the boss, and once the boss is beaten, okay, I have unlocked the ability. By the way, you can make the boss more complex. I made it simple on purpose so it's easy for me to play test. So now I'm just gonna complete the game. So here go here, and then I took some damage, and then I go to the left side, and then I jump here, and I jump here. And by the way, I'm just gonna drop off here to test that the respawn logic works. Yep. And I'm just going to also go back here to make sure that the logic works. All right, it does. And then I'm just gonna finish the game. You escaped the factory. The end. Thanks for playing. And that's it. That's the game. Hope you enjoyed this tutorial. And by the way, if you want, you can subscribe to the channel so that you don't miss out on future tutorials. I don't upload that often, so it would be a good idea. But yeah, so I hope you enjoyed the tutorial, and you can go on my channel, see other game dev, JavaScript related tutorials. Thanks for watching. Bye. One last thing, if you ever want to upload this game online, what you do is you just zip the whole code base and then drag and drop it on itch.io, and it should be able to deploy. That was one thing I forgot to tell you. So same thing for GitHub pages. You just activate GitHub pages on the repo for this project and it should be up and running. So that's the advantage of not using a bundler or NPM, is that the deployment is very easy. All right, thanks for watching again. Bye. Hi everyone, welcome to this new tutorial. Today I'll teach you how to make a desktop game in JavaScript. So JavaScript is usually used for the web, but with a technology called Tauri, we're going to be able to make a game that is installable on your PC. So we're going to use Tauri and the Kaplay library. If you don't have any experience with both of them, I'm going to explain everything. So this tutorial is really for you. In the sense, the only prerequisites you need is a good fundamental understanding of JavaScript. Now, let's get started. So the game we're going to build here is a Flappy Bird style game. So you jump here, and then when you hit the obstacle, you have your previous best score that is always written to disk. So you have the concept of a save file. And this is something I wanted to teach you because this is one of the main draw of having a desktop game in JavaScript, is so that you can save your games. So usually JavaScript is used for the web, and in the web, you have local storage, but it isn't a very safe way to store data, because as soon as the player clears their browser cache, it's going to wipe out the save. So this is one of the main draw of having your game as a desktop game if it grows above a certain size and you need to keep track of save data. So let's jump right into it. So in this game, one thing I forgot to mention is that we're going to have multiple inputs. It's going to be a very simple game because I want to focus on the actual Tauri concepts and the Kaplay concept. So Kaplay is the library for making games that is very easy. It was called Kaboom.js previously. If you want to know why the rebrand, you can watch the previous video. By the way, I made a lot of tutorials on Kaboom.js and how Kaplay basically now, how to make games with it. So if you're interested, feel free to watch those as well. They are still relevant because the difference between Kaplay and Kaboom is just the name for now. All right, so here we're going to implement keyboard controls. So just by pressing the space button, you can jump. We're going to also implement mouse control. So by clicking, you can jump, but also gamepad control. By pressing the south button, you're going to be able to jump. So this might sound strange. What is this south button? So look at this little schematic. Imagine this is a controller. The south button is the action button that is always at the south here. So it's a way that Kaplay uses those terms so that it can be independent from the actual type of controller. So an Xbox controller versus a PlayStation controller have different symbols on them. But at the end of the day, the X button is here for the PlayStation, and the for the Xbox, I don't remember actually. Here, is it A or B that is down there? But by just using the south name, we can just have our game be agnostic regarding this. So let's start the project. So there are some prerequisites that you need to have. So in terms of following this tutorial, you only need to know JavaScript, the basics. But as for the installation process, and also, by the way, I'm going to do this mostly on Windows. So the reason I'm doing this on Windows is because this is the machine I have. And also, the expectation for games is usually that they run on Windows. So if you're going to publish a game on Steam, it's really not worth your time to support Linux and macOS usually. Now, maybe with Proton, with the Steam Deck, it's changing a bit, but yeah. So you need to follow this this page. So it's going to be linked in the description. It's the prerequisites. So you need to set up this on Windows. By the way, you can still follow this tutorial on macOS or Linux. There are some instructions, but at the end of the day, the executable you're going to get is not going to be the one for Windows. So here we're going to set up Windows. No, here I have the link in the description. Follow the instruction here. You have a few things to install. So one thing I want to mention is the WebView 2 thing. So Tauri, compared to Electron, which is another solution technology for basically making desktop apps using JavaScript, HTML, and CSS, is that with Electron, it packages a whole Chrome browser for each version of your app. So if it's on Linux or macOS, etc., it's always going to package a fixed version of Chrome. And the advantage of that is that your app is going to be rendered the exact same way, regardless of the platform. However, the drawback of this is that it's going to make your app bloated. So because Electron has to package a whole Chrome browser, that means an executable that does basically nothing. So a project, empty project, is going to be, I think, 100 megabytes. Now with Tauri, the actual end game, like the full game that I've shown you earlier, is only 6 megabytes. So you can see that it's really not bloated. And the way Tauri achieves this is by using the system's web view. So for each operating system, they have a web view that Tauri uses. But the issue with that is that you cannot really make sure that the app is going to be rendered the same way on all platforms because, different browser engines have different particularities. It's mostly the same, but it's not exactly the same. The reason I'm going to use Tauri for this tutorial is because it was very easier to set up than Electron, less bloated since on Windows and also on other platforms. But the most important aspect that basically determined that I wanted to use Tauri instead of Electron is the fact that I really am targeting Windows only for this project. So I don't really care or feel any of the drawback of the fact that it's not exactly the same browser engine on the various other platforms because I'm not publishing to other platforms. All right, so once you follow this, you install. And by the way, another drawback, perceived drawback, is that it needs to have this WebView 2 runtime installed on the user's machine that is going to use the app. But now it should be available on all Windows 11 operating systems, distributions, but not on Windows 10 or Windows 7, I think. And then the reason for that is, well, it's not available by default. And if you were to just distribute a .exe made with Tauri, then this would be an issue because you would have to make sure that the user has the WebView 2 installed on their machine. Now, this is not an issue in the end because we're going to distribute the installer, the MSI. And this installer that we get after building the project is going to install this WebView 2 runtime on the user's machine if it's not already available. So you don't have to worry about anything. And yeah, you need to install Rust, even though in this tutorial we're not going to use it really. We're just going to, well, we're going to write some commands, but we're not going to write Rust, basically. It's just the project itself is built with Rust because there's a JavaScript API that can use to read and write to a file, which makes it very beginner friendly, I guess. All right, so follow this, and once you have followed the prerequisites for your platform, let's jump right into the project. All right, so how do we start a project? So also you have to have Node.js installed. This should have been mentioned in the prerequisites link that I've shown you earlier on. So you need to run npm create tauri-app at latest dot here if we're in a folder. So I'm using VS Code as my editor. I have created this Creeby folder because Creeby is the name I've chosen for this project. And then once I'm in this project, I can use the dot notation here so that it's going to create the project files within the current folder I'm in. If you were to omit this, it would create a different folder for you. So run this command. And then maybe I should increase the font size already, just to make sure that everything is visible. And then the package name. You have to specify your package name. I'm going to call it Creeby tutorial. Actually, just Creeby. I'm going to use TypeScript and JavaScript. This project uses JavaScript, but you need to use like which one for your front end you want, and then NPM. And then here, do not select the vanilla UI template, because the vanilla UI template is just going to be a buildless HTML, CSS, and JavaScript. So we still need to use a build system because it's more convenient to install and use the Tauri API that way. So I'm going to take the React template, but I'm going to remove everything that is related to React for this project. And then choose JavaScript here. All right, so we have everything we need. Now I'm going to open up the package.json, and you can see that we have a couple of dependencies we're going to need to remove. So we're going to need to remove React and React DOM because we're not going to use them. So I'm going to type in npm uninstall React and then React DOM. All right, the package have been uninstalled. And then I'm going to also uninstall this VJS plugin React. We don't need that as well. So I forgot to do that. So let's do it. Here we go. npm uninstall. Here we go. And then that's it. And now we can install the Kaplay library. So Kaplay can be installed in many different ways. It can be installed using a script tag, much like I did with Kaboom.js. But for this project, since we're using Vite inside of it, we're just going to use npm. npm install Kaplay, and I'm going to install a specific version. This is, I'm making sure to pin the version here so that if you're watching this in the future, it's going to always work. This tutorial at least. So it's self-contained. So 3000, that's the version 0.1.17. If you're not familiar with Kaplay and Kaboom, it works in thousands. So version 1.0 is actually version 1000, version 2.0 is 2000, version 3.0 is 3000. This is the naming convention that I used. It's strange, but I don't know the reason why, but yeah, that's it. It is what it is. So I'm going to hit npm install Kaplay with this version. Now we have Kaplay installed. Let me check in the package.json, and here we go. Okay, so before we do anything, I'm just going to collapse this. I'm going to collapse this as well. And I'm going to go to here. So here, to run Tauri, you have this Tauri command. Just to make things convenient for us, we're going to rename those commands. So we're going to have dev dot browser and dot browser here to differentiate from the two other commands I'm going to write here. So I'm just going to do preview. This is just a name I have decided for myself. But here, instead of having Tauri here, we're just going to have, when I run npm run dev, I want to run Tauri dev, which is going to actually start the application. And the reason we're doing this is because we have two systems going on. We have Vite, which is a bundler that bundles your web code and then puts it on a local host that you can use. And then there's Tauri, which takes this output at the same time and puts it in a desktop window. So that's why we have those two commands, even though for this project, we're not going to use Vite directly like that. We're going to use Tauri dev. So the other command is build and Tauri build. So just to check that everything works, but because we are using the React template, I'm going to remove everything that is within here. So let's remove all of those files. I'm going to also remove everything within the within the public folder. All right, delete this. All right, now we have the index.html. We don't really need much here. I'm going to remove this. I'm going to remove the head tag. I'm going to remove the HTML. I'm going to remove even this. It doesn't matter. And then here, instead of JSX, it's going to be JS. And then in the source file, I'm going to create a main.js file. Now in main.js, I'm going to call what we need for Kaplay. So I'm going to import Kaplay from Kaplay. And then, and then here, I'm going to initialize the Kaplay context, which is basically creates the canvas for us. You call the Kaplay function like that, and then pass in a bunch of options. The width of the canvas is going to be 1280 by the height, which is 720. And then here I'm going to use the letterbox options. Those are all options that comes from Kaplay. So here, letterbox true makes our game will scale regardless of the window size while maintaining the aspect ratio. And then here I'm going to put whether or not we want this to be global to be false. So we don't want Kaplay functions to be available globally. We want all Kaplay functions to be callable from the the context. This will make our code cleaner. And then we want to scale the canvas 2 times. This is what looked good. And then this is for everything within the canvas. It's going to become relevant later. So let's do that. Now let's go back to the terminal and run npm run dev. And then here it's going to compile your project. And then you're going to have to wait a bit before it compiles. And usually if you modify things related to Tauri config, I'm going to go over the file here, then the application will have to close and reopen. Otherwise, if you just modify JavaScript content here, code here, it should usually hot reload. I have something messed up. I need to modify something in the Tauri file here. Yep. Here you should run the dev browser and then build browser. And so really the preview command, it doesn't matter. So I'm just going to cancel this out and then everything should work. All right. So if I do this, and then, okay, what's the issue? Cannot find the package VJS plugin React. So here, let's remove everything related to React in the Vite config because we have removed it. So everything should be like that. And now, just so you can see, I removed this and another option called plugin React. So now let's run it. Hopefully it works this time around. Yep. When you see localhost, and then it's compiling, and then downloading the various crates we need. This is only done the first time, I think, and then it's building. Yeah, so it might take some time. It's a bit slow, but this is only like the first time. All right, so it was a bit slow, but it's the only once you do this, and then now it should hopefully open up. And here we go. We have our window with our canvas, and then if you press F12, so let me just increase that a bit. If I press F12, you'll have your console. Ignore this, we just remove the favicon. It doesn't matter since it's a desktop application. And yep, so we're ready to start working on the game. So let's import our assets. So I'm gonna close this. By the way, you can just leave it open like that. So here we go. I'm going to go here, and for the assets, we're gonna put them all in the public folder. All right, so I have imported all the assets. You're gonna find a link in the description or multiple links in the description to get everything here. So I'm gonna go over everyone. So this is the background.png for our game, clouds. We're gonna have a colliders data.json, which basically defines the hitbox for every platform obstacle. So the height and width of that hitbox and where to put it. So the X and Y coordinates. This is better. I thought it would be better than having to pull an external editor like Tiled. If you are interested in how to make like more serious games using an external editor called Tiled, watch the previous tutorial I made on the channel. Here are a few sounds. We have the confirm sound. So when you click on the button, the hurt sound and the jump sound, those are made using a website called gsfxr.org. I think that's the name. It allows you to make 8-bit or 16-bit sounds. And then we have the sprite for Creepy. And then the obstacle layer here. So the obstacles. And then one thing also is the icon. So here you can provide a bunch of different icons, and there's an icon command in Tauri. But for this project, since I only care about Windows, I just imported this icon for my project. So just you'll find this in the description. Just put it in the under the source-Tauri and then icons folder here. All right, so if I look at the project, you can see the icon appears here now. All right, I'm gonna minimize this and we're ready to start working on our project. So let's go back to the source folder and then in main.js. So the first thing I'm going to do is to actually load a bunch of our assets. The way you do that in Kaplay is to call either the load sprite function or the load sound function. There's also the load font function, not font, font, sorry. So load sprite works this way. So you pass in the name of the sprite you want to use. So Kribi, this is going to be the key that we're going to refer to in our code base. And then the second param is the actual param. So the param here is going to be the path to the assets, which is going to be kribi.png -kribi. So the reason it's just a dot dash is because when working with Vite, the public folder will automatically be linked to the root of the project. So you don't have to write public/kribi.png. So that's the first one, and that's basically it for the sprite. So I'm going to copy and paste the rest that you need here. So load sprite obstacles, backgrounds, and clouds, much the same way. For the sounds, it's similar, but the only thing that changes is that you use the load sound method instead. All right, one thing I want to implement right off the bat is to allow the player to go into full screen. So for now, if you press F11, which is usually the keyboard shortcut for going full screen, well, it doesn't work. So to implement this, we're going to have to use the Tauri API. So Tauri allows you to use a JavaScript API instead of Rust if you want to do things that touches the native like Windows system, like the native app system. So writing to a file, changing the full screen, etc. Those are things handled by the game window itself. So you have this file called tauri.conf.json, which handles all the permissions to what you're allowed to do. All right, so you have a bunch of permissions, and the permissions we're going to use here, are going to need to edit, is two things. So here in our tauri.conf.json, go to the Tauri and then allow list property. And then here, we're going to have two things. So we're going to use the fs key for file system and allow us to read the file. So set this to true. To write a file, to write to a file, set also this to true. And the scope. So the scope is here is, let me just put it scope, and then I'll explain it. So, and then add a comma here. So what is this? Later on in the project, we're going to need to write the save data, the save files basically. So this is a score actually. We're going to need to write this to disk so that when the player plays again some other time, we know what their best score is always. And for that, we need to be able to write to a file and read to a file. And here, the way Tauri works is that you need to enable each permissions. Either you enable everything by using the all property, or for each of those APIs, you enable what you need. And usually the best practice is to always enable what you only need. And the scope here is the files, the folder you're going to have access to only. And here, we're going to need to pass in the app local data folder, and by having this notation, so everything in the app data local, the app local data folder is going to be accessible to our Tauri application. So we're going to be able to write to any file write to any file within that folder, or read any file within that folder. And the .star here is for that as well. So here this constant or this name comes from the Tauri documentation. There are various constant like that. And it refers to if you go on Windows and you type in run in the command start, the the Windows, the search bar on Windows to the left, and you type in run, and then here you type in app data, and you have a local, low, and roaming. And if you go to the local folder, this is where maybe you're not seeing it. Maybe I can zoom. Yep, I can see. So in this local folder, you're gonna have a folder that is the name of your application, and in that folder, everything you can read and write within that folder. Let's replace this with creepy.game, and then if you do this, if you refresh, it's going to rebuild it. Here you can see that we have this. If you look at the path, app data local, and then creepy.game was created automatically by the application when it runs for the first time, or when it is installed. So here is everything. We're going to write the save file here. We're going to read it from here, etc. Hope that was clear. So now, yeah, replace the identifier, make sure everything is saved. And the other permission we need, though, is for with the Windows permission. So window permission, and the exact permission we need to be able to set this to full screen is the set full screen permission. And I'm going to set this to true. So now if I go back to main.js and I go here down below, we can write the logic we need to make the window go full screen when the F11 key is pressed. So I'm going to add an event listener. So you can do this in two ways. Either you do document or add event listener, or you can just call add event listener directly like that. And then here the key down event we want to listen to. And we need an async here because the API, the Tauri API is asynchronous. So here we're gonna have an EV for the event, or you could call it event if you want. And then here, if the event code equal F11, so that means the key was pressed. So actually here a better name would be the key, and then key.code is F11 key. If this is pressed, we're going to have first an if statement that is going to call this API. So app window, and you can see here, app window, it's going to import it from the Tauri API. So click on that, it should import it at the top of your file. And then here, what will happen is that first you check if it's full screen. So is full screen, you use this. This is from the API. If it turns out to be the case, then we're going to set it back to not being full screen. So the F11 key acts usually as a toggle. So we can use the set full screen function that we allowed the permission for in tauri.conf.json to turn it off, so with false. And then we have another if statement here. Actually, we should return early. So if I have this like that, I put it within brackets and we return early. And then here down below, if that was not the case, that means that the app window is not full screen. So I can just do app window, and of course don't forget to await. Well, actually it's not necessary to await here because we don't do anything afterwards. So set full screen and then set this to true. So here we needed to await so that we don't move on, we don't return before we are sure that we don't return before we are sure that the app was set to full screen. In this case, I don't think it really matters, but here it would matter because otherwise it would return a promise and not the actual value. So yep. Okay, so let's test it out. So I'm going to open the application. It is here. Now I'm going to press F11 and we can see that it is full screen. Now, if I put it back here, it's not anymore. All right, so now let's actually start working on the game. And we're going to create two scenes. So in Kaplay, the way you create a scene is by calling the scene method or function and then giving it a name and then passing as the second param a function that is going to contain the logic for that scene. So we're gonna need two scenes. We're gonna need the first scene called start, which is the menu, and then the second scene, I'm gonna call it main. It's going to be the actual content of the game. And then I'm gonna call the go function, which will go to the start scene when the game starts. So start function, main function, and start scene, main scene, etc. So I'm going to write a new file here. I'm going to call it utils.js. It's just going to contain a few utilities that are going to be used. For now, we're just going to create a function that makes the background a certain color. So I'm going to call it make background. I'm going to pass in the k context, so I don't have to import k everywhere, which is the Kaplay context. And then I'm going to call the add function. So the way Kaplay works is that you create game objects using the add function and passing it an array of components. So the array of components you pass in, which usually are components that are offered by Kaplay, they will then come together to create a game object with specific behaviors and properties. So here I'm going to use the rectangular component from Kaplay. I'm going to call the width method and height method so that this rectangle takes the full height and width of the canvas. I'm going to set the color by using the color component of that rectangle. So I'm going to set the color using the color component for the rectangle. So it's not a color component of the rectangle. It's just a color component offered by Kaboom that allows you to modify the color of a game object. So here I'm going to call the fromHex method, which can be accessed like this and allows us to specify a hexadecimal value. So by default, the color components takes RGB values, which mean 3 params that can vary from 0 to 255, but we want a specific color, and with a hexa, usually in pixel art or in art, you use hexadecimal instead of like RGB to specify colors. So that's what I prefer to use. And then finally, we're going to have a last component from Kaplay again called the fixed component, which will make the which is going to make the background independent from the camera, because the camera is going to follow the player. But by the way, I think this is useless because in a Flappy Bird style game, the player never moves actually. They just jump, and it's the platforms that moves, or the obstacles that moves towards them. So this component is not necessary. So let's use that in our first scene, the start scene. I'm just gonna call it make background and pass in the k here, context that comes from here. Now if I look at the result, you can see that here we have bars here that are just the black bars, and then you have the appropriate color. I prefer my black bars here to be black and not white. So here in the body, I'm just going to have a style tag. We're not going to spend too much time with CSS, just one thing, body, a selector, and then set that to being background color, and then black. So now it will look much nicer. Yeah, I think this is better. So now what comes next is to actually draw the background. So I'm going to create something called a map game object. It's going to act as the parent of all the game objects that are props or obstacles, clouds, etc. They're going to be all children of that singular map game object. So this is a feature that Kaplay allows you to do, is to create game objects, but also to have child game objects and parent game objects. So here we create a parent game object like a usual game object with the add function, and we pass in the following array of components. We can use the sprite component offered by Kaplay, and then you specify the key for the sprite, which was defined earlier on in the load sprite function. So here I'm going to have the background as the sprite I want to use for this game object. I also have access to the positional component, which allows us to set the position of our game object, here 0, 0, because it's the background, we want it to be at the origin. And by the way, in game development, things are drawn from the top left corner, unless you specify the center to be the origin of the sprite or the game object. And then finally, I'm going to actually scale our game here. So here I'm going to create a constants.js file, constants constants.js. I'm going to export const, and I'm going to call it scale factor, because the pixel art is going to be too small. So for things to be visible, I'm going to have to scale things a bit. Now you have two options actually. Either, let's scale it 4 times. Either you make the camera zoom in, or you make the sprites scale. So either one should work. So scale factor is going to be the thing I'm going to use here. Don't forget to import it, or otherwise you're going to have an error. So I'm going to import scale factor from constants. Now, did I get this right? Export, yep, should work. Okay, now let's go back to main. So we should have our game object. It should appear on the screen, and you can see that we have our background. It looks pretty nice. Now we're gonna have to add the clouds, and the way I'm gonna go about this is I'm going to create the clouds as a child game object of the map. So the way I do this is by having a call to map.add. So every game object has also the add function as a method that allows you to create game objects, but this time they are a children of that game object instead of a global game object. And here I'm going to again have a sprite component with the clouds. And when you create a child game object, what happens is that their position is relative to the parent game object, which is pretty handy. Here, however, we are going to need to call the positional components so that we can have access to the position and be able to set it. If you don't do that, you cannot modify the position. So even though I don't need to specify a value here, because I just want to later on modify the cloud so that you move in a certain direction, I still need to call the sprite, the positional component. And now the last one, I think here in Kaboom.js, what's handy and allows you to get away with not using classes, etc., is that each game object can have as part of their array of components an object which you can specify in its properties. So here I'm going to specify the speed property as being 5. So it's going to be the rate at which the clouds are going to move. So here I'm going to store the reference to those clouds here. Because by default, when you create a game object using the add, it always returns that game object. Even as a child of another game object, it will return the child game object. And here we have multiple clouds and not just one under the same image. So that's why it's the clouds game object and not every individual cloud as game object, which is better for performance reasons. So here what I'm going to do is I'm going to use one of the other methods that are available is the onUpdate methods on every game object, which runs this function every frame. So usually 60 frames, 60 times per second. So here I'm going to use the clouds move method, which is also offered by Kaplay on game objects, which allows you to just move a game object along the x and y coordinates at a certain rate. So here I can use the speed I've defined earlier on and access it like this. So the game object name dot the property. And then here it's going to be as the first param. That means it's going to move along the x-axis, positively, so to the right. And then for the y-axis, I don't want to change the speed, so it's going to be 0. And now here right below, what we're going to do is a clever trick. So for now, if I run this, the clouds are moving to the right, and then once they are fully gone to the right, they will never come back. So what I'm going to do is I'm going to use a clever trick, is I'm going to make sure that once the clouds position clouds.pause, you can access the position this way, and that's why I needed to use the pause component. If you didn't use that, you wouldn't be able to access the current position. So if the clouds.position is .x, because it offers you both the x and y value, but we only need the x value, is superior to 700, which is when they leave the frame, the visible area of the canvas. Then we're just gonna set back the position of along the x-axis to be of -500. The reason we do this is they go all the way back to the left immediately. They teleport back to the left, and then they will continue their movement. So basically, we have infinite clouds that go from left to right. So if I go here, now here I'm not gonna wait for this to be done, but you'll notice it while playing the game, the final game, that as the clouds move to the right, and they moved fully to the right so that they are no longer visible, they're gonna appear back from the left because they're teleported back. So now the last thing we need for that scene is to add the obstacle as another game object to the map, and here we're gonna need the sprite obstacles. So the obstacle sprite, and I think that's it. And by the way, because initially we scaled the map game object, the parent game object, everything else, the children are also going to get scaled, by the way. Forgot to mention that. For the last game object, the obstacle game object, we're going to have to specify the position as well by using the position component, but not necessarily passing in a value, because we're going to modify this value later on and read it. And here we're going to use the area component, which is also offered by Kaplay and allows you to specify a hitbox for your game object. Actually, you know what? I think it's not necessary here because the hitbox is going to be dependent on something else. But for this, yeah, here in this case, we don't need it. We don't need it. You're going to see when we're going to need it later on. And that's it. Or maybe, yeah, that's it. I think that's it. So yeah, we don't need anything else. So if I look at the app, you can see. So basically what we're building here in the start is the start menu. Basically, that's it. So we're going to put the Creepy character here and the play button. And then actually in the main is actually where we're going to write the actual logic for jumping, etc. What we're going to do now is create a player.js file, which is where we're going to write the logic for Creepy, the main character, so that we can reuse that in both the start scene, in the menu, and in the actual game, so in the main scene. So I'm going to create a function which is going to act as the constructor. It's going to be called makePlayer, and it's going to take in the context. And then here we can use the make method from Kaplay, which what it does is like the add function, but the only difference between make and add is that make creates the game object but does not display it on screen. Later on, we're gonna add, if you make an add call to a make to the result of that, it's going to actually create it. So for now, we're just focusing, sorry, with creating the game object itself. So here I'm gonna use the sprite component with Creepy, so that this is what is displayed. Here we're going to have an area component, which defines a hitbox, and you can pass in an object with the shape property to specify a specific hitbox shape. We're going to have a rectangle. You can create a rectangle by using the k.rect with a capital letter in Kaplay. And the first param is the y and x position relative to the game object itself, and you can have this as a vector2. Vector2 is just going to be in x and y coordinates as a single data structure. So here we're going to have 0 for the first param and then 1.5. So that means the hitbox is going to be placed at the position 0 and 1.5 relative to the game object. And then the second and third param of the rect method or function is just going to be the width and the height of that rectangle. So here the width and height is going to be 8 by 5. So Creepy, the character itself, is 16 by 16, but by having this hitbox being 8 by 5, it's going to be more generous since it's a hard game, and it will reduce the amount of rage that the player will experience. And then by default, I said earlier on that in Kaplay or in game dev in general, things are drawn from the top left corner. But in this case, it would be better for things to be, so the player game object to be drawn from the center. And you can specify this by using the anchor component offered by Kaplay and passing in center here as the string. To use this, you need to have the area component defined, otherwise you're going to get an error. And then finally, going to scale the character as well, this game object, like we did with the other one. And this is where we can use our constant again here. And then finally, we're going to have an object here, which is going to contain properties and methods that are useful for the player. So here, I'm going to have first an isDead Boolean, initially false, which we're going to use here to know when to display the scoreboard and when to restart the game. And then the speed is going to be 600, which is the value that felt nice. I'm going to have a key controllers array here, which is going to hold event listeners to the various input controls we're going to define. And the reason we're doing this is because when the player dies, we want to cancel all those controllers. And by having them in an array and then iterating through them, we can disable the player controls so that the player can no longer move once they die. All right, so now let's create our first method, which is going to be the setControls method here. This is arbitrary, and by the way, if you're not familiar with this notation, it's equivalent to having this like that, which you might be more familiar with. So this method, I'm going to call it setControls. Its goal, as its name suggests, is to set the controls. This is not from Kaplay. This is just a name I've decided to call this function. I'm going to call it later on. So here, I'm going to store the jump logic that I'm going to write into a simple small function. So because it's a small function, by convention, I'm going to use the convention that if it's a reusable piece of logic that you're not going to use elsewhere, I'm just going to use this notation for the function, and otherwise I use the function keyword. This is a personal preference, and you can feel free to do what you want. And here we're going to play the sound. So here in main.js, we imported the sounds for the various situations. So when your player jumps or gets hurt, and here when we set the control, when the player jumps, we want to play the jump sound, which we can use the key here of. If you remember main.js, the jump sound is here. And yeah, to play a sound, you call the play method from the Kaplay context. And then here I'm going to use this.jump, and this might be confusing. Where does this and jump comes from, and why a comma here? So that's a mistake on my part. So this can be used to refer to the whole game object. So when you create methods within this object here, you have access to the actual all of the game object, which is pretty handy. That means that this refers to the game object itself. Now jump here is offered by Kaplay. It allows you to automatically implement jumping, and I realized that I forgot to add the body component. So this jump method comes from the fact that we used the the body component, which we didn't. So now it's time to add it. So the body component allows us to make our game object susceptible to gravity, and also allows us to have the jump method, so which implements jumping automatically for us. You can modify various properties either within here, the jump, or within the body component itself. Here I'm going to set the jump force to being 600, and there's the mass that you can modify, etc. By the way, go to the kaplayjs.com. Go to kaplayjs.com, which is where you're going to find the documentation for Kaplay. So we have jump force, everything is fine, and then let's actually implement our jumping. So here I'm going to use this.key controllers, and I'm going to push to it the various event listeners we're going to create. So here we have access to the following. So this on key press. Well, actually, you can use a global k on key press, and I don't remember why I did this way, but I think it's more performant to. Actually, I don't see any reason to use this here. So use k here, and then on key press, which is offered by Kaplay. You can have an example here. you pass as the first param the key you want to use, and the second param is the function that is going to run when this is pressed. There is another way of doing it where you only have one param, and you have the key param here. It's going to give you every key, which is a more handy way and better way to do it. But because in this project we only have one input, really, then this way is fine. Watch my previous adventure platformer tutorial to know how to use more advanced feature of Kaplay. It was called Kaboom then, but everything is applicable. The same knowledge basically. So here, space, and then we're gonna call the jump logic. So we're gonna pass the function here. So this is going to result in an event listener controller, and this controller is when the space key runs, it fires off the jump logic function. Now, as I said in the beginning of the tutorial, we will have more than one input method. The other one is the click. So this key controllers push. Maybe key controller is not the right word here. Maybe I should call it input controller. Input controllers would be a better name, because it's not only for keys in the keyboard. So here we can use the onClick method from Kaplay, and you can just pass in the jump logic here. It's gonna fire the function you pass in when the player clicks. And then finally, we're gonna push the one for the gamepad. So for gamepad, you have Kaplay offers you the on gamepad button press, and then you specify the south, as I've explained earlier on. South comes from the fact that if you look at the controller, this button is to the south, basically. And now here, the second param is the actual logic. So jump logic, that is going to fire off. All right, now we're almost done. I'm going to collapse the set controls here. I'm going to call the disable controls, which is going to be called, not dispatch events, disable controls, which is a method I created. I decided to create those function. It's not from Kaplay. Just making sure that you understand that. Here, disable controls, what it's going to do is just going to iterate through the key controllers. Actually, now it's called input controllers, and then for each, you could use a more performant for loop, but it's only 3 elements, so it's not that useful. So key controllers, and then arrow, and then key controller. For each key controller, we're gonna call the cancel method, which is available on each of those controls. So if you look at the documentation, I click on there's no IntelliSense, it seems. Anyway, these calls return in event controller. All right, so now in main.js, I'm going to, right below here, let's add the player. So const player, and then we're gonna call the add function, and within we're gonna call the make player function that we defined earlier on, that now should be imported from the .player.js file here. So now what I'm going to do here is first pass in the K here, the context, so that we can have access to the various Kaboom methods. And then in here, you can modify the position like this and as a vector2 like that. So you can use the vector2 method to create a vector2 on the fly. And then here, we're going to put it at the following coordinates. So I'm going to copy and paste this because it's not really that relevant. I'm just going to explain one thing here. So here, k.center gives you the center position, and you have access to the x and y coordinates of it. And here we just make our Kribi character relative to the center position by a few given offsets here. This is what looked good. So if I look at the result, it's here. Wait a minute. So something went wrong. I'm just going to do F12. And here I have the, let's go to the console, and then the body require, okay, we didn't use the positional component, so I forgot to add this to our definition of the player. So now if I run this again, you can see that the query character is here, which is what we want actually, by the way. And now the last thing we have for this start menu scene is the start button, and when it is clicked, or when the player presses enter, or when the player presses the south button on the gamepad, we should start the game. So here in main.js, we're gonna have to create a play button. So here we're gonna do it the same way. So I'm gonna create a constant called play button. I'm going to create a game object out of it. And here there's no new concept, so I'm going to copy and paste the code. Feel free to pause. There's one new concept, is the radius. So when creating a rectangle, by the way, this is the rectangle component, creates a visible rectangle. Do not confuse this with the hitbox k.rect. This is not a component. This is just creating a rectangle hitbox. So there's a difference between the two. So when you want to create a rectangle that is visible, you use the rect component from Kaplay. When you want to create a rectangular hitbox in the shape, you use the k.rect here. All right. So a radius of 3, so it's well rounded. And then here we're gonna add a child to the play button. So right below here. And it's going to use a new component that you're not familiar with if you haven't used Kaplay before. It's the text component. It takes as the first param the text you actually want to display, and the second param can take the size, the font, etc. Here we just want the size. So the size is going to be 24 with this given color. So it's a darkish color, which follows the palette I used for the assets. All right, so now everything should be here. Should be fine. Let's look at the result. We have the play button, but if we click, nothing happens. If we press space, nothing happens. So here, I'm going to use the same pattern we used in for the set controls for the player. So I'm going to copy and paste, create a disposable, I guess, small reusable piece of logic function here using this convention. It will play the confirm sound and then go to main. Main is the other scene, which is actual game. And then we hook this up to the various input methods. So on click, on key press, on game button press. All right, so now it's time to write the logic for the actual game. Here, I'm going to create a constant. I'm going to call it score. It's going to be initially have 0. So, yep. And by the way, one thing is we're going to implement the save system right now, actually, instead of writing logic here. In our start scene, so let me just collapse it just to have a clearer picture. So yeah, I'm writing in a very big font so that you can really see the code, but it's kind of inconvenient. So we're gonna have to define our save system. So I'm going to create a file called save.js, which I'm gonna write the logic for that. How we're going to go about saving our score. So the pattern I used for this is something very simple. What I do is I create a function called make save system. It takes a save file name you want to use for the game. And then within it returns an object. This object has first a data property, which contains the data we're gonna save. It's going to contain an async method called save. It's going to contain another async method that is going to be load. The reason those are in async is because we're going to call the Tauri API within, and the Tauri API is asynchronous. So here in our save function, what we're going to do is we're going to call the write text file method from or function from the Tauri API. This is something from Tauri. It takes 3 params. It takes the save file name, so the actual name, the path, or actually the save file name, not the path. And then here, actually it's two, yeah, three, the content, and then the, sorry. So it takes the name of the file, the content, which is just going to be a JSON.stringify. So we're going to convert our data here. So we're going to use this.data into text. And then the final one is going to be the base directory. So the dir, it's an object that you need to specify the base directory, and then app local data. This is how you're going to be able to write the data here to the save file name, which is going to be save.json, and along the base directory app local data. If you weren't to not use this, it wouldn't allow it. And here base directory is imported from here. It's an enum. And app local data is basically like the thing, the folder I've shown you earlier on. All right, that's it. That's how you write to a file. And if the file didn't exist before, it's just going to create it. And if it already existed, it's going to overwrite it. So you might need to append in certain situations, but for our project, we can just overwrite when the score that the player has acquired in the current game is higher than what was written on disk. And then the load function here is we're going to have a try catch, because we might attempt to try to read a file that doesn't exist, especially when the player first opens the game. Well, the goal of this is that we will store into the data property that we created here the actual data. So JSON from the file. So we're going to use JSON parse, which is going to parse the text, the string that we stored inside of our save.json file. So here I'm going to call the await read text file API from Tauri, pass in the save file name, and then the second param is just a dir. So dir directory, base directory, and then app local data. And then if for some reason it's not possible, and this occurs when the file doesn't exist, and it happens when the player first install the game for the first time, or they installed the game in the past, uninstalled it, and then removed the save file from the local folder, then what we're going to do in this case, we're just going to set the data property from within the game to an empty object, and then when we're going to save, we're just going to write to a new file, to the file, basically, to a new file, because it didn't exist. All right, we have everything we want here. So now we're just going to export our save system. So I'm going to have a constant, call it save system, which is going to be, we're going to call the make save system, and we're going to pass in that we want to store this in save.json. So when the player opens up the game, they go to the start scene, and at the end of the start scene, we're going to call our save system. This should be imported from our file, just to make sure save system has been imported. And then here, what we're going to do is we have save system, and then we're going to load. So initially, if the file didn't exist, then we're going to have an if statement, which is going to make sure that if the save system dot data max score, which is a property that doesn't exist yet. By the way, it doesn't exist yet. So I'm assuming, like, we have the player, they open up the game for the first time. That means there's no data. So we load the data from our save system, and this is going to go into the try catch, is going to be catched because it doesn't exist. You cannot read a file that does not exist. That means that the data is going to be set to basically the default. So when we arrive here for the first time after having loaded the data, then the max score property doesn't exist, and this is where we're going to actually set it. So save system dot data dot max score, We're going to initially set it to 0. Then we're going to save that data that we just wrote into the data object to disk by calling the save method, and then reloading it to actually this is not necessary to reload it here, but because we just write the same thing and then we don't need to reload it. So I'm gonna not need that. So here we go. And the reason I'm doing this is just to make sure that if the player opens up the game for the first time, we have actually a max score property that is created in that save.json file. All right. So now let's write the meat of the game, which is the main scene. Here I'm going to have a variable. I'm going to call it score, which is going to increment as the player is surviving and avoiding the obstacles. Now, the next thing I want to do is I'm going to import the colliders data. So I'm going to use an await and then an await and then fetch. And then the reason I'm doing this is to fetch this colliders data. So here I'm just going to do dot colliders data.json, and then once you receive a response here, you need to await the response, and then you need to await again while it is converted to JSON. Usually people do this in 2 calls. They first store this into a response constant and then call .json on it. But I prefer to have it on one line here for conciseness. And then here I'm going to create colliders data, and it's going to be the colliders object .data. And the reason it's .data is that if you look at the colliders data.json, it's a data property with an array, and we were only interested in the array, so that's why I'm storing it as its own constant. And then I'm going to call make background. By the way, this should probably be called at the top. The first thing we want to do, because the background we set here is dependent on each scene. So you cannot have a global background that you can set. Well, actually, you can use the set background, but the issue with the set background is it doesn't respect the aspect ratio, the letterbox. That means that if you call this method from Kaplay, it's going to color even the place where it shouldn't be, like the black bars. So it doesn't respect the aspect ratio. All right, so we have the make background here, and yep. So now what comes next is we're going to use set gravity so that the player is going to be affected by gravity. The value, the G value that was that felt nice was 2,500. Set gravity is a method from Kaplay. So yeah, by the way, if you see still Kaboom context here, it's because it was previously called Kaboom. All right, and then here the logic is going to be very similar to what we had initially. I could have abstracted this into a function. By the way, I noticed something is I called this map. You could have called it level, and then later on in my source code on GitHub, I used level here, which is inconsistent, and I should probably do better. So I'm going to just copy and paste here, so this first part, and just for the sake of consistency, let's use map everywhere because it's the same logic, copy and paste it basically. So here you could create a function that takes care of all of this. I'm not gonna do this just to go faster because the main draw of this tutorial is really to teach you how to have this all as a desktop app, not necessarily the game itself. If you're interested in more like code organization and tutorials where I take care more of that, you can see my other tutorial, watch my other tutorials. So here we have, okay, so I replaced it with map, and then here, we're gonna have the platforms like we did initially here, and instead of level, it's gonna be map. And then here it's different logic. So actually, never mind. Yeah, this is a different logic. So here we also had the platforms. If you go to the logic we had for the start menu, we had clouds, we had the platforms here. But now we need to actually do something with the platforms. That's why I store them inside their own constant. And then here below, we're going to use the onUpdate methods that is called every frame. And here I'm going to make all the platforms move. By the way, the platforms are just a single big image, so it can be treated as a single entity. It's not multiple sprites. So here, the move function, we're going to move to the speed platforms.speed here, and then 0. And then here is going to be something else. So we're going to use the same logic that we used for the clouds. So we're going to have, as long as the position is inferior to a certain value, well, as soon as the platform's position is inferior to a certain value, we're going to replace the platforms to being to the right, and then we progressively increases the speed so that it is a challenge for the player. So here's the comment I left here. By the way, the source code is available on GitHub. It might be slightly different from what I'm writing here, but you can use it as a reference. And then here we have this now, and we can have the loop method, something from Kaplay. So every second, it's going to run the function passed as a second param. And here we're just going to increment the score by 1. Simple way to calculate the score. And then here is where we're going to add the hitbox to all the platforms, or the obstacles. Maybe obstacles would have been a better name, since it's the name of the sprite here. But initially I wanted to make a Kirby-like and then teach you how to use Tauri, but I thought it would be like too complicated, and it's better to isolate and do something simple so that you can be familiar with how to make like desktop games. All right, so here as I said, our obstacles are a single image, and by using the collider's data, we're going to know where to draw the hitbox for each of those obstacles within that image. So we're going to create child game objects of the platform's game object. So here, I'm going to use a for loop for const collider of collider's data. We're going to add for each of them to the platform's game object. We're going to add, so the platforms is a child of the map, and every collider here is going to be a child of the platform, so that their position is relative to the platform, the obstacle image. That means when this image moves, all the colliders are going to move at the same time without any extra logic from our part. And then here, it's the same thing, so I'm just going to copy and paste. Actually, there's one thing different, is static. So here we create a hitbox with a rectangle with a collider width and collider height. This comes from the JSON file, which has these values. We place the position X and Y. This is going to be relative to the platform, the obstacle image, which is what we want. And then here the body, by setting the isStatic property to being true, what will happen is it's going to be solid so that our player cannot pass through, and it's going to act as obstacles. All right, now we're going to need to create 2 other game objects that are going to sit at the top and bottom of the screen. And those 2 game objects outside of the for loop, but still in the main scene, are going to act as walls up and above. So here it's the width, the rectangle is going to be the width of the whole screen. One is going to be placed at the top of the screen, but not visible, and the other as well. And we don't need them to be fixed, since we're not going to modify their position. The player position isn't moving at all anyway. Oh, by the way, never mind. I think actually we might need this. Anyway, let's keep it for now, and then I'm gonna remove it if it's not necessary. I'm thinking of an edge case, but it might not be actually a case. All right, so now if I look at the result, you can see that we have nothing for now, but the platforms are slightly increasing in speed. So now let's call our player. So const player make player pass in decay, and then right below player position, the position that sounded nice, looked nice, was 600 by 250. We're going to set the player control so that the player can start moving. And then we're gonna use Kaplay's onCollide logic. So when this onCollide method available on GameObject is that when the player onCollides with this. So by the way, I forgot to explain what is this. This is a tag. You can set it so that you can use them later on in onCollide calls to check for collisions. So here, onCollide, or when the player onCollides with the tag here. The tag here is going to be the obstacle. So every game object that has this tag is concerned by this method that is going to fire. So basically, when the player collides with the obstacle, this runs. What will run here is first we check if the player is not already dead. So player is dead. Make sure that this is, if it's true, that means we don't run the logic that comes afterwards. And then we play the hurt sound. Then we set the platform's speed to being 0. And because of that, because we set the platform, I don't think fixed is necessary because the player is not moving, so the camera is not moving at all. So let's set it to like that. So platform speed is going to be set to 0. Then we're going to disable the player controls. So disable controls of the player. And then here we're going to have to do and create score box. And then set player is dead being true. So let's play our game. Okay, where's the player? By the way, you can use the F1 key to open the debug mode. Oh, I think I know. Because we called the make player, we didn't add it to the screen. So you need to call it within a add. Because make player uses the make function, which creates the game object, but doesn't actually add it to the scene. So now it should work. So if I go here we go, we have our game. So let's on purpose hit, and then nothing happens. Okay, now if I refresh again using F5 and I go to the top, yeah, so those walls that are not visible are here to prevent the player from going out of bounds. So yep, and here, where are they? Yep, so those are the walls, those two game objects here. Okay, so the last part is really to create the scoreboard. So I'm gonna, the score box, not board. Well, it could be a board. Scored box.js. So here we're gonna have an export function and then make score box. Takes the context k, but it's going to also take a position, I think. Yep, it's going to take a position, which is going to be a vector 2, which is going to have x and y coordinates, and that's it. And oh, of course, one last thing is the actual current score. And now here, we're going to use the save system, and we want to load from the file the save system, because we're going to have to compare to the actual max score. So making sure to read the file that we have saved so that we can do the comparison here. So if the score is superior, the current score is superior to the save system dot data dot max score. If that's the case, then we're gonna put it in the save system max score, the new maximum score, and then we're gonna call await and then save system, and here is actually where we do the saving. So we're gonna call it save. By the way, this should be async, so we can use await. And this is the actual thing that writes to disk. So maybe I should have call it save system.write and read, but I think load and save are pretty understandable terms. So now let's create our box. And here I'm going to use the make function as well. So here, the make function. And the reason I want this fixed though is, yeah, because here it's important to have it fixed, independent from the camera, because depending on where the player is, but actually, never mind, the camera shouldn't even be moved in the first place, so there's no need for that. So here, nothing new, except for the outline component, which creates an outline, and we can give it a particular color as the second param. This is going to be the outermost container, and then we're going to add as child game object the various text we need. So this is something I'm going to just copy and paste because it's tedious to write. Here we go. Let me just go up so you can copy. So this is the previous best score text, which we take from the save system and a given position, etc. Here, same thing for the current score. And then the current rank, which actually we didn't write the compute rank method function. So yeah, let's just copy this for now, those two. Hit pause, and maybe like that. Can't see everything. Now I'm going to go in utils, and the rank, compute rank is just going to give a rank depending on the score value. So here, export function, compute rank in utils, and then you pass in the score. And then depending on the score, we're just going to give a letter-based grade, so the rank. And here I'm just going to copy and paste the logic. It's just a bunch of if statements. Maybe you should have used them. Maybe I should have used a switch case here, but yeah, so if the score is superior to 30, S rank. Superior to 20, A rank. Superior to 10, B rank. Superior to 2, C rank. And D if you have 0, 1 or 0. And that's it. So now if I go back to the scoreboard, score box, let's import the compute rank. Import compute rank. And yep, so now it should compute it. So if I play the game, by the way, I did not call the scoreboard, but we haven't finished. We need to do the following. We need to create the restart button and the same logic for the restart button, and then return the container, which is the whole parent of the box. So here we have this restart button that as a child of the container as well, which is going to be a rectangle with this color, and then it's going to be drawn from the center. Nothing new here, no new concepts. And then here, as a child of the restart button, I'm gonna have the text play again with the following size, etc. And then here I should have followed. This is just a real reusable piece of logic that isn't used elsewhere. Actually, it is used elsewhere. It's not the first time that we have something like that. But I think it was different every case, right? Here it's jump logic, and I think it was used where it was used. It was used here, right? Go to game. So maybe this should go. So we have this here. Let's take this. Let's go to utils. Let's create another utils. Let's write it as a proper function. Well, they're both proper function. I mean, like with the function syntax. Let's go back to main. Let's just... the issue now is that we need to use an arrow here. And then call and pass in the K. And then an arrow here. And then pass in K. And then an arrow here. And then pass in the K, because we don't want the function to be called immediately. If you were to pass it and it would be called with the parenthesis, it would call it immediately. But we still need to pass the context, so that we need to wrap it inside of an arrow function definition. So that's that. And then at the above, let's go to utils here and add it. Go to game. That means in our score box, I can just remove that. I can go above. I can import it, go to game. Here we go. And here we go. So we have the on clicks, etc. So on key press, the various inputs. This again could be abstracted away, but I want to keep things simple for this project. And then finally, we return the container, which contains everything. So the whole score box. And then in main.js, if I scroll down in the to-do, we're gonna call k.add score make score box, pass in the context, pass in the following position. I don't remember the actual position I used. At the end of the day, we just pass in the center, k.center here, position, which is, well, I should have probably hard-coded it here in score box if it's the center, but imagine in a future use case where we want to display more components like that score box in various different places. So it doesn't hurt, I guess. And then finally, as a third param, the score that we had in main here. We had defined it above here in our main scene. All right, so that's basically it. And now I think our game is done. Yeah, I think our game is done. So let me check. Okay, we have a mistake. Does not provide a go-to game score box.js. Utils does not If I go to utils, go to game. And then if I go to the score box. Okay, because we need to wrap it under a arrow function. I'm just going to copy and paste this. Save. All right. Now things should work. Yeah, so I didn't read the proper error message, so what's the issue? Syntax error. The requested module source utils.js does not provide an export name go to game. Is that true? Yes. Export. Sorry, I missed that. Now if I go here, we have our game. And then let's die. And okay, what is that? A W trigger is not a function? What do you mean? Okay, I made a mistake somewhere. Oh, I know why. If I go back to main, here, remember this was an await. Here we return a promise, so it's trying to add a promise as a game object. Doesn't work like that. So we need to use await here. Okay, wait a minute. Only allowed within async function, but this needs to be async. So the scene itself needs to be async. Not the scene. The on collide callback. So that means we don't need to have here as async. We need, because we needed to make a fetch call to the JSON file, which contains the collider data. All right, so I think that's it. Previous best score 3, current score 1, previous best rank C. So let's try beating our score. Here we go. We have CC as the rank. Okay, let's try for 20. At the same time, we're gonna test a few things. So, all right. 15, current rank B. So next time, if I die here, previous best score 10. Okay, it's not doing it right. That's probably due to the fact that I did not load it in the main, in the start, scene. If I go to where I set up the save system, I did not load the save system here. I need to load here as well. Now the last part of the tutorial, it's basically getting the executables, getting ready to distribute the project. So I'm gonna close the project, and then you're gonna write npm run build. So now it's going to build the project. gonna compile. And this is going to take maybe a lot of time at first. When you do it for the first time, it's the first time building the project. So let's wait. All right, it's almost done compiling. And as I said, this compilation step takes a lot of time the first time you do it, but then it's relatively quick afterwards. So now there's only one thing left. And here we go. Running and then producing the MSI, which is what is useful to distribute. All right, the project has been built after a long time. Now, to get the executable, you can go here to source.tari, target, and release. And then in bundle, this is what you want to distribute, either the MSI or the NSYS. So either one of those two should be fine. The reason I want you to distribute these instead of the kirby.exe file is that these are installers, and if the player is either playing on an older machine and doesn't have the WebView 2 system installed on their machine, then the installer is going to take care of installing it for them. All right, so yeah, just distribute that on itch.io or Steam, either one of them, and that's it. This is how you make a desktop game in JavaScript. All right, thanks for watching. I hope this tutorial was useful for you, and yep, that's it. Feel free to subscribe for more JavaScript game dev related content. Bye. I forgot to mention something very important in the project is that if you want your executable, so once the Tauri app is installed, so when your game is installed on a user's machine, if they hover over it and this short description property is not defined, it's going to display a Tauri app. And I would assume you want a description of your project to appear and not a Tauri app. So to have this description, you need to go to tauri.conf.json and then under the bundle, add the short description and your description here. So that's all.